She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking, Ethernet whiz. Found her at a bullet hook, sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange drools over slow motion duel. Her shield's a disco wall, fracturing legs, grass, shooby-doo-bop crack. That lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bluff the corn's grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Architect with a buffercorn's grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with for do with for do with do with do with do 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 do. You ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it.
Good morning. I guess good morning to ETH Denver. Thank you for those of you who woke up this morning and have had coffee in time to be here. I think it's going to be a really long week, but hopefully a great one. So thanks for showing up bright and early on Monday morning. I'm Jess Holgrave. I'm the CEO at Reown. Reown is the company behind WalletConnect, which many of you might be familiar with if you've been using any crypto app over the last 6 or 7 years. And today I'm going to talk mostly about user experience, because we at WalletConnect and at Reown believe that this is one of the major barriers to true crypto adoption and bringing more people into the space. At Reown, we've been around since 2018. We relaunched the brand last year alongside launching the WalletConnect Foundation. WalletConnect has been around since 2018. It was designed originally to solve one of the first user experience challenges within Web3. This was at a time that we had the emergence of mobile crypto wallets for the first time. But the majority of applications, still today, unfortunately, although I think that's changing, the majority of applications were built on desktop. And so the WalletConnect protocol was designed that I could really easily scan a QR code with my mobile wallet, connect into the application to be able to do anything and everything on that application. Today, the network supports over 700 different wallets. I think we have something like 57,000 different applications registered on the network, although not all of them are still alive and kicking, but certainly we have well over 6,000 daily active applications using the protocol. Last year we made about 220 million connections between users and their Web3 apps, and at around 35 million unique wallets. So we have this really amazing insight into what drives users, what people are interested in. And for me, this has been like a really exciting new challenge to take on. I joined the company about 18 months ago. Before that, I was running crypto at a payments company, and a long time before that, had a startup in the NFT world. And when I was building that, this was in a pre-WalletConnect world. We just had the MetaMask SDK. We were trying to figure out how new users were going to get onboarded. We were doing a lot of work with artists and having to educate them about what a seed phrase was, what a wallet was, all felt like a massive distraction in terms of bringing people into this space. And I think we've made good progress, but I don't think we've made enough progress there. And so today I'm going to talk to you about some of the things where we think that there are still big user experience challenges in Web3, and some of the things that we think are helping to solve those as well. This is a video that, due to some technical issues, plays at 2 seconds, so we're not going to watch that. But I am going to talk to you about some of the things that we're building. So aside from the WalletConnect network, which today is supported by 16 different node operators and is truly running in a decentralized fashion, we launched that last year, which was one of the big kind of aspirations for WalletConnect over the long term. So we're really proud to be decentralizing the network and handing over the stewardship of that network to the WalletConnect Foundation. You can find Pedro, the founder of WalletConnect, who's running the foundation here on a few stages this week. You can also find us all at WalletCon on Wednesday, which is our developer conference. But aside from that, we really now focus on 2 major SDKs. One is called WalletKit. This is an SDK for wallet developers. First and foremost, it gives those wallet users access to the WalletConnect network, which means they can connect to any different applications on the network. It also has a bunch of security features in and user experience features like chain abstraction. And then on the AppKit side, this is an SDK for app developers used by some 3,000 different app developers today across all different networks. Everything we do at WalletConnect is multi-chain and supports different networks. And within AppKit, app developers can find a really easy toolkit to let users log in, sign messages. We have an on-ramp, an embedded on-ramp, embedded swaps functionality, embedded smart accounts, and social and email logins for those new users that we want to be onboarding. And so this is really a comprehensive kind of toolkit. And so within these 2 SDKs is how we're delivering a lot of the advances that we think that should be brought both to Ethereum but also to the broader crypto community and builders at large. Today, I think we have a challenge, which is that we've spent a lot of the last few years really investing in infrastructure. We're now at the stage, or nearly at the stage, I think, where we have these very scalable systems. We can manage large numbers of transactions very, very quickly. But for me, Ethereum is still kind of designed for the power user. I've done it several times in the last few years where I've onboarded a new friend. And I think back to like when I was starting to get into crypto, and I was super happy to go through all of these challenges, right? Like thinking about where I was going to put my seed phrase, how I was going to store that safely. I was like happy to download 5 different apps just to find one that actually worked and that was intuitive. But the reality is that like I was doing that because I was excited about Web3. And the vast majority of users who we want to be able to deliver the benefits of Web3 aren't interested in Web3 itself. They want usable systems. They want things that bring joy to their life. They want things that make them money. They want things that solve pain points for them. They're often not interested in the core principles of Web3. And so my belief is that we need to get these people in because we deliver something that they want, and it's only through that we're really going to get people excited about what Web3 is all about in the first place. And so this idea that we can still rely on some of the old onboarding methods and people are going to need to learn about the technology itself, for me, feels very antiquated. Every single person in this room, I imagine, has a credit card or a debit card in their pocket. But very few people understand the ins and outs of payments acquiring and merchant processing and card issuance that sit behind that. And that's because you shouldn't have to. You just want to use your money and buy shit. And the reality is in crypto today, we're still at the stage, this idea that in order to have a credit card, you need to learn how payment systems work. And so we have a big gap here to be designing for the average user, which a lot of people claim that they really want to be onboarding. We are really lucky to work with hundreds of amazing app developers, and every day we see these unique projects coming online, but they're still thinking about them as crypto users rather than as everyday users who just want to use an application. when we think about like UX more broadly, this shouldn't come as a surprise to you. We looked at like UX comments, and you can see from some of these things that people, even those of us who are in this space because we love it and we want to be building it, find the user experience challenging. We all think it sucks, but very few people are really invested in making it better. So today, when we were coming up with like the title for our report, for this presentation, we were a little bit inspired by a consumer report that we put out last year. And actually, I just got some of the preview results for the 2025 report this morning. So that will be coming to you all in a few weeks' time. But when I look back at the 2024 report, for me, it feels that there are still some major issues. And these are experienced crypto users. These are people who've been using crypto for 2 to 3 years. They have multiple wallets. They claim to be using crypto applications on a more than weekly basis. And yet every single one of them finds that there's major challenges either around security, user experience, fees, speed, how to onboard people. And so the title for this talk, we decided it was going to be the good, the bad, and the ugly. And so I'm going to talk you through some of the good and the bad, and I'll finish with the ugly, which is really my call to action for how we can all make this space better. Firstly, I think we have an issue that we created that solved one massive problem. We solved the issue of speed and scalability on Ethereum, but we created a new problem for ourselves. That's one of fragmented liquidity. At Rion, we do a lot of work with payments companies, and these are people who see value in crypto. They want to be able to bring crypto payments to the masses, merchants who want to be able to accept crypto as payments. They know that people want to be able to do that. We've seen the rise of stable coins over the last few years. And yet then you start doing user interviews and you say, actually, you can only pay with your USDC if it's on Solana. By the way, your USDC doesn't really count if it's on Arbitrum or it's on Optimism. And users are like, hang on, this is painful. Payments companies are like, what on earth? This doesn't make any sense. If I just have US dollars, why can't I use it? And so this liquidity fragmentation is a massive issue. The good side of this is that I think we're getting there in terms of solving it. We have amazing partners that we've been working with, including Socket, Across, Leafy, and many others, and we see hundreds of different solutions coming out. The Ethereum Foundation's been doing work in terms of its interop standards. And so I think that probably by the end of this year, we'll be at a stage where a wallet can manage assets over different chains, and we will be in a situation where as a payments company, I can just accept USDC. My user can have USDC on a different chain, not the one that I necessarily want to manage, but we can solve those in single user op and single intent processes to make that payments flow simple and to enable users to use their assets on any chain. The next big one that came up, and I think this is where we've also made great progress as an industry, is those dreaded seed phrases that we all have to manage. I think that there's huge scope for having many different types of wallets. That's one of the things that we're very pro at WalletConnect. We work with 700 different wallets, and I still think that actually there's scope for more. And when people say, why do we need more than 700 different wallets? For me, that's because we need different wallets to do different things. I, as an end user, don't want the same user experience in the wallet that I use every day to buy coffee as the same wallet from a security perspective and a user experience perspective that I want to store my 401k fund in. And so we do need different types of wallets. We need different user experiences when it comes to wallets. But those seed phrases, especially for new users, are incredibly complex to manage. I think something like 24% of the people that we surveyed last year said that they had lost seed phrases or lost funds due to having to manage seed phrases themselves. So I think that one of the positives that's come out of the last 12 to 18 months is the evolution of not only Google and social logins to be able to create wallets at the back end. Amazing companies like Privy, Magic, Turnkey, Para, who used to be Capsule, many others who are really solving these problems, but also those of smart accounts. So that now I can use pass keys as signers on my accounts and set up different permissions associated with them, which for me is like the third bad thing. How do we actually go through the process of using our wallet? How do we have to sign things constantly? If I'm in a game, I don't want to continuously go back to my wallet to repurchase every time I want to take an on-chain action. If I want to do a subscription payments today, I either need to give pretty unfettered access to my account and my keys to that payments company to manage it, or I need to move those funds into some sort of escrow smart contract, which kind of defeats the point of me having them in my wallet in the first place. And so I think that the evolution, and we'll see this with Pectra as it comes in, I think in first week of April is the latest rumor. The smart session standards that can be used with smart accounts, something called 7715 that we wrote with a bunch of other partners in the industry, allows us to create this idea of a smart session. So I can set a policy on my account. I can give access to a specific app for a specific period of time up to a certain amount, so that I can start to use my wallet in a much more sophisticated way. I no longer have to just give this broad range access and keys to partners, but I can say, in a specific game, I'm going to spend up to $20 a week, or I want to pay my Netflix subscription actually with crypto, and I can do that by using smart sessions and making sure that that company and only that company can withdraw a specific amount from my wallet on a regular time schedule. So I think this, for me, is probably one of the greatest advances of 2025, and I'm very excited to see some wallets already adopting it and more apps starting to experiment with it. The next thing is around security, and probably this is on everyone's mind after some of the events of last week, unfortunately, is that we still exist in a world where it's very hard to know what we are signing. It's very hard to verify what contracts and what domains we're interacting with via our wallets. And this creates a huge problem not only for all of us who are trying to use apps, but also externally for people outside of the industry who continue to view this space as one to be scared of. I remember having a conversation last year where somebody said, we just need to do more education. And I agree that education is good, but again, if you imagine me giving you a credit card for the first time and then saying, right, now you have to go through a 2-hour course on why and where and how to use your credit card safely, because by the way, it's probably like a 1 in 4 chance that you're going to lose all the money in your credit card. This would be a terrible user experience. People just wouldn't use credit cards. And we have to think about wallets in the same way. We need to give people the tooling that makes it really, really easy for them to use wallets in a safe and secure way. One of the things that we've built at WalletConnect is the Verify API. So this confirms which domain you're interacting with, and all of the wallets on the network now will flag if you're interacting with a malicious domain. We're expanding this program later this year to include to include contract verification and other things. And I think also want to commend the work that Ledger and other partners are doing on things like clear signing, so that I can actually understand the transaction that I'm about to sign, using tooling like Tenderly or Blockade to simulate those transactions really well before I execute something. We know that that's still not perfect, and there are other things that people should be doing. But hopefully, I think this, if anything, if any of the events of the last week have done is actually heighten people's focus around security, and also acknowledge that despite the fact that this is we want to build interoperable things, we want to build open systems where anyone can do anything, it still is kind of our responsibility as the builders to think about the people who are using our products and to make sure that they're safe while they're doing that. And finally, I think we still exist in a world of too many clicks. Less clicks is more is one of our mottos at Reown. And one of the things that we're asking all of our wallet partners to do this year is to upgrade some of the message signing that exists as part of the WalletConnect network, so that I can take single auth and sign click requests. I don't have to keep moving between an app and a wallet. And combined with smart sessions, I think this will help us to move into a much smoother user experience. But having said all that, I think it doesn't really matter how much tech we build if people don't want to use it. And so my ugly for you today is the fact that even if we build this tech and we solve these bads and we turn them into goods, we still need to make sure that people want to actually start using these things. And to do that, we need to, A, encourage application builders to want to be using this technology. And we need to have more of a focus on the user experience. Some of the initiatives that we launched through the WalletConnect Foundation last year in terms of UX include the establishment of the UX Council. This was the first vote that the WalletConnect community passed a couple of weeks ago. So we're welcoming some 35 of the industry's top experts around user experience to join us as part of stewarding the network going forwards to really think about what user experience is and what we should be delivering to end users. We launched last year a program called WalletConnect Certified. As part of WalletConnect Certified, we invited the top 20 wallets on the WalletConnect network to go through a rigorous QA process and to adopt new and better user experiences for their end users when it comes to both security and ease of use. And we're expanding that program this year to include a bunch more wallets, so hopefully encouraging the whole industry to have more of a focus on UX. And that's not to say that wallets don't. I just know that many of them they need to make money, they need to attract users. But we believe that by really focusing on security and user experience, that will benefit them and their end users over the long run. And finally, the WalletConnect Foundation announced a large user experience grants program. We've welcomed some 8 participants now into the Smart Sessions subcategory of that. So if you're building with Smart Sessions, please let us know. We'd love to support you on that journey. We also have grants available for things like building on chain abstraction products and many other things. So overall, really what we're trying to do here is establish a center of knowledge sharing, of building in the open, and of working together to improve user experience. We need that. We need better designers. We need more people to start thinking about user experience. And ultimately, we need to start making this usable if we really want to attract all those people that we claim to do. That's it. I'm being flashed to say wrap it up. I'm here all week. I'm speaking again on Thursday. And on Wednesday we have WalletCon. So if wallets are your thing, please join us for that event as well. Thanks.
Tears, call me well connected, I call it drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. Watch the rock on PI. Get homemade in 7/4 time. Shaboom goes the efficiency pulse. The
Hello. My name is Hari, and today I want to talk about how to build safe and successful Web3 protocols. First of all, why am I talking about it, and why should you listen to me? So I used to help build the Solidity compiler or the programming language a while ago. I'm one of the founders of Spearwood and Cantina. We are an industry-leading security company working with projects building in crypto. And because of that, we have worked with over 250 customers directly, and we have interacted with over 1,000 companies building in crypto. And we've seen it all when it comes to building and deploying smart contracts and building your own protocols. We work with people all the way from young startups who are trying to build a massive protocol, all the way to people like Uniswap, Coinbase, all the big players. And I want to share a lot of thoughts based on what we have seen, what works and what doesn't work. So let's start talking about one way of building things, which is very common in the Web2 space, which is build fast and break things. And this is something that really was popularized by Facebook, because they had this philosophy of shipping fast, moving quickly, even at the expense of things breaking. It's very common in Web2 startups, as I said. But this doesn't work in crypto, unfortunately. And the main problem it doesn't work in crypto is because of security. If you're a founder building a protocol in crypto, the moment you have assets or value in your protocol, you will have black hat hackers that is looking after your protocol, trying to find bugs and steal money. I don't want to sound alarming, but this is the reality of building in crypto. The moment you have use of funds, there are malicious actors who are trying to steal money. This is not the case in Web2 companies. And I want to highlight this by saying that Web2 hacks are not catastrophic. And I want to talk about an example of Retool, which is a $3 billion company. It's a very successful company. They sell an application that connects with your database, and they will help you build dashboards and other UIs without using much code. So a lot of companies, including many companies inside Fortune 500, uses Retool to build analytics or simple tools for admin dashboards. They had a compromise. They had a hack back in 2023 where an employee was spearphished and a malicious actor was able to gain access to all their systems. This is the worst of the worst when it comes to Web2 hacks. Your entire system is compromised. Turns out that all the sensitive data was leaked, and in Retool's case, what you're giving Retool is access to your own database. So imagine you being a Fortune 500 company, and you give access to your database to this other company, and now that company get compromised, and now your database is also compromised. This is exactly what happened with Retool. But fortunately or unfortunately, after a single month of the hack, it was business as usual. Retool is still alive and kicking. It's a very successful company. Nothing really happened to them except for the fact that, okay, they had to make a public disclosure. Maybe they lost one or two customers, maybe they did not, but nothing really happened to Retool as a company. On the contrary, if you look at Web3 hacks, they are catastrophic. A single hack can end your company. To give an example, I want to talk about Nomad. So Nomad was a multi-chain bridge, which was built by a very highly technical team of engineers. It was one of the best teams out there when it comes to building multi-chain projects. And they had a single hack where there was a simple bug in one of the smart contracts, and they ended up losing $190 million. They ended up recovering some of it, but the initial impact of the hack was $190 million. And this hack killed the company. The company doesn't exist anymore. And that's a good comparison to Retool, where a similarly catastrophic hack happened for the company, but it's still alive and kicking. In fact, if you look at what the hackers did with Retool, they tried to go after their crypto customers. They didn't even try to go after their Web2 customers. They tried to see which companies in crypto ended up using Retool, and they tried to see how much information you can extract from this crypto companies' databases. So that is the kind of like sophistication that a lot of hackers in the space are going after. Even when they hack a Web2 company, they're going after their crypto customers because that's where the money is. So I know like these big hacks become very public, but there are often like small hacks that doesn't really like come up in public. You have to be in the industry, you have to be in security space to understand these smaller hacks. These smaller hacks also kills the companies. If you choose to continue as a product that underwent a hack, you often have to like fill the hole with your own funds, or you have to like shut it down. There is like no other way to continue if you are a small company that had a hack. So this is the biggest difference between like building in Web 2 and Web 3, where a single hack can kill your company. So moving fast and breaking things, it doesn't work. So let's look at the complete opposite of like moving fast and breaking things, which I call as moving slow and not breaking things. Unfortunately, this also doesn't work, and I'll tell you why. So we speak with a lot of customers building in crypto, and the number one feedback we get after these customers go into mainnet is that they often learn more about the problem they're trying to solve in like 1 week of going live than like spending 6 months like building. This is such a common problem if you're a young startup building in crypto, building a new innovative product. The best way to learn about the market and your users and your problems you're trying to solve is to ship something out there. And if you fall into this trap of like spending months and years building without really like getting real customer feedback by going into the market, you're probably building something that is not correct. So we see this common pattern among like customers we talk to, which is that the second version of the protocol is oftentimes the protocol they wanted to build initially. So I want to now talk about what does it look like, what does success look like when you're building in crypto? And I want to bring like an extreme example, which is Uniswap. So if you look at Uniswap v1, it is a protocol that was extremely simple. Uniswap, for those of you who don't know, it allows you to swap from one token to another token. Like you can have like USDC, and you can buy ETH using Uniswap. So Uniswap v1 was dead simple. You can swap Ethereum for one other token. That's it. That's all it did. Of course, like if you can swap from Ethereum to another token, you can now also swap from one token to another token, because you can go through Ethereum to do that. So, but the way Uniswap v1 implemented it was like having like a single swap, and they like kind of like made like two swaps work by batching these calls. If you look at Uniswap v2, now you can swap between any pairs. You're not restricted to like Ethereum pools alone. You can have a pool of say USDC and USDT and swap between the two without dealing with Ethereum as an intermediary asset. So anyone sitting here who is trying to get better at building a protocol, I highly recommend you check out Uniswap v2. It's an extremely well-designed protocol. It's very, very simple. And that's the reason I want people to check it out. It's very, very simple. And Uniswap v3 ended up increasing the efficiency. If you look at Uniswap v2 and the pool I just talked about, which is USDC and USDT, turns out that it wasn't very efficient to do swaps this way. And Uniswap v3 improved on this by making stable coins and other things to be more efficient. And Uniswap v4 ended up shipping better programmability into the Uniswap protocol. So if you look at the evolution of Uniswap protocol, it started off as something extremely simple, and they realized that, okay, they have clear product market fit with their problems, and they clearly understood what their problems were. For example, that it wasn't efficient. And they ended up shipping like newer iterations that solve more and more problems. And now I want to talk about a framework for shipping secure and successful crypto products, which is based on like our experience working with all these customers. First of all, you have to ship fast. There is no other way around it. But you also cannot break things. So I think the best way to do both is by shipping your V1 by stripping down as much as possible. So the question I tell founders these days, like, what is the absolute minimum set of features that you have to ship that you believe the users want? And then try to build something that's like less than 50% of what you believe is the absolute minimum features. This is the level of like stripping down that you have to do if you're building a protocol that is at the V1 stage. And then security is important. But if you have a small protocol, it means that it's easier to secure. You don't have to like invest a lot of time, money, and resources into security when you are small. So you can get a security review with one or two security searches. You can do a security competition. You can also like host a bug bounty program. None of this will break a bank, unlike like building like a massive protocol where you have to now invest a lot of resources into security. And think about building a V2 with more effort into engineering, more effort into security. Like the protocol that you want to ship is the V2 protocol. It's not the V1. So this is the mindset that I want more founders to have when they're building in crypto. And in my opinion, from our understanding, this is going to help you ship safer and also like be successful building a product in crypto. And now I want to like, share some general advice, general thoughts on like what I just said. Okay, first of all, this advice is most relevant to like 90% of the startups building in crypto, because we talk with a lot of companies building like new and innovative products. But if you are building a product that already have like an incumbent player, you probably need to like ship something that's already better than what's out there. So if you're building something that already has like a competitor or like an incumbent in the market, you probably have to ship something way better than them from day one. But if you're building something new, you're much better off shipping something small and starting off there. The other thing I want to talk about is that building a protocol is very hard. Solidity is very simple. Solidity is a very simple programming language. And it's very like deceivingly simple. You think it's simple, but turns out that there is a lot of nuances that you did not take care of. Compare that to like building like a CRUD app, which is like, okay, you build like a Web2 application which has to deal with a database, some authentication, some APIs. Building a Solidity contract is like 10x harder, even though it doesn't look like that. So I want you to get into this mindset that what you're building is actually like harder than it looks. And the last thing I want to talk here, which is very controversial, is that starting with upgradable contracts are okay. If you listen to people on crypto Twitter, you would often hear a lot of idealism about like how you should build protocols. They would tell you that you have to decentralize everything. There shouldn't be any like admin functions. But these are often relevant to like protocols at the end stage of iterations, not at the beginning stage of the iteration. And I see too many founders who fall for this trap of like listening to like how your protocol should like end up instead of like how you should start building. So it's okay to have upgradable contracts, but make sure that you put some effort into securing these private keys that are securing any admin functions. A mistake I've seen some founders make is that they may have like a private key that's lying around in their laptop as an environment variable, and sometimes they get compromised, and it's just very easy to like upgrade and like steal user funds by doing that. So there are some risks to it, but the risks are easily manageable if you use a multisig and don't screw up your OPSEC. So that's mostly it for my talk, and I just want to like summarize the point I just mentioned, just so that everyone gets it. So moving fast and breaking thing, it doesn't work in crypto. Security is the big problem here. Security issues can kill the product. If you're shipping something with user funds in it, people are going to come and try to steal it. I don't want to sound alarming, but that is the truth. Moving slow also doesn't work. You'll have a harder time building a successful product if you're taking a long time going to the market. The reality is that you probably don't know what your customers want until you ship it. And I want to propose a framework to build and ship successful product, which is ship something for the V1 that's extremely simple. Think about Uniswap V1, extremely simple. Think about what is the minimum number of features that your users want to have. Try to ship something that's like 50% there. You probably are overshooting at day one. Think about V2 being the real launch of the product. And once you go from V1 to V2, you can scale your engineering, you can scale your security, you can scale your bug bounty program, you can do all these other things by the time you're getting to V2. That's all for my talk. We have a few more minutes, so I'm happy to take any questions if you have. I know there is not a mic, so you have to shout. Okay. Okay, the mic is coming.
I'll just hold it.
Yeah, hi. What do you mean by stripping down your V1?
So the mistake I think a lot of founders make is shipping a V1 with a lot of features. And you probably need to ship fewer features than you think for your V1. And like, keep it simple. Like I said, like, think about what is the minimum number of features that you have to ship to make the product useful for your users. And you probably should be shipping only like 50% of it. So does that make sense?
Yeah, I so agree with you, especially on the security part, like especially for protocol companies, the security can kill the company. So on your view, like at what stage should a company have a dedicated secure member, secure engineer, or secure team, like full-time dedicating on make sure that this doesn't kill the company? Yeah, like to hear your view.
Okay, that is a great question. And I think the answer varies like company to company. So if you look at Uniswap as an example, I think Uniswap started having a dedicated person after they shipped V2. So around like V3 time, that's when they started like thinking about having in-house security people. And in my opinion, like that is the stage where you need to start thinking about like having an in-house CISO or like a security team. You can get away with a lot in V1 if you can get some external help. I would say for V2, like invest a lot more into security. At V3, better start thinking about like having an in-house security team, because today the threats are very different. Today people are trying to compromise, your laptops. I mean, you know what happened with Bybit. Like people are gonna come to like, hack your laptops, hack your devices, and when you are a large company that manages a lot of user funds, there are usually ways to like compromise it. So like definitely after like having clear product market fit and a bit after like, your V2, that's when you start thinking about in-house CISO.
Hi, Hari. You mentioned, I got some echo here. Dropping the phone. You mentioned you have 6 months in development and that would be too slow because you would hit your customers and you would get people engaged on it. What is, in your experience, the timeline from V1 to V2 that would make it a
So
acceptable?
I think V1 to V2 you can invest as much time as you want. Like I've seen protocols invest like a year from doing this transition, but the goal really is to ship a V1 where you can really understand from your customers. What I've seen people do is like they spend a lot of time shipping this V1, and in 1 week of shipping this, they learn that okay, all those features that they thought users wanted, that's not what they wanted. They wanted these other things. And I want you to like spend as little time as possible in V1 and invest time after V1 really understanding what people really need. Because before that, you're just guessing, to be honest. So it looks like we're at time, but I'm going to be around the event if you just want to have a chat. But yeah, I really wanted to talk about this after like seeing a lot of companies making the same mistakes over and over again. It's expensive. It's not going to help you become successful. And in my opinion, if you use this framework, you're going to have far more success and far less like issues with security. Thank you.
We're not just dreamers on chain truth, no middle. Yo, we pity-let the city on sports and chains. We pity-let the city with regen brains. We pity-let the city on sports and chains. No rug pulls, just pure on-chain. If you faded, just stay seated. The Etherverse will leave you heated. We don't need your legacy, cause regen memes are proof-of-brain. We let the city on sports and chains. We let the city with regen brains. We let the city on sports and chains. Rolling up and slapping chains. She's a Colorado comet in code forged steel. Wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking, ether night whisk. Found her at a bullet hook, sucking down APIs. Armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while lag run drools over slow motion duel. Her shield's a disco wall, fracturing legs, grass. Shooby-doo-bop crack. Ooh, that lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bluff the corn's grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Da-da-da-da.
All right, hey everyone. My name is Michael,
And I'm John.
and we are both auditing engineers at QuantStamp, a Web3 security firm. So today we're going to go through a little more of a technical talk, and we're going to lead you through some easy to miss Solidity bugs. First of all, obviously security is super important. I think as some of you guys saw from the last presentation, we've gone through some of the security concepts of how to develop things from a high level. We want to dive into some very specific Solidity bugs that we can look at from actually real world audits. So everything that we go through today is actually going to be from an audit that we have done, and then we have simplified the bugs and tried to boil them down into a couple slides that we can share with you guys. Obviously, in any security sense, in the Web3 space especially, we have lots of money at stake, reputation at stake, and so it's essential to avoid bugs at all stages of the process in order to prevent losses and prevent reputation damage. So yeah, the goal of this presentation is 100% to get people aware of bugs that are lesser known, but still very common and very easy to miss in our security reviews.
Yeah, so before we talk about easy to miss Solidity bugs, just to give a little background here, like we consider some bugs to be easy to find. And these are bugs that usually you cover in the beginning of your smart contract career. As soon as you begin an auditor, one of the first things you'll do is open Zeppelin's Ethernaut exercises, which cover a lot of these easy to find bugs we have mentioned here, like reentry risks, proxy misimplementations, on-chain privacy issues, signature replay, etc. Those things are pretty well known and standard. They've been around for a while, so these bugs are well known and shouldn't really be leading to hacks in new products. Additionally, we consider easy to find bugs anything that can be detected by a static analysis tool such as Slither. So this category of bugs are bugs that we consider easy to miss. So during the line-by-line manual audit process of a security audit, these are bugs that maybe at first glance they appear correct, the logic looks correct, the logic looks sound. However, due to nuances either in the Solidity language or the EVM or networks themselves, this can lead to significant issues down the line.
All right, so the first issue that we're going to dive into is opcode functionality on various EVM networks. A lot of developers, especially first-time developers, are going to look at the EVM and Solidity, and they're going to dive right in, developing based off of the current state of the Ethereum mainnet. And unfortunately, with how everything is going right now with L2s, not every network is 100% EVM compatible. And so there are opcodes and lines of codes that will work in one way on one chain and another way on a different chain. And so you have to be completely aware of this kind of situation. So a good example here is the self-destruct function. This is actually being deprecated, so I wouldn't really recommend using it anywhere. But on Ethereum mainnet, it will no longer destroy your contract. It will just return all of the ether to you. However, on an L2, this might actually do nothing. The opcode will be dead and just revert. And so if you were expecting to be able to withdraw all of the ether from your contract using self-destruct on an L2, and you had it audited and say didn't tell the auditors that you were expecting to deploy it elsewhere, you could run into a situation with locked funds. So there's a few different solutions for how you could go about avoiding this problem. One that we have displayed here is using the chain ID as an indicator to show how you want to operate on different EVM chains. So for example, if the blockchain ID is 1, you're on Ethereum mainnet, you may want to just call self-destruct and get your ether back, even if it doesn't destroy the contract. Maybe on an L2 instead, with a different block ID number, you want to call transfer to move your funds out of it. Another way you can do it is to have different versions of your project for different chains. I think this complicates the process a little bit more. And then finally is kind of a allusion to one of our papers that we've done recently actually was about a pre-compiler step where you would pre-process your Solidity to produce a gas-efficient version of it for each chain depending on different opcodes that might exist there.
Yeah, so this bug is really interesting and kind of inspired this talk. This contract is a very simple staking contract where the user can deposit funds. However, the issue is very subtle here in the fact that the starting stake variable is declared in the memory space of the smart contract, and the total staked, which is actually the smart contract storage itself, never gets updated in this line here that we're pointing to. So as an auditor, just really be careful about local variables and where they're existing in the smart contract storage. And as a dev, please double check that the contract storage itself is actually being updated. And this is quite easy to miss because it seems like you're taking the user's message.value, updating it to starting stake, but this total staked variable in the contract state itself never actually gets updated. So the fix here is pretty straightforward. You would usually only use a local variable for intermediary operations like we see here, calculating the net user stake. And then the contract state needs to be directly updated itself. So after the stake does take place, the total staked would be reflected in the contract state.
All right, another instance that is kind of the inverse of this one is using storage variables in a function when you shouldn't. So in this instance, we have a staking contract, and we're going to say that we have a struct, which is used to determine how much ether needs to be withdrawn from the contract. In this bottom function here, we have the process unstake, where we're going to take the unstake request and store it in a variable within the function. And the bug here is that we use storage instead of memory to store that struct. So when we grab the request, we're storing it. We're not actually storing it in a memory variable in the function. We're just having a pointer that looks at the storage in the contract. So on the next line, when we delete the storage request, we are actually going to get to this third line where we're supposed to send the funds, and it's going to be completely zeroed out. So you have to be very careful about where you choose to store things in your contract. So the obvious solution, which may be a bad fix, would be to let's just reorder the lines. If we delete the unstaked request after we withdraw, then it should be fine, right? Well, this actually introduces one of our easy-to-find, well-known bugs, which is a checks effects interaction violation, which introduces a reentrancy bug. So you would need something with this, like a reentrancy guard, to actually prevent this from causing lost funds. A good solution to this would be to just store the request in a memory variable. So now instead of just pointing to where the values are in storage that we want to withdraw, we're now creating a copy of the values, putting it in the stack, and then we can use that value even after it's been deleted from storage to withdraw the ether.
Awesome. So this bug involves incomplete struct initialization, and we see this come up in our audits oftentimes in complex contracts that need to define something like a configuration struct that has many different fields. So in this contract, we have another staking contract, and in the constructor, the intent of the developer here is clearly to initialize all fields of the stake config to these default values. However, it's a little easy to detect that the stake boost wasn't assigned in the stake. And did I say easy? It's hard to see that. Sometimes, right, you can't see that if there's a lot of different fields. So what ends up happening is stake boost is going to default to that 0 value. And as soon as the user stakes, they're actually zeroed out the funds that they've sent in, which is clearly no good for anybody trying to use your product. So a good fix here, there's 2 fixes, right? So instead of assigning using dot notation for the struct itself, you can lean on the compiler's safety guarantees by using the struct constructor syntax. So the Solidity compiler itself will actually throw an error if you are missing a field in your constructor syntax that isn't detected if you were to use dot notation to initialize the fields in your struct. So this would be the preferred fix because you do get those security guarantees from the compiler. But if you insist or you prefer to use dot notation to assign the fields of your struct, a good practice is to compartmentalize your logic into different functions, such as something called a init config, so that devs during code reviews in the development process, you can look here and make sure that the struct is actually initialized properly. And during the audit, auditors would be able to look there and guarantee that the struct was indeed initialized correctly.
All right, so this one plays off of the struct initialization error in a similar manner by looking at how EVM handles default values. So in this case, we have a pool launching contract. We have a pool status state variable, and it's going to hold an enum of type pool status. So in this version, we have launched, paused, and closed are the 3 states of the pool the developer expects the pool to ever be in. And then we might also have like a pre-launch phase that we expect users can't interact with the pool yet, but we say that it's not launched yet. So we don't represent it in the enum because they don't think they need to. But since the status was defined as a state variable and then not set during the constructor, it is actually going to default to the first value in the enum always. And so that would mean that right off the bat, as soon as this contract is deployed, the deposit function would be allowed because the pool state would be in the launched phase. This may not be intended, and it can happen in a lot of other different circumstances too, where anytime there's an enum and the default value is the first one, if that's not an okay or safe state to be in, then we need to evaluate adding a new one on top of that. So our fix here would be to add a pending state as the first state in the enum. This would make it so that it defaults to the pending state and then needs to be manually changed to one of the launched, paused, or closed states later.
Great. So I like this issue because there is no issue, and the compiler actually allows this to happen. But there are some things that can really go wrong here. In this contract, we have a parent contract deposit and a child contract deposit with access control. And I'm sure we can see that both of them are incorrectly declaring a private variable account manager. But because these variables are declared as private, there's actually no like collision of this storage, as one account manager lives solely within the deposit contract and another lives solely within this child contract deposit with access control. So we can see that only the child contract allows the account manager to be assigned, and it's only going to assign to the state variable within it itself, and this will not be reflected in the parent contract. So when the inherited function get account manager does get invoked on the child contract, it's actually going to read stale data from the parent contract, which would likely just be an undefined zero address value here. So this isn't an issue, again, in the compiler, but it can lead to issues down the line, as we saw in client code. And quite frankly, the issue with the code that we were auditing here was that deposit, this parent contract, was never meant to be deployed as a standalone contract on its own. So the devs should have just declared it as abstract to be only inherited, and then we could just isolate the storage only into that abstract contract, so there's only one account manager ever being referenced throughout the system.
All right. So this is one of the more complicated ones that we have here. This contract is, well, it's actually two separate contracts, parts of a bridge. So in the top part, we have the origin chain where you'd be sending tokens from one chain to another, and the bottom you'd have the destination chain. The issue here is that on the origin chain, we are allowing users to specify a payload, which would allow for arbitrary calls on the destination chain. So you might have some, say you want to bridge USDC from mainnet to, say, Zirkit L2. You might have something that happens on Zirkit that you want some action to take place when the funds actually arrive there. And so we want them to be able to specify what actions they would like to take. But the problem here is that this is just a little too free from the user's standpoint. So the risk here is that we have stalled transactions, lost transactions. When you're focusing on something that's going from one chain to another, you lose the atomic guarantees of operating within a single chain. And so now we need to focus on problems that could occur if, say, one transaction doesn't execute on the second chain. Can it be replayed? If it gets to the second chain and fails, can it be retried, or is it going to fail every time? Is the user paying enough gas on the starting chain to pay for the operation on the second chain? And when you give all these options, such as an empty payload that the user can specify anything, we're very likely to run into issues. So as I've kind of been alluding to, the auditing tips is anytime you have generic bytes as user input, we're probably doing something wrong unless we're working with like a wallet. We want to confirm that our cross-chain execution is in somewhat of a box state so that we can limit the number of operations that the user can actually perform. And we want to remember that different EVM chains, again, operate a little bit differently. So just because it sounds like good opcodes on the origin chain doesn't mean it's actually going to work on the destination chain. So once again, we want to sanitize inputs. We want to restrict and give options for what the user can do instead of allowing for arbitrary execution. We want to enforce maximum payload sizes so that we don't run into issues where, actually I should go back. So we have a try-catch block on the destination chain. And this would theoretically handle any errors that we would run into, but, I'm sorry, we activated Siri. This would theoretically handle any errors that we would run into, but the one it can't catch is if you run out of gas on the destination chain, it's just going to fail and the whole bridging operation won't work. So we need a way to work around that and limit operations that are going to run out of gas on the destination chain.
Awesome. So those were our main category of like our easy to miss solidity bugs, but we have some honorable mentions out there. So any contracts that support multiple tokens, please do not assume that all decimals of those tokens will be the same. So perhaps read the contract state for the decimals when normalizing values. Any NFT marketplaces, please keep your eye out if it's planning on supporting the CryptoPunks contract. The CryptoPunks contract has been around before many of these token standards became the norm, so it operates in a very unique fashion. Additionally, if there's any staking contracts and needs to be accounting between user stake funds and the reward tokens that are given. So if USDC can be staked and rewarded out, there needs to be an accounting separation between the user's funds that were deposited and the rewards that are to be paid out, often provided by the team, which sort of relates to like the risk of just reading the balance of the contract. And then another thing that we've seen is if usually this is in the earlier stage of a protocol, but if there's any manual price updates that are to be given by the team, maybe it's like a ratio of rewards or something like that, that is almost always going to open up the contract to the risk of front running and back running for optimal gains and maximum extracted value. So with those, before anything like withdraw for a certain calculated reward, if that can be reassigned by the team, perhaps prefer an update on those operations instead of waiting for perhaps like a price update once a day. Yep. So in conclusion, even our easy to miss bugs can lead to severe consequences. Lean on both static analysis, in-depth audits, manual line review, any automatic tooling during the audit process itself. Then just generally embrace best practices for Solidity smart contracts, such as proper state updates, full initialization. Do not rely on default values. It's even safer to assign the default values explicitly than to just assume that they're going to work there. And always, always sanitize the data, especially if it's user provided. So stay proactive. Always read up on crypto Twitter, security best practices, recent hacks, and stay safe out there.
Awesome. Thank you, guys.
We'll be around to chat after.
We have about a minute and a half if we have time for questions. I don't know. Might be close. Any questions?
Thank you.
Looks like we got one. Can we get him a mic? He was raising his hand. Oh, yeah. Oh. We don't have much time.
Yep. So does QuantStamp do security audits for other chains besides EVM chains?
Yes, definitely. We've done audits for all EVM chains, Solana. We've done stuff for Sui. We've done stuff for Ton. Yeah, we've done Cardano. We've done just about everything, including the kind of Web 2 node side of things as well.
Is there any talk about using AI to automate some of these audits that you guys do manually?
We do not have a talk on it, but we do, if you want to come talk to us later, we do have some insights on that.
Also, maybe let's talk after. Let's talk after down there. Thank you guys again.
Thank you.
Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a mempool express. Next bottleneck, I see mountain crush it. Click, clack, goes a mace on firewall. I spooked and truce from trash sheets. That's my device. Nullifier sniffing on my clothes too crisp. Mainnet gossips tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. You private DMs, I'm the dumpster dive chump. Eyes everywhere, match 3 bird phones. Haunteries whisper, king chomp and blockchain bones. Make it down to my voted fuck. Style best tears. Call me well connected. Visa, Colorado Comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking ether night whiz. Founder at a bullet hook sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while lag run drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby doo crack. Ooh, that lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bluff the corn's grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Alliance architect with a buffercorn's grit, teaching still.
Hello everybody, I'm Sushan, DevRel at Humanity Protocol, and today I'm gonna be going through how we can build build applications on privacy-preserving identities, and how we at Humanity Protocol are making this a reality. Just to begin with, let's just kind of understand the identity crisis that exists not just in the Web3 world, but also in general. I'm pretty sure all of us here are aware of the kind of control and the amount of centralization that exists in the current world with large organizations and governments having complete control of our personal data and IDs. And with data being the new oil, every single day we hear news of all kinds of data breaches and leaks. Sometimes it's large organizations kind of trying to monetize on our data, or it's just because of the central point of failure of these large organizations. And also in Web3, we have a huge lack of robust identity mechanisms to really filter out the Sybils that are kind of interacting with our chains or platforms every single day. And to really solve this problem, we need to figure out a way to incentivize and reward the right users who are real human beings. And that's where we come in. At Humanity Protocol, at the most basic layer, we have the humanity layer, which, utilizing proof of humanity, our goal is to begin with ensuring that the decentralized ID or the wallet address that's interacting is an actual human being. And beyond that, once we know that it's a real human being behind the wallet address or the DID, we can further associate that wallet address or DID with all kinds of verifiable credentials for interacting with different ecosystems. And how do we really figure out if it's a real human being associated with that DID or wallet address? I mean, we could go with multiple approaches there's the software and hardware approach, where if you want to go with the software path, we can use AI, machine learning algorithms, and other ways like social reputation scores, etc. But eventually, as AI and technology progresses, I mean, even at this point, we can see how difficult it is to really filter out Sybils, and Sybils and attackers and whoever intend to attack the system can figure out multiple workarounds for all these safeguards that we try to put with just software mechanisms. And that's why we chose to go with a hardware approach. And coming for the hardware approach, biometrics of course is the best approach, and for that we had to keep few goals in mind. The first would be that, of course, it's sufficiently accurate in terms of identifying that it's a unique human being and there's no overlap with multiple human beings. And also keeping in mind that it shouldn't be invasive in terms of the privacy for the user themselves. So that's why we chose palm signatures, where the palm signature or the palm print or the veins of the user is like utilized to scan through and generate an encrypted biometric and associate that with a specific DID of the user. And keep in mind that this encrypted biometric signature doesn't reveal any of personally identifiable information of that specific human being. That's just verifying that it's a real human being, that they're a real human being utilizing the DID. And once we know that it's a real human being, of course, we can utilize the fact that it's a DID that's interacting with your platform with one-to-one matching for, it's a human being that's interacting, or one-to-one matching by attaching multiple credentials associated with that DID for various use cases across the ecosystem. And this also leads to this whole concept of self-sovereign identities, where we have these self-sovereign DIDs or identities of users who are real human beings, and they have complete control over their identity, and also they have multiple verifiable credentials that are kind of independently issued by trusted parties, and all these credentials associated with real human beings or the DID can be verified independently either through decentralized nodes or specific applications that are verifiers. And of course, it's privacy preserving with encryption in mind for the signatures of the biometrics and decentralized storage and cryptographic proofs for proving certain parts of your DID or verifiable credentials. And to really build on top of it and understand the whole concept of kind of like attesting and attaching verifiable credentials to your DID, we need to understand the concept of verifiable credentials itself. And what are verifiable credentials? At the most basic level, they're just certain claims related to that specific DID or unique user, or just, in this case, the credential subject, which is the human user that's interacting or possesses that DID. Now, these claims can be customized, and this is where we all developers come in, and you guys can get creative and come up with all kinds of use cases to attach different kinds of verifiable credentials to that specific DID of that unique human being. And this is tamper resistant because it is signed using the keys of the user, and that specific signature of the verifiable credentials cannot be tampered, because if there's any small modification carried out, the whole signature is going to change, and we're going to be able to prove that it's not a valid verifiable credential. And most importantly, this adheres to the W3C standards, which is the World Wide Web Consortium standards of verifiable credentials and DIDs. Hence, it's interoperable across not just Web3 ecosystems, but also Web2 ecosystems. And of course, you got to keep in mind that we don't reveal any personally identifiable information associated with the user, but rather it's just certain verifiable credentials associated with the DID, knowing that it's a human being, and they can selectively choose to reveal parts of the details to whatever applications or entities that they trust. For an example, it could be like a driver's license verifiable credential associated with a user. Maybe they just want to reveal the age parameter. They can just go ahead and reveal that selectively. Or they just want to reveal their whole verifiable credential, that they have this license, that they possess this ID. They can just go ahead and prove it. And coming to the wide variety of applications that can be built leveraging our base layer of knowing that it's a human DID, and of course using our SDK to build on top of it. The key aspect that you've got to keep in mind is the use cases are really broad, and you can get really creative and utilize the concept of verifiable credentials for multiple use cases. To mention few, like universal basic income like UBI, you know that it's a human being and they might have certain verifiable credentials associated with them, you can go ahead and give periodic incentives to a verified human being. Or enterprise DeFi, where maybe certain DeFi protocols want to comply with certain AML or policies or regulations of specific countries, they can just selectively know that it's a user from that country and they have these specific verifiable credentials issued by certain trusted parties or issuers, and go ahead and let them carry out the trades. And on-chain games where, or also just games in general, where the game developer just wants to make sure that it's real human beings that's playing their game or competing, they can go ahead and utilize the DIDs provided by humanity. And decentralized signs, where verified reviewers can contribute to the progress, knowing that it's real contributors and reviewers. And further, a really interesting use case that I'm excited about, which is the network states, where we have like self-governed states, and we have these DIDs, and just with a palm scan, people can navigate through the whole network state, buy whatever they want to buy, or access certain events, or the possibilities are basically endless. And as I'm kind of running out of time, I'm just going to quickly breeze through the use cases where we have DAOs, where we know that we can give certain amount of weightage for specific human beings, knowing that, to prevent kind of like DAO attacks just through token holders or multiple few entities having a large control, we can just know that they are real human beings voting, and there's a majority kind of like populist kind of approval for specific proposals. And then there's RWA for linking specific verifiable credentials associated with real-world assets, and of course the education certificates issued by authorities, universities, or employment proof, etc., can all be attached to the DID of that human being as verifiable credentials. Now, in terms of what we can, at this point, how developers can build on top of our SDK or API. So at the moment, we're on testnet, and we have rolled out few basic, very simple APIs to leverage the concept of verifiable credentials and issue, verify, revoke using the W3C standards. As I mentioned, the use cases, it can be broad. You can just consider one of the multiple use cases, or just get creative and think of some cool on-chain use cases. So in terms of the bounties, we have got 2 tracks. The first one would be focused on mobile apps with really good UX and easy onboarding for the users with their DIDs on our testnet, and think of some cool use cases where they can just show that they own this specific verifiable credential on their mobile application. Or the other track, if you want to just build like a web app and utilize their APIs, you can just go ahead and, again, get creative and build some cool use case where you utilize the verifiable credentials, and the users can do whatever you want to do based on whatever kind of dApp you're building. And coming to the judging criteria, these are like the key criteria, but to summarize, the functionality in terms of it's got to make sense, and it's got to be functional, it's got to work end-to-end, not just a half-baked project, and it's got to be a novel use case. And we are really interested in DeFi use cases because we believe that human DIDs, along with verifiable credentials, can unlock a lot of DeFi possibilities. And of course, the best practices for technical implementation and UX. In terms of UX, I think you got to make sure that it's like super easy for the users to get onboarded onto your application. So let me just quickly walk through the APIs that we have got. So so this we've got a. So if you go to our docs at docs.humanity.org, you can look at the key APIs and also a few other details. But these 4 APIs are going to be crucial let me just show the issue part where it's very simple. We're abstracting a lot of things for y'all. So the key goal for you is to get creative with the digital claims part for the verifiable credential, where you can customize this with whatever custom claim, and the subject of the address out here is going to be the user. Sorry, I think. It's going to look like this. And this is going to be the address on, so make sure that whatever address you're trying to verify is has signed up on testnet.humanity.org. And it's just got to be the wallet address in this case of the user or the ID that you're trying to verify, attach the verifiable credential to, and you can just go ahead and yeah, this is where you get creative, and you can add any kind of custom claim associated with your use case and assign or issue the credential for that user. Yeah, once it goes through and gets issued, you're going to see the credential itself and a message saying that it's been issued successfully. So we have like a bunch of details out here, but I would like to focus here on the ID. So the ID of the verifiable credential is pretty crucial. And also here, the claims come, the claims that you attach to that. So remember that this is one specific verifiable credential associated with the DID, and the claims that you have associated with that are going to come, are going to show up out here under this section. So post that, you can just go ahead, copy this credential as such. You can just copy this credential and go to verify credential section, and this is the body of it where you just provide the credential. And once you send that, it's going to show that if it's legit or not. This is for the verification part to know that if it's a legitimate credential. Now, so this is an example of if it's not legitimate because I just revoked it. And for that, there's a revoke endpoint where, for some reason, if you want to revoke it, you can just go ahead and revoke it after a certain point by providing the credential ID. And then the list credentials where, so here, you got to keep in mind that the holder DID parameter is optional. You can either choose to provide that and limit it to a specific DIDs, the credentials you have issued for that specific user, or you can just get rid of it and get all the all the verifiable credentials you have generated for your application with that specific API key. All right, so yeah, so let me quickly, So these are our docs, and if you've got any doubts, you can hop onto our Discord server or our Telegram, and we'll be around here. You can just approach us, and we'll love to help you with any doubts, or if you want to just brainstorm your idea. Also, please do scan this or fill this form. This is going to lead to the form, and we're going to reach out to you with the API key for your application. And yeah, that's pretty much it. Really excited and looking forward to all the interesting use cases that you all are planning to build on top of Humanity Protocol. Thanks so much.
Open source and gas optimized, code permissionless. She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking ether night whisk. Found her at a bullet hook sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while lag run drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-bop crack. That lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bluff acorns grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Architect with a buffercorn's grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with for do with for do with you ordered a moonwalk across gas feed graves. My main
Hi, everyone. My name is Pranav. I'm an engineer at a company called Provable. We are a labs code that is really into ZK tech. So today, I'm pretty excited to talk about ZK-powered payment channels, but only sort of. See, what happened was when I sat down to write this talk, I realized that there were so many core conceptual pieces to go over that instead, we're going to take the long way and talk a little bit more generally about private payments using ZK, and finally touching on these interesting ideas like payment channels, stablecoins, compliance at the very end. So as a little bit of an overview, we're going to take some time to set the stage. Then we'll actually dive into private payments, how the model looks like abstractly. Then we're going to expand on that a little bit, talk about the hybrid ZKVM that we've designed at Provable and then actually instantiated in Alio. And then finally talk about the cool use cases at the very end. So with that, let's just jump into it. So first, I wanted to just set into a frame of mind what the anatomy of a payment looks like. Now, for most of us, whenever we make a transfer, a payment using crypto, we're looking at some UX that looks like this. Now, under the hood, this is implemented very differently across different chains. But abstractly, we'll reason about a model that looks like this. Here, we have off-chain, a user Alice, and on-chain, a ledger, which for a token program contains some state. Here, Alice has 8 credits, 8 tokens, and Bob has 2. And what Alice is going to want to do is send Bob 3 credits over via the network. Now, the way this looks like in Ethereum, in Bitcoin, kind of abstractly here, is that Alice will first generate a transaction. That transaction will specify the person she wants to send to, the amount, and a signature. And Alice is going to fire that over to the network. The network is basically going to take a look at this transaction, process it, verify that it's well-formed, verify that the signature is correct, and then update the state. And at a high level, this is like how payments work like, transfers work like in the account model. But if you squint your eyes a little bit, you'll also see that this is how they work in the UTXO model. There is a public ledger. It contains some public balances. And that tracks how much everybody has. There's a fundamental problem here, though, and the issue is that all transactions are public. This means that the actual UX that we expect in payments, in transfers, in money, isn't actually represented in these sorts of constructions. When we send money, we expect that only the two parties who are interacting actually, get to see the details of the payment. And this is just a fundamental problem that kind of blocks a lot of crypto use cases. If you're a whale, you're very cautious about moving your money around to prevent people from tracking your expenditures, so on. If you're any user, right, you're basically under the assumption that you can be tracked. So in this talk, we're going to work out how we can use a different model to effectively support private payments and get the kind of UX that we want. Now, before we get there, we're going to have to talk about ZKPs, but I'm going to keep this super, super high level and oversimplified. There isn't a huge need for technical ZKP materials, but there's a bunch of really good resources online for this stuff. So for the purposes of this talk, when I refer to zero-knowledge proofs, I'm going to refer to ZK snarks specifically. And what that means are zero-knowledge, succinct, non-interactive arguments of knowledge. Now, if we were to dive into ZK, there's a lot to unpack here. But for today, all we're going to care about is the zero-knowledge component. Basically, that the private inputs to the proofs are not revealed to anyone who has the proof itself. Another way to think about this is that with the zero-knowledge proof, I can create a proof pi that proves that I know some value x, which is private, such that some result y is equal to f of x. And in this case, y and f are public. Now that we've kind of run through this overview and kind of set the stage for payments and ZKPs, let's take a look at what a private payment actually looks like from first principles. Basically, we have in this model a different kind of instantiation of state. Before, you had this ledger which tracked for every account, every user's balance. Instead, in this model, we're going to track these objects called records. And records are individual data blobs. You can think of them as encrypted envelopes, each with a public ID, which is enforced to be unique, and some encrypted data, which is encrypted to the owner in the record. If you're coming from the Bitcoin space or familiar with the UTXO model, this effectively looks like encrypted UTXOs. So in this setting here, Alice has a record that she owns that is on-chain, but the balance and the fact that she owns it is encrypted, so only she knows her balance here. And same with Bob. Bob has a balance. He knows that he has 5 tokens, but no one else knows this information. Now, if Alice wants to send, let's say, 2 tokens to Bob, she's going to form a transaction. And now there's a lot of parts here, and we'll go through them one by one. The component in the red is the records that Alice is going to use as inputs. So she's going to reference records that exist already on chain and say that she's going to be spending these things and then producing the blue records that you see out there. So in each of the blue records, you'll see that there are 2 new records created, one called 3 and one called 4, and one basically debiting Alice the amount that she has remaining, and one giving the amount to Bob. Additionally, there are also 2 proofs attached to the transaction. And these proofs basically will assert, using zero-knowledge proofs, that the transaction is well-formed, so that the encrypted data was created correctly, and that Alice actually owns record ID 1, and that the balance is conserved. So Alice didn't mint money out of thin air. And with this, she'll fire it over to the network, and the network will verify these zero-knowledge proofs, as well as check that the transaction's well-formed. For example, that the record 1 actually exists on-chain, and then update the ledger. And the way the network updates the ledger is basically the network will invalidate the record that Alice wanted to spend, and then append the 2 new records that Alice has created. Now you can follow along this model to basically work through it and see how Bob might, condense his state. So if Bob, right now has 2 records, 2 and 4, each with 5 and 2 credits respectively, Bob can basically fire off a new transaction that takes 2 and 4 as input and produces a new record 5, which asserts that, just basically combines the 2 records and fires it off to the network and subsequently gets updated. So at the end of it, Alice has transferred 2 credits over to Bob, and Bob has aggregated his private balance. And in this whole process, nobody else knows the actual balances of Bob and Alice, or even knows off of looking at a transaction that it was actually Bob and Alice that sent money to each other. Now, we kind of spent all this time talking about how we can move away from this account-based ledger model, similar like stuff that we see in Ethereum, the EVM, so on. But there are actually some good things about it. When transfers are public, it means that they are easily auditable. It's also very easy to manage this state and actually implement these kind of designs versus these record-based UTXO models have UX issues, as well as, you just got to do a lot more heavy lifting to implement something like this. But there are desirable properties in both. So in Alio, ZKL1 that we've contributed to, helped build up, we've just kind of combined the two. We have in the VM in the network a public ledger that tracks public balances, as well as a private ledger that tracks your private balances. Now, what this means is, if we have this kind of like traditional world where, you have public on-ramps, a centralized exchange, a bridge, and just public transactions where Alice and Bob can send money back and forth, move them on and off, and so on, you now get this private dual world where Alice and Bob can also move into the private domain and transact between them. What's kind of unexplored here, which is kind of pretty exciting, is what are the private on and off ramps look like? How do you construct private dexes? How do you construct private bridges? And this is a bit of an open question, but a very exciting space to kind of look at. Now, I kind of fudged things when I said Alio just combines the public construction, the account model, and the private construction, the encrypted UTXO model. We actually have also instantiated a custom designed VM where developers can upload their own programs and more generally write code that works with private logic as well as public logic. And instead of just looking at payments as one, as the core problem, this virtual machine here kind of treats payments as a use case, as a specific program on the network. And with that, you can start to explore more production-grade stuff. So, kind of the sort of pseudo topic of this talk, payment channels. So payment channels are kind of an interesting idea. Basically, one approach to scaling the speed of crypto payments. Alternate approaches are like actually building a full-purpose L2. This is another approach that kind of got some popularity in the early days in the Bitcoin community. The way it works is basically at a high level, you have 2 parties who want to transact, send money back and forth to each other, Alice and Bob. And what they're going to do is they'll go through a couple steps where they will open up a payment channel via an open and an acknowledgement, and then send as many transfers back and forth with each other, and then finally close the whole thing. The way this works in the traditional sense is that opening and closing is on-chain, and in Bitcoin and any kind of like EVM style or account-based construction, this part is public. But because we've designed this thing with records and private state, privacy actually almost comes for free. You can just copy the existing constructions out there, and you have private state channels where settlement is actually truly private. And then because we designed this virtual machine where you can kind of arbitrarily define other functions, other logic, you can use that to add in more rich spend conditions to your payment channels. So it's not only just balances going back and forth, you can add extra conditions that do something more interesting. Maybe require some identity verification, maybe require some minimum balance, something like that. Another dimension to actually implementing these things in production or actually creating a product out of them is compliance. So we spent all this time creating a private way to transfer money, but there's a problem in doing that, and that's you're basically fundamentally doing something illegal. With private money, it means that people can kind of launder money quite easily if you don't have guardrails in place. So with this, we're also thinking a lot about, with privacy, how do we design compliance? And what's really interesting is that zero-knowledge proofs, while giving privacy, also give a very natural mechanism for adding in compliance that's also private. Now, at a very base level, if you're looking at compliance for private transfers, the basic thing that you need to do is make sure that a party interacting doesn't come from a set of blacklisted addresses. And this kind of fundamental idea is known as, or this thing bakes down to something known as set exclusion. And we know how to do this with Merkle proofs. It's fairly straightforward. And it's also fairly straightforward to instantiate these in zero-knowledge proofs themselves. But other than set exclusion, you can do a lot more interesting things. Basically, again, we're just going to use zero-knowledge proofs to kind of prove arbitrary properties about the users who are initiating or receiving payments. So some interesting things you can do is use a zero-knowledge proof to provide some identity verification. You can use a ZKP to check that your transactions are under some limits, or that another set of assets have a certain amount of exposure before firing off a transaction. You can require credit checks. You can require checks on user history all through ZKPs. You can enforce sanctions. You can add requirements that users come from specific locations. And you could even do provenance for funds before they're actually sent through. Here, things do get more creative. There do need to be parties that provide, this sort of raw data in the case of identity. But it's really kind of an open space for application developers to really add in whatever compliance measures that they want. So it's kind of based on each use case, anyone can really design whatever piece that they need here. So at Provable, we've basically been exploring ZK tech, building this stuff out, and its main instantiation is in Alio. Alio is a ZKL1 that kind of implements this zero-knowledge virtual machine with all these principles baked in. So developers can immediately go on it, use a language called Leo to develop their dApps, and immediately have this ability to write hybrid applications that interact with public and private state. And yeah, that's all I have today. This is a general high-level idea, and if anyone has any questions, I'd love to dive into it a little bit more. I think we'll get a mic over there.
Yeah, I mean, can you make a quick comparison of the Alio, the provable Alio, the payments you just talked about with things like Zcash or something like that?
Yeah, it's a really great question, right? So just to repeat the question, how do we compare payments on Alio to something like Zcash? And the interesting observation is that the baseline ideas of Zcash, where you have these kind of public and then shielded domain, is instantiated as, instead of a core protocol level implementation as it is in Zcash, in Alio, this is a programmable piece. So to actually do this in Alio, you write a program that you upload to the VM, and you get these kind of privacy elements in there. So whereas in Zcash, it needed to be a native asset, here developers can build their own programs, add their own compliance mechanisms for specifically their own use cases, and upload it on chain and run them. Great. Thanks for listening, everybody.
Code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if you chains choking ether night whisk. Found her at a bullet hook sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange drools over slow motion doom. Her shield's a disco wall fracturing legs grass. Shooby-doo-ba crack. That lance a lightning fork splitting bottlenecks backs. Alliance architect with a bluff acorns grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Architect with a buffercorn's grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with for do with for do with do you ordered a moonwalk across gas feet graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess. Scales of justice ballast on a mempool express. Next bottleneck, I see mountain crush it. Click, clack, goes a mace on firewall. I spooked and truce from trash sheets. That's my device. Nullifier sniffing by my cloaks too crisp. Mainnet gossips, tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. You private DMs, I'm the dumpster dive jump. Eyes everywhere, match 3 bird phones. Haunteries whisper, king chomp and blockchain bones. Make it down to my voted fuck. Stealth crawl through your junk dead scene. Let it up. The entropy. Mace cracked balls like, who's got the keys? Nullifier's huffing, you're just a rat with his firewall splinter to confetti bits. I'm curating leaks at the after party, sipping TLS tears. Call me well connected, I call it. Coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. They rock on P Island. Get homemade in 7-4 time. Shaboom goes the efficiency pulse. The lag runs lagging in his latency sub. Professor Wade's got the future on spinball. Urging notes dancing where the bottleneck's been. Professor Wade's got the future on spinball. Bugging tomorrow with yesterday's cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Wade's got the future on spinball. Urging nodes dancing where the bottlenecks been. Professor Wade's got the future on spinball. Hugging tomorrow with yesterday's ram stains. Chaos is not compeller. Order's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI? Nah, just 3 Red Bulls in a row. What you building, prop? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Light runs xylophone. Old as speak, young as each block, mine down. Professor Wade's got the future on spinball. Urging nodes dancing where the bottlenecks been. Professor Wade's got the future on spinball. Hugging tomorrow with yesterday's ram stains. Throwing me mad, but mad's just a beta test for Boodle. Oh, he jumps right to you. Oh, he jumps right to you. Oh, he jumps right to you. Oh, he jumps right to you.
Welcome everyone, thanks for coming. My name is Daniel Bigos and I am open source developer at OpenZeppelin. And today we're gonna talk about Arbitrum Stylus. So let's start with the question, what is Arbitrum Stylus? So before Arbitrum Stylus was enabled on Arbitrum chains, Arbitrum nodes hosted only EVM. Arbitrum Stylus adds additional co-equal virtual machine, WASM virtual machine. And that virtual machine allows us to develop smart contracts in any programming language that compiles to WASM. At this point, I need to mention that WASM smart contracts are fully interoperable with Solidity ones, which means that we can call either WASM smart contracts or Solidity contracts. They can both call each other, and it works just out of the box. Thanks to the WASM virtual machine, we have faster execution and lower gas fees, because operations on WASM virtual machine are much faster in comparison to the EVM. Thanks to the Arbitrum Stylus, we also have better security, higher security, because Stylus disables reentrancy by default. Now let's check the stack around Arbitrum Stylus. So what we have? Stylus SDK, it is a Rust SDK, but it can be any other programming language SDK that provides set of tools, libraries, components to build your own EVM compatible WASM smart contracts. Also, we have a cargo stylus, and this is a command line tool that gives us possibilities to create a new project, build our smart contract, deploy it, and do some other stuff around this. Also, we have a Nitro node, and Nitro node is nothing besides the Arbitrum node that holds multi-VM, multi-virtual machine, both EVM and the WASM virtual machine. Now let's try to build our first Stylus contract. So let's generate the project with the cargo stylus command, and as you can see on the screenshot, it generates for us just a regular Rust project. And within this project, we need to check 3 files. Cargo Tom, the first file that we need to check. In this file, we have information about the smart contract name, some of the metadata like the author, repository, license, stuff like that. And besides that metadata, we have also information about all the dependencies. So dependency management comes from the cargo tom file. The great thing around Arbitrum Stylus is that we can use any Rust crate that we want to in our Stylus contract, and it just works. Another file, I would say the most important one, is librs. In this file, we put all the logic around our smart contract. The last but not least, main rs file. It holds some logic around displaying our smart contract interface, but we will go into this part later. Okay, so for today's talk, we're gonna build just a simple counter. So let's start with defining the storage. Every Stylus smart contract is built like a Rust structure that holds some data, and in our case, we just need to store the current counter value. To have our Stylus contract, we need to use two Rust macros that come from the Stylus SDK. The first macro, storage. This macro generates for us the Rust code to interact with the EVM persistent storage. So with this attitude, we can just store values for our counter and also retrieve the value from the storage. The second macro, entry point, this macro generates for us all the code that we need to interact with our Stylus smart contract. Of course, that's a very basic contract, but once building our own, we can use any data type that we know from Ethereum, like integers, maps, string, vectors, addresses, anything that comes to our mind. Now, it's time to define some logic for our smart contract. And to begin with, to give you more perspective about Rust, any logic in Rust is defined in implementation blocks. A Rust structure can have many implementation blocks, but the most important one is the one with the public macro. The public macro exports all of the functions that we have in this implementation block to be smart contract functions. So our counter smart contract will expose functions like value, increment, and decrement. As you can see, those functions are just regular as functions, so they can return a value like unsigned integer. They can return an error. They can panic, as we can do in Rust. The second implementation block shows us how to interact with the EVM stuff, like, for example, emit an Ethereum log. Also, how to retrieve some information around the context, like the message sender. Of course, the Stylus SDK provides many other functions to play with the EVM stuff. Having mentioned errors, having mentioned events, now let's try to define them. As you can see in the code snippet, we use just a solidity syntax to define both errors and events inside sol macro. So sol macro is a Rust macro that, based on the solidity syntax, generates for us all the structures, all the Rust code that we need to build EVM compatible with smart contracts. There is one thing to be mentioned, that in Rust, we need to strictly specify what type of errors our function is going to return. We may know that we can have with function bunch of errors to be returned, solidity errors to be returned. So we need to take the attitude of having just an enum, and to have a binding between solidity errors and our Rust enum error, we just need to use derive solidity error. We also need to take care and assure proper quality of our contracts. The problem is that we cannot just use pure Rust test to write tests for our Stylus smart contracts. It is due to the fact that we need some kind of EVM emulation. We also need some kind of WASM virtual machine emulation. And to solve that problem, to solve that issue, my team at OpenZeppelin built a library called Motsu. it is unit testing library to test our Stylus smart contracts. To write a Motsu test, Stylus unit test, we need to use just Motsu test macro and provide information which contract are we going to test, and also the list of the addresses that we're gonna use in our test scenario. And as you can see in our code snippet, we can execute any of our smart contract function on behalf of a specified address. The great thing about Stylus SDK is that the Off-Chain Labs team, the team that builds the Stylus SDK, with the newest version of SDK, introduced some changes that allow us to modify the context in unit test, which makes the testing easier and allows you to write your own testing tools. Okay, so we have our contract ready to deploy. So let's deploy it. For deployment, we can use Cargo Stylus tool. And during the deployment command, it sends 2 transactions to the Arbitrum chain. The first one, called deployment, it just posts WASM on-chain. The second one, called activation, does some operation on the WASM binary. Now it's time to introduce a term that might somehow trigger you, and the term is cache. Interesting, cache in blockchain. But the problem is loading WASM binary from hard disk into memory takes some time. And to reduce that time, Off-Chain Labs team brought the idea of cache. The cache is nothing more than quick access memory, and we can store in cache at max, if I remember correctly, 4,000 smart contracts. Everything is managed by the cache manager contract, and to place a smart contract in cache, we just need to place some bit, and we have it hashed. We can also use our Cargo Stylus tool to check the minimum bit for the smart contract and place it in a cache. Now we want to know how to interact with the smart contract. So let's check the main RS file. In this file, we have a single one instruction called print ABI. And once we execute Cargo Stylus export ABI command, it generates for us Solidity-like ABI interface. It looks exactly the same as for Solidity contracts. So it means that we can interact with our Stylus contracts in the same way that we interact with just regular Solidity contracts. Of course, we may want to build more advanced smart contracts that are composed from smaller smart contracts, and it is also possible in Stylus too. We just need to create another structure that contains all of the components, all of the smaller smart contracts, and we need to make use of both borrow and inherit macros. Those macros we need to use to have the possibility to export all of the components contracts functions to be available in our ERC20 example. So thanks to borrow and inherit macros, we have by default exported all of the functions from ERC20 metadata, capped, and posable contracts. Additionally, if we want to, we can also override some of the functions from our components contracts, like I did for the decimals from the ERC20 metadata. All of the contracts that are mentioned here come from our OpenZeppelin Stylus contracts library that my team was working on. So I strongly recommend you checking out our repository, playing with our contracts, and suggesting ideas what we can build in the future for the whole ecosystem. The question is, right now, if we, Stylus developers, miss Solidity, there are some stuff that I want to discuss right now. So at first, constructors. Right now, Stylus does not provide constructors. We just need to use initializers or do some workaround and injecting some code during the deployment. But the great information is that the PRs bringing Stylus constructors are already merged to the main branch. So we can expect them very soon. The next point is that smart contract composition. As I previously said, we can have only a single public macro. And that design decision prevents us for making use of the power of Rust traits and auto-implementing some of the interfaces. Another great news is that the Off-Chain Labs team is working on improving the developer experience, and we should also have the changes available in the next couple of releases. The next thing, Solidity modifiers. To be honest, in Rust, we don't need modifiers. We can just play around with stuff with regular Rust functions. The last thing is that we can't have multiple Rust functions with the same name that differs in arguments. But due to some fact, we may need to have in Solidity same function names, and for that we can use just a selector macro. Now it's time to explore the power of Rust and Stylus. I always say, don't trust, verify. And we decided to build a Poseidon hash in Arbitrum Stylus. And with this implementation, we built our own optimized big integers library. We also applied some tricks with WASM multiplication using the more efficient data types. We did some Rust tricks with function inlining because calling function takes some CPU time. Also, we did some Rust tricks with unrolling code loops. And in the end, we used WASM optimizations on our binary with WASM opt tool. And we did some benchmarks with 3 smart contracts. The first smart contract with Poseidon implementation, the pure Solidity, let's say easy to read, maintain, and audit. The second implementation called Tuel, it's a Poseidon implementation in Solidity assembly. And also, of course, our Rust implementation, Stylus implementation of a Poseidon hash. And to be honest, we were so amazed with the results. We get 18th time faster than the Solidity implementation. Another use case that we may want to consider that we touched in the past are Uniswap v4 hooks. We can imagine that we may want to do some intense computations in our smart contract, but we can move the logic to the Stylus smart contract to speed up the computations and just call the logic from our Solidity hook. For example, that computation may be custom curves in pricing models. There are a bunch of many other use cases that we can leverage the power of Rust and Stylus, and those examples are, for example, on-chain verification with ZK proofs. Additionally, we may want to build some advanced DeFi instruments, not only Uniswap hooks, but anything else. We can also we may want to build some high-performance on-chain logic, like on-chain games. We may want to optimize our current protocols by moving the intense computations to Stylus contracts. And just to summarize, we have endless possibilities, what to build with Stylus, how to speed up our protocols, everything. That's all from my side. Thank you so much for your attention. Do we have time for questions? Okay. So thank you so much. If you want to join Open Zeppelin, just scan the QR code, check the open positions, and apply. Thank you so much.
Clicking through blockchain debris. Crypto notes flutter like drunk bumblebees. Optimize the orphans, they cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Way's got the future on spinball, urging those dancing where the bottlenecks been. Professor Way's got the future on spinball, plugging tomorrow with yesterday's ram stains. Chaos is not a compeller, or it's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI, nah, just 3 Red Bulls in a row. What you building, prof? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Light runs down a fountain. Old as speak, young as each block, mine down. Professor Way's got the future on spinball, urging those dancing where the bottlenecks been. Professor Way's got the future on spinball, plugging tomorrow with yesterday's ram stains. Throwing me mad, running me mad's just a beta test for Boodle. Oh, he jumps right. Oh, She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking ether night whisk. Found her at a bullet hook sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while lag run drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-bop crack. Ooh, that lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bluff the corn's grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Architect with a buffer corn's grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with a do with a do with with do you ordered.
Hey everyone, my name is Zed and I'm from Silo Finance. I want to talk to you about programmable markets and how they help us with product market fit, product PMF, with PMF, and how they can help you to find it as well. So let's start from the beginning. Silo was created as a necessity to make the lending market more secure in, during the old times, DeFi summer 2020, 2021. We had a lot of demand for risk assets and long, those risky tokens that were just released. And, that demand was met with forks of Compound or Aave. And obviously, they're not designed for risk assets. And what actually happened, a lot of hacks, and the simple asset, one single asset introduced to shared pool design like Compound just spoils the whole bunch and everyone loses money. So that was the reason why Silo was created, and we actually launched the first version in 2022. And we got to pretty good TVL. We got some nice adoption, but really quickly, we kind of reaching the ceiling, glass ceiling, and we couldn't go through it. And as you can see, our chart of TVL is full of pain. And the reason for that is Silo V1 was designed for one use case in mind. And obviously, you have your assumptions, and then you launch the products, and your users will tell you that, it's good, but then there's a bunch of other things that you should do differently. There are other features that you should, introduce to the project. But we couldn't do it because the whole thing was essentially immutable. So there's nothing really we could. And any improvement to the protocol, those small things that a lot of times turn out to be big hits, were very expensive to introduce, because just a single line of code to a code base that is like 2,000, 3,000, 4,000 lines of code can introduce a critical bug, which, many times it happened already. So that begs the question, how can you have immutable contract, immutable product in DeFi and still improve and introduce new features to find product market fit? And the answer is hooks. And that's exactly what we did. We designed the hooks for a new version of the protocol in a way that they should be the simplest possible way to introduce small incremental improvements to the protocol. And this was our North Star, right? We wanted those small things that you can do quickly to be isolated in a single contract, so you can focus only on your stuff, on your features, and then the rest of the protocol can handle, the kind of infrastructure things. So in design, they're very similar to Uniswap v4, and everyone knows about those by now. So when we actually developed the silo hooks feature, and we started doing benchmarks, right? We wanted to see how much simpler it really is. And the first example from the top, in lending, in two-asset lending pairs, a lot of times you have assets that are good for collateral but are not good for debt. They're not secure this way. So you have to forbid borrowing one of the assets. So essentially you create one-way lending pool. And if you wanted to do this in the code base, the core code base, we had to remove like maybe 120 lines of code, which introduced like a lot of changes, a lot of security assumptions change. And now, even though the code does become simpler, you have to go through the whole process of like testing, peer reviews, formal verification, fuzzing, audits, multiple audits, and it just becomes a huge, huge process. With hooks, you can do exactly the same. You can achieve exactly the same features with 18 lines of code, which you can write during the evening, and then on Tuesday send to your buddies for reviews, and by the end of the week, you have launched this on production. So this is an absolutely huge improvement in terms of like those small incremental improvements for your product, and this allows you to actually find your product market fit much better, right? And this is not something that we just invented. Web2 has been doing this for many, many years now. It's just in DeFi, the problem is when you have actually mutable contracts, something that the code that cannot change. So on top of the silo hooks and our vision to do incremental improvements, we also introduced the deployer fees. So essentially what now the developer can do, they can write the hook with the custom feature or maybe multiple hooks and connect to a single silo market and deploy the silo for themselves, spin up their own UI, and essentially launch a brand new lending protocol with their own features and differentiators. And it will take you much less time than it took us to build this whole thing from scratch. So we launched V2 about a month ago. We were able to get to pretty decent TVL by now, and we have a lot of markets already with like deep liquidity, high APRs, and I'm bragging about this for a reason. So imagine this case, right? There is like new hot real-world asset that is launching, and those assets a lot of times don't really have the liquidity, right? They don't have really big secondary markets because they most of the time they come, well, not most of them, they always come from traditional finance. So what you could do is you could come up with this idea, I'm going to build a lending protocol just for AWAs, right? I'm going to focus on this. So the first problem you're going to hit is liquidations. How do you handle liquidations with the asset that is not liquid? You need liquidators that actually have underlying balance, right? You need someone that is willing to hold the real-world asset in their own wallet and then repay the collateral, or rather debt, in the silo. So for example, if you have RWL paired with USDC, then someone must be comfortable holding this RWA because, well, that's how liquidations work. So it's very probable that the depositor of USDC already accepts the risk. I mean, he has to, right? Because you deposit money, so you're sharing the risk with this asset. And that means, why don't you just give them the underlying asset instead of liquidations, right? So you can default rather than liquidate. So when the position actually becomes insolvent, the USDC depositor gets the RWA assets with a discount because there's always a liquidation fee, right? So that's one thing you can do. That's the hook you develop. And then immediately you can just spin up as many silos for as many RWA assets as you want, and immediately create an UI, and you have your own lending protocol with big, nice differentiating factor. And then another problem that you're gonna hit very quickly is like, you can launch 10 markets, but if they're all empty, then it's not very attractive. So 0% APR doesn't really bring that many lenders. So what you can do, you can throw another hook on top of it, which is going to deposit idle liquidity from your silo, from your lending protocol, right, to our core lending, right? So as you guys see, hopefully, because maybe it's too small, but there's like SUSDC market with 11% APR. So what you can do, you can pair your AWA with USDC, and this underlying USDC immediately goes to this silo and earns 11%, which means if you start your own product, you don't start with a bunch of zeros. You start with all those inherent APRs. You can tap on this liquidity immediately, and you have plenty of those, right? You have plenty of assets with very deep liquidity, so you can jumpstart your own protocol. So if you merge all of this together, the hooks, the liquidation, the permissionless deployment, the idle liquidity management, you can literally start your own lending protocol within weeks and bootstrap all the liquidity using the underlying liquidity in Silo for your own lending. So this is the stuff that the hooks can do for you. And on top of that, remember, when you deploy the Silo market, you can choose on your own for yourself how much the fee for given market you're going to take. You have the range to choose from, so it's not given to you, and also this will basically bring you revenue, right? The same as it brings revenue to other deployers, to the DAO, etc. So you have a way to launch your own lending protocol within a couple of weeks and differentiate very well, actually, in the market. And you have those examples already in Uniswap V4 hooks, right? There's so many of them. There's so many projects that literally with like 150 lines of code, they're like a project on their own. They have user base, they have liquidity, and they work very, very well. So this is the biggest takeaway from the hooks and from this North Star idea that we got. With the very small amount of effort, now you not only can just literally fork Silo without forking Silo, right? You can fork Silo without having to deal with all the deployments, all the challenges, and like all the security assumptions that you're supposed to know. All of this is gone, but you get all the product stuff, product side on your side, and you can simply just launch your own project very, very quickly. So after that, the search for product market fit is also open for you, because you can just stack more hooks to your own markets, right? You can just keep experimenting. You can keep innovating, and you don't have to worry about all this underlying protocol infrastructure that you need to do in order to get to this point. So we created a quick start repository for you. There's like a playground where you can just go. You have all the heavy lifting done for you. You have the silo deployed as a fork for you. You have the dummy markets also configured for you. So all you have to do is just focus on the differentiating factor that you actually want to implement. And yeah, and then just don't forget to set deployer fee, so you can bring sweet revenue when you actually launch your project. And thank you guys for listening. I hope I'm looking forward to see what you're gonna build. Thank you.
cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Way's got the future on spin, book. Urging notes dancing where the bottlenecks been. Professor Way's got the future on spin, book. Bugging tomorrow with yesterday's ram stains. Chaos is not compeller. Order's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI, nah, just 3 Red Bulls in a row. What you building, prof? A singularity jukebox. How you stay charged? Espresso stream through my cortex. Who's your nemesis? Light runs down a frown. Age, old to speak, young as each block mine down. Professor Way's got the future on spin. cross gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a mempool express. Next bottleneck, I see mountain crush it. Click, clack, bosom, lace on firewall. Eyes spooked and truce from dress sheets. That's my device. Nullifier sniffing on my clothes too crisp. Mainnet gossips, tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. You private DMs, I'm the dumpster dive chump. Eyes everywhere, match 3 bird phones. Haunteries whisper, king chomp and blockchain bones. Make it down to my voted fuck. Stealth crawl through your junk dead scene. Get it up, the entropy. Mace cracked vaults like, who's got the keys? Nullifier's huffing, you're just a rat with His firewall splinter to confetti bits. I'm curating leaks at the after party, sipping TLS tears. Call me well connected, I call it coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. They rock on PI. Get homemade in 7 for time. Shaboom goes the efficiency pulse. The lag runs lagging in his latency sub. Professor Wade's got the future on spinball. Urging notes dancing where the bottlenecks been. Professor Wade's got the future on spinball. Plugging tomorrow with yesterday's RAM stains. Velcro boots clicking through blockchain debris. Crypto notes flutter like drunk bumblebees. Optimize the orphans, they cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Wade's got the future on spinball. Urging notes dancing where the bottlenecks been. Professor Wade's got the future on spinball. Plugging tomorrow with yesterday's RAM stains. Chaos is not compeller. Order's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI? Nah, just 3 Red Bulls in a row. What you building? Prop? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Life runs dial-a-phone. Age? Old as speak, young as each block, mine down. Professor Wade's got the future on spinball. Urging notes dancing where the bottlenecks been. Professor Wade's got the future on spinball. Plugging tomorrow with yesterday's RAM
Alrighty. Hello, everyone, and welcome. I'm Will Wade. I'm one of the core contributors to the Frequency blockchain. And today I'm going to make a case to you for the use of smarter, more case-specific sidecars for blockchain. Now, before we get into the details there, I want to talk a little bit about sidecars. What are they? All right, there's a couple basic points. Sidecars, for the most part, are standardized pieces of code. They're API servers that you can deploy. They're usually gateways to other servers. There's other code that's actually doing some of the work. It's doing kind of a translation layer. And it's usually run by the consumer of that API. Now, that's not always true. You can see that little asterisk, and we'll talk about that a little bit later. But the key here is why. Like, why do we care about sidecars for blockchain in particular, and why might we actually use one? So this is kind of a story about complexity. So in the case of frequency is one of the core use cases is decentralized social media. And decentralized social media is complex. There's a ton of data working through the systems. There's a ton of pieces and parts. Here's a few pieces of it, right? There's a decentralized identity piece. There are network operations. There's public keys, encryption keys that have to be managed, that have to be handled. There's the actual social graph itself, the encrypted social graph in the case of frequency, and how that's managed on chain. And there's the content itself that's flowing through, or references to references of content as you might have need. And so as we were working through all of these details, we were having a lot of trouble with different people integrating. And we came back to that classic age-old software engineering tool, which is, instead of building social media infrastructure for users directly, let's build infrastructure for applications. And so this looks a little bit like this. In the case of frequency, we have users, they use applications, those applications talk to the blockchain. In this way, we've kind of protected users and isolated that complexity away from them. There's still ways to ensure self-sovereignty through direct no-fee delegation revocation, but a delegation system, this allowed us to say, okay, instead of users having to worry about all the complexity of the blockchain and such, we're going to push that complexity over to the applications. Applications that are probably run by people who have software engineers and people who can interact with that complexity. But as always goes, we had a lot of other problems to solve, right? So how do we get these applications onboarded quickly? Some of them are legacy Web 2 applications. That means they're running Scala, they're running all kinds of different languages that might not be as common in the Web 3 ecosystem. There's a lot of complexity in Web 3, right, that a Web 2 developer might not be used to, right? If you're trying to integrate an application, you're going to end up with, wait, you say I just send this off and I don't get a response back yet? How do I find out my return value, right? Classic problems as people get into the Web 3 ecosystem. There's also data access, right? Where is the data coming from besides the blockchain? Do I need to worry about CCIP or IPFS or any of the other decentralized file systems? How do I get all that together? How do I verify that it's true? There's queuing involved, right? If I'm going to send batches of information off to the blockchain, I might need that problem. I might need a secure key space. If I'm an application that's pushing things to the blockchain, actually interacting with paying fees and such, I need to have a secure place to keep that key and to have those interactions. So many more problems. And this brings us back to the classic, right? Complexity, you can't always get rid of complexity, but you can choose where you put that complexity. So as we work through the kind of classic problems, right? So here's classic Web 3, right? You have blockchain, you have clients. Nice and simple. And here, complexity obviously has a cost on the blockchain side. It costs money to do things on the blockchain. And so we try to do as little on the blockchain as we can, and that forces every tiny little piece of complexity over onto the client side. Uh-oh. Now we've got a lot of code, we've got a lot of bloat on these clients. People, oh, I want to build on top of my blockchain protocol. What do? Well, you bring in that nice, cool SDK, and it handles all that complexity for you. Or you try to do that. And we definitely went through this as we were working on the social media interactions. How much can we put into an SDK? How much can it do? And of that original list, right, it did help with our onboarding speed. It didn't help really, though, with legacy Web 2 applications, right? Primarily because of the language problem. We couldn't build 5 different languages all at the same time necessarily. It didn't hide much of the Web 3 complexity for those applications. It didn't help handling the interactions with IPFS or other decentralized decentralized systems of file storage. Queuing didn't happen, but we did have, this was very good, we had a nice secure key space, right? If the application is doing the SDK, they're kind of managing that key and making sure it's safe. So we got a couple wins here, but not all out. So let's go to a slightly more common, right? A lot of people use Infura or other providers, maybe Pinata for IPFS. And so you have this common infrastructure that you can connect up to. And let's see again, we'll apply again, once again, our fancy SDKs. But we haven't still solved so many of our problems, right? Our onboarding speed definitely increased. That's good. We've got a little bit easier Web 2 application integration. We've managed to get language independent with these third-party infrastructure pieces. We've got data access kind of figured out, but we still don't have queuing. Now we've lost our secure key space, right? It's on a third-party infrastructure server. That's a problem. So we were thinking, well, what if that infrastructure can be more interactive, can be smarter, more case-specific to our own use cases, right? What can we put kind of in that original diagram? What can we put in between those applications and the blockchain? And that is kind of where the sidecar pattern came to use for us. So here's an example application infrastructure that someone might build, obviously still simplified, but using frequency and the frequency social system, right? You've got your kind of all classic back-end pieces, right, that you need to do if you're trying to provide search over top of the systems of social media. If you're trying to provide user-specific details and streams, you may very well need to have a lot of back-end data that you're using, caching, to provide good experiences for your end users. But notice that this back-end no longer has to connect directly to the frequency or to IPFS. It doesn't need any of that access. Instead, we have this kind of sidecar slot that we can put in all of those pieces. And remember, we've got a lot of those pieces, and this kind of brings us to everything's green bliss, right? This has changed our ability to do onboarding. It's made it really easy for legacy Web 2 applications to really get up, because guess what legacy Web 2 applications speak? They speak API. They are really good at it. Doesn't matter what language they're using, they're really good at it. We've got our data access, we've got our ability to do queuing with Redis or other queues that can be added into the system, and all of this including a secure key space, because remember, it is not shared infrastructure, it's shared code. Right? All of this is still running inside of the application, the company who's running this application. It's running inside of their infrastructure. They're controlling that security model, but with the ability to also easily integrate. So this gives us all of this place to stuff all of that complexity that we have, right? Remember, we had a lot of complexity. We have that decentralized identity pieces that interact with it. We have those network interoptions like encryption keys and such. We have this encrypted social graph that also has to be compressed and paginated to get on chain. We have content management that gets batched and pushed out. All of that can get pushed into these little sidecars. In fact, we've split it out into multiple sidecars so that each one is as specific and independent as possible. So if you want to sit there and say, oh, well, I'm going to use the sidecar for the graph service. Graph works just like I want it to. That's great. Social graph, all good. But I want to do some crazy things with content, or I want to do something special there. You don't have to use the entire package. This is, again, a great piece of this kind of shared code that many different people can run. They can choose which parts of it they want to run. They could even fork it and modify it to run themselves. So, when do you think a sidecar, when do I think you might want to start thinking about a sidecar as a solution, right? Because SDK is a great solution. Infrastructure that's public infrastructure like IPFS and such, great solutions. When specifically might you want to use a sidecar? So one is services. So if your users aren't people, but they're computers, if you're actually doing infrastructure like this is doing for where the applications are saying, hey, we're going to take care of this, you don't have to worry about this complexity. If you're trying to talk to servers, sidecars might be a great solution for you, right? Servers are great at talking APIs. Last I checked, I didn't talk to humans in APIs. At least that seemed to be a more natural language interaction. But this can also apply if you're interacting with EIP 4337, the alt mempool, alternative ways to pay and such. This might also be a solution for you. So if you're trying to operate a bundler and you want a more specific bundler to your specific use cases, this might also be something to go look at. Another thing is if you're dealing with a lot of off-chain data, right? If you don't want the user to have to worry about validating data, going and fetching, I mean, do you really want your user to have to be interacting with IPFS? Now, I love IPFS. It's a great technology that they built and the other decentralized file storage systems, but it is not quick. It's not easy. It needs a cache in front of it. If you want to build a great user experience, you may not want your users directly interacting with that data. This also matters if you're dealing with data that might change over time, right? On the blockchain, we don't do too much of, I'm going to change the structure of data, but we might very well do that with off-chain data. However, with a nice API, we can hide a lot of that purely data structure changes and instead put that complexity all the way back into those sidecars. Finally, if you're trying to do Web 2 integrations, this, I think, is the biggest piece here that pushed us toward this solution, because Web 2 applications, they already speak APIs. They don't talk most of the time in Web 3 timescales. They don't think in probabilistic. They don't think about finalization, nor should they have to think about many of those things if the integration doesn't require it. So, are you not convinced yet? I mean, I thought I made a pretty good case, but maybe you're not convinced. So let's take a look at something most people are pretty familiar with here, ENS, right? ENS is a relatively simple setup, and it's got a nice, wonderful set of SDKs already. So congratulations to the ENS crew and all of their contributors. That's a long list. And yet, it still doesn't capture all of the languages that are out there. So we've already ran into that problem of if you're trying to interact with someone who's in an ecosystem that's not listed here, you're already potentially in trouble and having to port an SDK just for that. It's also, just what are we trying to do with it? So let's look at the simple resolve. If you're trying to just simply resolve something, you need a connection to Ethereum. Now, that might not sound like a big deal, right? But if you're a server, you need to make sure, hey, is that connection to Ethereum still up? What about retries? Do I need to retry? Do I need a failover? All of those different interactions when you're working at the server level. Do you care about finalization? Do you care if your ENS lookups are finalized or not? Maybe you do. Off-chain resolutions, right? ENS has wonderfully expanded out to L2s and using CCIP. Do you need to be able to connect to those? Do you want that details in your application, or do you want it in kind of a shared code base that you can use? There's also reverse lookup. Do you want to be able to verify the canonical address? Is this the canonical address? Is it not? Do you want caching? Do you want an interface that matches DNS and actually serving this up over port 53? Hopefully you're using HTTPS DNS, but All of those pieces lead to a large set of complex questions for something that is, at the end of the day, a 2-parameter read-only function, right? We didn't even get into the details of putting in a new ENS entry and making sure it's up to date and managing the resolvers and all of those pieces. And this is a great SDK. I'm not saying we should make a sidecar for ENS, but this is a great little example of how a sidecar can help answer a lot of these questions and make your infrastructure a lot easier. Okay, there's also a secondary benefit, and this is actually one of my favorites, which is you get great API documentation. API documentation has evolved over the years, but now with Swagger and OpenAPI, there is great UIs. You have a nice standardized way that almost any engineer can look at this left-hand side and parse it and understand what's going on. And then plenty of great UIs to interact with this. This is a system that, while not necessary, right? There's plenty of great API and great documentation for smart contracts and such. This gives you a much more feature-rich, right? This is specific. This is versioned, right? So you can talk about, hey, hit this version of the API. It's going to do something different. Oh, the underlying protocol is changing. We need to deprecate something. We need to throw an error. We need to return something. All of those become much more possible when you start interacting with API documentation that is actually both interactive and has things like mock servers and other things can easily be built out of it. So the final thought here, right, is at the end of the day, it's a question of where do you want to put your complexity? Your code, your protocol that you're interacting with, your blockchain, all of it has complexity, and your choice is kind of where do I put that? And there's a lot of different pieces, right, that go into that. Where is the cost? How easy is it for users? What are my users look like? Are they humans? Are they computers? How is that going to interact? And so all of those choices kind of come into play, and I want to make sure sidecars are kind of one of the things that come to your mind as you're thinking about, well, what's another place I could put this complexity? It hasn't worked to put it in an SDK. It hasn't worked to put it in shared infrastructure. And these kind of sidecars give you that option to do that. So again, I'm one of the contributors to Frequency. You can learn more about Frequency at frequency.xyz and read about kind of the sidecars and how they actually work. We have documentation and such you can read on there and kind of see how it works. If you're interested in socials particularly, I suggest go look at and decentralized social, go take a look, see how it's kind of implemented. And if you're just interested in the sidecar piece, go look at it and kind of see, oh, here's how they made decisions. Maybe we made the right decision, maybe not. You can feel free to please go to the GitHub and put some issues in, put some questions in, and I'll also be around later. With that, I'll see, do we have time for questions? Maybe one question. Anybody have one question? If not, I'll just stand up here for another 2 minutes and until this guy kicks me off. All right, there's one. Nope, not a question. I thought there was a question, but there's not. That's great. Hey, you can catch me afterwards. I'll be hanging around. Thank you again very much, and hope you enjoy the rest of the conference.
In a row. What you building? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Like runs down a fountain. Age? Old to speak, young as each block mine down. Professor Wade's got the future on spinball. Urging notes, dancing where the bottlenecks been. Professor Wade's got the future on spinball. Plugging tomorrow with yesterday's ram stains. Throwing me mad, but mad's just a beta test for Boodle. Oh, he jumps right to oh, he jumps right to oh, he jumps right to he jumps She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking Ethernet whiz. Found her at a bullet hook sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange drools over slow motion duel. Her shield's a disco wall, fracturing legs, grass, shooby-doo-ba-crack. That lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bluff the corn's grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Architect with a buffer corn's grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do-do.
Hello, everyone. Thanks for joining my talk today. I am Mickey Nagus. I'm a senior engineering manager at EdgeNode, which is a core developer of the Graph protocol. My topic today is Decentralize the Help Desk, Redefining Web3 Support. So I intend to share some lessons learned from the Graph in providing support for a decentralized protocol. Let's get into it. All right, so if you're unfamiliar with the Graph, this is a pretty simplified view of our protocol, but ultimately the Graph is a decentralized indexing solution. So we're indexing blockchain data and then organizing the world's knowledge and information. At a high level, dApps ultimately need blockchain data to display on their front ends, and it's really arduous to do that themselves. So what they can do instead is develop a subgraph, which is an open API. By developing their subgraph, they're able to access blockchain data that indexers have already indexed and organized for them, and then that way they can display the data directly on their website without doing the heavy lifting. If you work for a Web3 protocol and you're interested in providing support for a decentralized protocol, you probably have similar roles in your ecosystem as well. And providing support for multiple different user personas can be complicated. So I'd love to share what the Graph has learned. So when we look at the current Web3 support landscape, there are a number of challenges in providing support for a decentralized protocol. Decentralization is our superpower, but it does introduce a lot of challenges around coordination and communication. Common Web3 support frustrations include a lack of accountability. Often users don't even know who's responsible for providing support in the first place. Oftentimes there's no source of truth around documentation or troubleshooting information. And when they do receive support, a lot of times users see very, very slow support response times. And if they do receive support eventually, often they're met with canned responses or protocols that overly rely on bots. So the challenge is, how do you provide timely, world-class support across a decentralized protocol? And we believe at the Graph that for Web3 to reach its full potential, we need to rethink how we support our users and their unique needs, and how do we create systems and processes that are collaborative across a decentralized protocol, but ultimately responsive to solving customer issues. So in doing this, it's actually quite natural to look at Web 2 for inspiration, but there are a number of existing flaws in Web 2 support models. So while there are some pros and cons in leveraging Web 2 support systems, the pros being maybe there's tooling that's already been vetted and proven to work at scale, but the cons being often Web 2 companies are centralized, so they own the complete end-to-end technical support hierarchy, they own all of their tooling, and everyone who provides support works within one single centralized company, which is just not the case for Web 3 protocols. So in a centralized Web 2 support model, the speed of response for customer issues and the quality of service provided are often constrained by the technical skill level of L1 support engineers, your first layer of support, and also, frankly, by business hours. So some Web 2 centralized companies offer global 24/7, 365 support, but a lot of those companies also don't do that. And we don't have an option in Web 3. Support needs to be on and available 24/7, 365. Or else, if you only operate support against certain business hours, you create a ton of bottlenecks for your users. So Web3 protocols can and should leverage the parts of Web2 support that make sense for them, but ultimately we believe that providing world-class support in Web3 requires a revamped approach. So let's look at the graph solution. Our goal is simple. We want to keep users at the center of everything we do in providing support, and we want to ensure that the support we're providing is as sharp and performant as the technology that we're building. There are many contributors to the Graph protocol, and we have successfully set a gold standard for decentralized support in Web3. Instead of keeping this internal, we don't want to gatekeep it. We want to share our lessons learned with other Web3 protocols so that everyone can help level up the support UX across all of Web3 together. So let's get into it. I'll now cover the Graph's decentralized support playbook. So we've centered our support around 3 pillars: people, processes, and tooling. These 3 pillars have enabled us to provide world-class support across a decentralized protocol. Let's look at pillar 1. This is our people pillar. So our level 1 L1 support engineers are technical. In a lot of cases, the L1 support team at many companies are actually non-technical, and they often serve as just a router for copying and pasting user issues to another tier in the support hierarchy, and we have done away with that. Our L1 support engineers are extremely technical, they are users of our protocol, and they're able to resolve user issues much faster. Number 2, you need to build a follow-the-sun distributed team. As I mentioned before, Web3 doesn't sleep. There are no business hours in Web3, and so you need support engineers in major regions around the world to support your global user base. This one's kind of contentious, but I believe we should provide no canned responses ever. This is because when you have canned responses, it drives a lot of back and forth between your L1 support engineer and a customer to even get to the root of their issue. And by doing away with canned responses and providing bespoke messages to each customer, we found that it's way faster for our L1 support team to identify an issue and resolve it. Next, borrowing this from Jocko Willink's book on extreme ownership, but you should establish and reinforce a culture of extreme ownership on your team. Your L1 support engineers should know that each customer issue is theirs to own until they resolve it or escalate it to another tier in your support hierarchy. And lastly, we're at a hackathon here today. If you're offering a bounty from your protocol, your technical support team should know exactly when the hackathon is occurring so they can resolve issues. If your devs who are trying to go after your hackathon bounty experience issues at a hackathon and they don't get timely support, it impedes their ability to pursue your bounty. So your tech support team should also be plugged into providing support during hackathons or other real-time events. All right, jumping into pillar number 2, this is our process pillar. So first, we suggest you set a competitive time to first response, or TTFR, SLA. Whether you advertise this as a formal SLA publicly or just an internal TTFR target, this is very important in ensuring your team members know what the baseline time is that they have to respond to customers within. Similarly, if you're offering an uptime or quality of service or reliability SLA, you need to look at all of your upstream components, software, and services. If your upstream services offer a lower reliability SLA than you offer, you're putting your ability to achieve that SLA at risk. Next, you should enable different contributors across your decentralized ecosystem to participate in the support model. An example being your L1 support team doesn't actually need to be your Discord community moderators. If you have, let's say, a DAO in your ecosystem, you can put out a grant for the DAO to manage your Discord server and allow your L1 team to remain focused on resolving customer issues. Next, you definitely need processes for writing RCAs, root cause analyses, or postmortems when you have major breaking issues. This is a key process for you to have in place to ensure you are solving these major breaking issues at the root. Nothing drives customers crazier than dealing with major outages over and over and over again. So this process is key in ensuring you don't have repeat issues arising. And lastly, you should be bringing support to where your users are. If they're on your website, they should get support there. If they're in Discord, they should get support there. So ensure you have processes in place to bring your support team members and monitor and respond to customer issues across platforms. All right, lastly, pillar 3 is around tooling. So bots are totally okay to use, but you still need humans too. But by using bots, you're able to outsource responding to repeat, low skill, low technical issues, and then again, free up your L1 human support engineers' time to focus on more complex issues. Chatbots that we like at The Graph include Pluno, formerly Awesome QA, as well as Katara and Cookbook.dev. Those are all great options. Next, you need data and metrics. For us, we rely on Astronaut to provide us with sentiment analysis and different pattern insights, as well as TTFR response time metrics. I'll talk more about Astronaut in a moment. You should also implement a ticketing system or similar tooling on your website. So even if you're providing support primarily in Discord or Telegram, asking a user to churn off of your website and go find your Discord server to get support just creates more friction for them. And so offering a ticketing system directly on the website will help your users get more timely support. Next, you'll want to develop an observability strategy to level up your monitoring and alerting. So this includes building out dashboards using tools like Metabase or Grafana to give your tech support team insight into the health and wellness of your protocol and any services that might be failing. And then surfacing metrics using Grafana and then Victoria metrics or Prometheus metrics, and then creating alerts is helpful in ensuring you're triggering a page for your on-call engineer to respond to critical issues within a certain threshold. And lastly, I mentioned on the last slide, you need to bring support to where your users are. And so if you're providing cross-platform support like the Graph, you'll need additional tooling in place to help your team manage that complexity. An example is if you have hundreds of Telegram chats with users, you can use a service like 3RM to send out mass messages across multiple Telegram chats. All right, so we talked about some of our guidelines that we wanted to share with you. So what are the results of all of these changes? So if we flash back to 2022, the support response times for users of the Graph was roughly 1 to 7 days, which is actually pretty typical for Web3 protocols even today. We started identifying and fixing many inefficiencies in our support model. We expanded our L1 support team at Edgenode, where I work. We clarified roles and responsibilities with our ecosystem supporters across the protocol. We implemented improved tooling, and we onboarded our secret weapon, Astronaut, for providing cross-platform support analytics. And when we look at our results today, we are able to say with high confidence that the L1 support team's median time to first response is 3 minutes. So by implementing the guidelines we covered today, we've brought down our support response times from up to 7 days down to 3 minutes median TTFR. Have our customers noticed? Absolutely. Here's a quote from Fabian, founder and CEO of Snapshot Labs. No matter the time zone or issue, the Graph support is always available. Slack, Telegram, Discord, ticketing, every channel is optimized for speed with real-time guidance from experts who actually build on the protocol. Our users have definitely noticed an improvement. I mentioned Astronaut. So in addition to our L1 support team, an incredible team of mission-aligned engineers, Astronaut has been the other key to success for us. Astronaut's a platform that enables enterprise-grade customer support across multiple chat platforms, and it has been crucial in our ability to track our median response times to users and know where our bottlenecks are and improve them. So here's how it works. You can easily integrate Astronaut with just a few clicks. You integrate Astronaut with different channels on Slack, Telegram, or Discord. Astronaut offers conversation intelligence, which is a really cool feature. It automatically identifies and connects related messages across busy group chats. It offers intelligent tagging. It's automatically identifying bugs, support requests, and other product feedback. And it's offering us deep insights and amazing analytics around the question volume we receive from users, our response times across platforms, performance metrics broken out by team member, different days of the week or times of day. It surfaces outliers, so if we miss our response target and have an outlier where it took us a very long time to respond to a user issue, Astronaut easily surfaces that to us, so we're able to identify where we still have bottlenecks and solve them. And lastly, it identifies recurring issues or themes reported by customers. A quote from Ayola John, the co-founder and CEO of Astronaut, also in the audience here today. The graph has set a new standard for Web3 customer experience. Before Astronaut, tracking response times across hundreds of Telegram conversations was a manual nightmare. We built our platform to help teams like theirs deliver world-class support while preserving Web3's open culture. And this summarizes our experience very well. It was a nightmare trying to even understand what our baseline TTFR was, let alone know how to improve it. All right, so what's next? This has very much been an iterative journey for the Graph protocol. We have been able to deliver world-class support by continuously adapting, learning from our customers, and innovating ways to apply some Web 2 technologies as well as Web 3 specific improvements. By addressing the unique challenges that a decentralized ecosystem faces while prioritizing the UX of support, we have been able to deliver fast, efficient, and responsive support for our users, getting down to a median 3-minute TTFR. So as Web3 continues to grow, we encourage teams to remember that people, processes, and tooling are the foundation for excellence in providing world-class support for Web3. We'll continue to listen to and adapt based on user needs, but we wanted to share these guidelines with you in the hopes that we can level up the Web3 support experience. So if you'd like to get in touch, connect with us by going to thegraph.com. You can access support from the website, as I mentioned. You can review our docs and other information. You can follow @GraphProtocol on X. If you'd like to get in touch with me, I'm happy to chat about support anytime. You can hit me up on Telegram at Mickey_Negus or email me at mickey@edgenode.com. I'll also hang out here on the side after my talk ends if you'd like to chat in real time at the event. But with that, again, I'm hoping these guidelines have been helpful to you. Take whatever resonates, leave behind what doesn't resonate with you, and let's improve the support UX across Web3 together. Thank you.
She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking, ether night whisk. Found her at a bullet hook, sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange drools over slow motion doom. Her shield's a disco wall, legs grass, shooby-doo-bah crack. That lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bluff acorns grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Architect with a buffercorn's grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with a do with a do with do with do you ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a mempool express. Next bottleneck, I see mountain crush it. Click, clack, goes a mace on firewall. I spooked and truce from trash sheets. That's my device. Nullifier sniffing by my cokes too crisp. Mainnet gossips, tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. You private DMs, I'm the dumpster dive chump. Eyes everywhere, match 3 bird phones. Haunteries whisper, king chomp and blockchain bones. Make it down, top it, fuck. Stealth crawl through your junk dead scene. Man it up, the entropy. Mace cracked vaults like, who's got the keys? Nullifier's huffing, you're just a rat with His firewall splinter to confetti bits. I'm curating leaves at the after party, sipping TLS tears. Call me well connected, I call it coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. They rock on PI. Get homemade in 7/4 time. Shaboom, dose, efficiency pulse. The lag runs lagging in his latency sub. Professor Waze got the future on spinball. Urging notes dancing where the bottlenecks been. Professor Waze got the future on spinball. Bugging tomorrow with yesterday's RAM stains. Velcro boots clicking through blockchain debris. cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor weighs out the future on spinball. Urging nodes dancing where the bottlenecks been. Professor weighs out the future on spinball. Hugging tomorrow with yesterday's ram stains. Chaos is not compeller. Order's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI? Nah, just 3 Red Bulls in a row. What you building? Prop? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Like runs found. Old as speak, young as each block mine down. Professor weighs out the future on spinball. Urging nodes dancing where the bottlenecks been. Professor weighs out the future on spinball. Hugging tomorrow with yesterday's ram stains. Throwing me mad, running me mad's just a beta test for Boodle. Jobs got to do affordable.
Hello, everyone. My name is Márton Csernai, and I'm very excited to be here. I will be talking about identity, privacy, and security in the new age of AI agents. Briefly, a little bit of background about me. I come from a research background. I did a PhD in telecommunications and network science. Then was a postdoc at the neuroscience lab. And in 2018, I joined the crypto scene. And I was working at Kilt Protocol in the Polkadot ecosystem, which was mainly about credentials and decentralized identity. And since 2024, I started building my own project around AI agent platform, and how we can work together with AI agents as humans in a seamless way. So the content of the talk will be, I would like to give a brief overview of the current identity concepts, what privacy implications those have, what are the security mechanisms that we can attach to these concepts, and then put them together into actionable items. So what is an AI agent? Like jokingly, you could say that it's easier to build an AI agent than to explain what it is. But more concretely, I would say it's an autonomous software entity that acts on behalf of users and makes decisions and executes actions. Now, you could say, or you could see that how we go from simple automation to an AI-based workflow, and then to an AI agent. And the main concept is that an AI agent is a fuzzy and autonomous system, and the reliability is much less than in the simple automation. And so the identity of an AI agent, the key thing to see here is that AI agents have distinct identity needs that account for their transient nature and their delegated authority. So human identities are quite static, and AI agents need dynamic content-aware identities. Also, we can think of it as ephemeral identities that reduce attack surface, but this also complicates auditing. And delegated identities must preserve chain of custody for compliance. And as a simple use case, we can say that in a healthcare, like a diagnostic AI agent would be accessing patient records that both need ephemeral session identity and a persistent organizational identity. So the key challenge is that AI agents are both autonomous, but they need to be constrained. And one of the key problems is over-permissioning, which we can see there was a big agent breach in Microsoft due to a broad use of the Graph API access. The current frameworks are moving towards accompanying or accommodating AI agents, but we don't really see the ready-made frameworks for AI agent identities. And also, like, monitoring is super important, and traditional security information and event management tools miss 73% of AI agent anomalies. So one key thing here is that OAuth 2 already handles 80% of agent authentication needs. The key thing, or like what you need to be aware of, is the proper scoping of these OAuth authorizations. And so the technology is there, it's just we have to use it the right way. And so regarding decentralized identity systems, we have two approaches that we can take here. One is a simple peer-to-peer decentralized identity system, which is based on this conflict-free replicated data types. This is the same technology that Google Docs uses. Basically, you can edit documents with your colleague at the same time, and there are no conflicts. Somehow, there is a protocol to make this happen. And the other concept is the blockchain-based decentralized identity, where there is a central source of truth where the identities are anchored to. And both have their pros and cons. One thing to note is that revocation, authorization revocation, is challenging in the peer-to-peer version, easier to do in the blockchain-based version. But the blockchain-based version incurs a bit more delays and costs. So it makes sense to use hybrid approaches. Like, for example, for routine operations, one would use the peer-to-peer approach, and for higher value operations, you would use the blockchain-based part of the identity. So regarding privacy in AI systems is a feature of identity management, not just data protection. So zero-knowledge proofs enable proof of compliance without data exposure. So trusted execution environments can provide model confidentiality. Differential privacy can help with agents learning capabilities in a private way. And for example, ChatGPT already provides a way to opt out from getting, so that your data that you enter into ChatGPT and ends up in their training data, you can opt out from this. So it is also like this, you have to find that little box in the configuration of ChatGPT and click it, and then you're already in a much safer, more private way. Regarding security, I would say that AI security requires moving from perimeter defense to identity-bound defense. So that means that usually in human-based identities, we secured the resources. Here, we have to think about what kind of authorization we give to each of our agents, because in many cases, we will work with a whole agentic framework with hundreds or thousands of agents running in that framework, and they cannot have the same authorization that comes from my user identity. And there are ways, for example, agent-to-agent TLS prevents man-in-the-middle attacks for multi-agent workflows. Behavioral attestation can use machine learning to detect agent drift. And also one of the case studies, like a 50 million deepfake scam, shows that we need to have continuous authentication, which means that it's not enough to log into a system once and then use that for months, but there is a need for AI agents to be authenticated continuously on a per request basis. So a bit about regulations. Regulations are converging on auditability as the cornerstone of AI. So one of the main thing in Europe is the new AI Act that's becoming active this year. Fines up to 35 million or 7% of the company's worldwide annual revenue. So that's the amount that governments can fine a company, so it's pretty steep. In California, there are new regulations that say we need a meaningful human review in the process of handling with AI, and yeah, so there, just in general, there is a need for compliance strategy to implement immutable audit trails around agentic systems. And also we have an emerging ISO standard for AI management systems. Regarding implementation, just a couple of things to note. We have to secure delegations chains, which means the authorization and delegation. So I delegate the right to my agent to tweet in my name, but maybe it cannot read my tweets. It can read other data. So that's what we mean by delegation chains. And context awareness. Context is super, super important for AI. And we want to monitor how the context gets put together and how that can leak out. So a bit about current protocols or emerging protocols that are built on current systems and protocols. OAuth extensions now. So if you look into the OpenAI API controls, there's a huge level of different scopes that you can set up for your API keys. And this is the way that we see that there's a very, very high level of fine-grained control for OAuth scopes. Verifiable credentials is a concept that's been around for a couple of years, and now there is a new action force around AI agent identity. Also, other policy-based access frameworks and conventional Kerberos systems start to integrate and handle agentic systems. One thing to regarding like what's coming in the future, on-device AI or on-device agents, which means that we will be able to run an agent on our phone, which is pretty cool because it can use the data that's locally available on my phone, and then that agent will somehow authenticate, will get its delegation or authentication from my phone or from my accounts that I use on my phone. And this is a really interesting. So I will not. I wouldn't even need to go to a central place to get my credentials, because I could have my credentials already on the phone and everything on the phone. The other thing, cross-platform tools and analytics, and also like system integration. Like that's one thing that's probably going to be a very not high, but very important part in the next years. How do we integrate agentic workflows into current legacy systems? Okay, so just to put this into like a context or wrap it up. First point, use OAuth scopes, and you are more or less more or less on a good way or secure with authorizing your agents. We don't need completely new authentication systems. The other point is privacy starts with the training data, what goes into the training data, what can leak out from the training data, because all the other things they didn't really change. The only thing that changes with AI agents, what got into the LLM that we're using, and if we fine-tune that LLM with our private data, then we don't want that to leak out. So that's number 2. And then the third point regarding security, I think that security in regards to AI agents and agentic systems will be compliance heavy with human oversight. So you could say that you could automate a lot of compliance things and reduce the amount of human intervention in the last in the last decade. And now I think we will move in the direction where we have already a lot of automation for compliance, but now we will have to put back the human into the loop in very crucial points of agentic workflows so that we can monitor and control the outputs and the operations of agentic systems. And I think this will be more or less what I wanted to talk about. As a wrap-up, thank you for your time, of course. If you want to learn about what we do, then please go to our website. You can reach me on Telegram or on GitHub, X. So with Gigantic, my project, we are building a platform where we can seamlessly integrate human professionals, freelancers who can build their own AI agents, deploy it on the platform, and monetize them. and they can do this. They can build their agents and connect their own private data. And then by using the platform, they can share the revenue with the platform and then build a reputation for their agent. And we are thinking about focusing on the compliance aspect, how the human freelancers, human professionals can check the work that their AI agent is doing and sign off on that work when they deliver that to the customer. So that's one of the key concepts in our platform. All right, well, thank you very much, and looking forward to connect. And if you have any questions, let me know.
Professor Way's got the future on spin. Plug in tomorrow with yesterday's RAM stains. Throwing me mad, but that's just a beta test for Boodle. She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking Ethernet whiz. Found her at a bullet hook sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-bop crack. That lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bluff the corn's grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Architect with a buffer corn's grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with for do with for do with do with do you ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN.
Hey everyone, Web3 has a big problem. User experience. I think we can all agree with that. All of us here have probably got past our first wallet, but I think 99% of the population haven't quite. And I want to ask you a quick question just before I proceed with my presentation on building AI agents on Hedera. Can AI agents fix that? We'll find out. So just want to quickly say, this can be quite interactive. I'm just put up on my screen. That's my Twitter. I'm not telling you to follow me. More than welcome to. If you have a look at the pinned tweet on my Twitter account, or you scan that QR code, you'll get taken to a Google Doc which contains information as to how you can set up the relevant tools and agent SDKs that we're going to be using. So I'll leave that on here just for the time being. While people scan it or scan it for later or have a look at my Twitter and get it up on your laptop. On it, you'll find instructions how you can interact and run the Git pod for our ELIZA plugin, ELIZA being a very common AI agent framework, and also how you can set up our Hedera agent kit and LangChain integrations. Cool. Before I just continue and talk more about the agents, I'll give a very brief background as to LLMs and what they are. I'm going to assume a lot of people are using them regularly, but on a very high level, neural networks trained on loads and loads of data. You give it a prompt, it basically predicts what's going to come after that. It generates, whether it be text or images or other media forms, based on the probability of all of the feed data it's taken in that big training phase. And AI agents. What are AI agents? Well, they basically use large language models alongside tools or actions which are deterministic pieces of code that an AI agent understands. It knows, okay, I've got this function over here. It might be a JavaScript function or a Python function. I've got this function. I know what that function does. Maybe it creates a token, and it knows the arguments and the required data to execute that function. If you haven't already noticed, these images are all generated by AI. So unfortunately, our agents or any agent, they don't have ABAPI quills or database quegies, but they do have API calls and database queries as well. So I thought that was quite funny. And yeah, maybe not the best at generating text on images yet. All right, so what do we have on Hedera? Well, we've got our Hedera Agent Kit SDK. This is essentially a JavaScript TypeScript class which aggregates all sorts of different functionality on Hedera. It's relatively opinionated, but the beauty of this is you can just use this and integrate it with any sort of existing AI agent framework. We've done that with our ELIZA plugin. I'm going to be showing that today. If you scan the QR codes earlier, you'll also be able to follow along. And also our Hedera LangChain/LangGraph agents. All of those are essentially using the Hedera agent kit. But if you're wanting to build maybe a autogen agent, you could use the Hedera agent kit and leverage that. Also, before I quickly go to actual like a live coding demo where we can see these agents in action, we do have 3 bounties this year. Top one, AI agents, $25,000. That's split over the top 4, so the winner gets $15,000. And we've got EVM stuff as well, Explorers for those of you who are sort of getting into Hedera. But that's a perfect time to sort of leverage some of these tools. You can maybe build a dApp which integrates them. I mean, but also it doesn't need to be with agents, or you can actually contribute to our open source SDKs. All of that information is on this Google Doc. I'll quickly share that Google Doc. So if you go, again, on my Twitter, that pin tweet, AI agents on Hedera, as well as it's got setup guides. I've already started the setup, so I'm going to show you how to run the Gitpod environment for our ELIZA plugin, and then also we can test out our LangChain, LangGraph agent. And let's start off with our Hedera agent kit. Now, we do have that might need to be lowercase. We do have an open API kit or a router API key which you can use. So be quick and sort of, there's not loads of credits, but if you want to test it out, you can do that. I'm going to start plugging it into our Gitpod environment. If you want to follow along, click on that open Gitpod. It will start setting up in the background. By now, mine should already be installed and it's been built. All I need to do is just pass in my API key. So I'll allow that. And then I need to go to my Hedera account ID. So I can find that actually on the Hedera portal, which if you go over here, let's click on that. Go to the Hedera portal. You can create your own account over here. We'll use this account of mine. With the Hedera portal, you get 1,000 HBAR, testnet HBAR every day, which is more than enough for basically anyone, unless you're really stress testing the network. And I'm going to get the private key as well. And this is a ED25519 key. You can, of course, use ECDSA key. So just for you EVM builders here, if you do have an existing MetaMask wallet, you can use those exact credentials over here. ED25519. Cool. So that's now set it up. It should automatically starting the application and also running the front-end client. I'm just going to be doing a few demos, just showing the user interface, which comes out sort of out of the box, and we can start playing around with it. But of course, if you're familiar with it, has anyone here used ELIZA, actually? I guess I can gauge how deep to go in. Is ELIZA over there? Anyone else heard of it? No? Okay. Heard of it? Cool. Right, well, I'll give a quick TLDR on ELIZA. Pretty exciting framework, open source framework for building LLMs. Very popular in the Web3 space, not so much sort of in the Web2 audience. But it's pretty cool because they've got really nice integrations into things like Twitter or X or Discord, Telegram. So you can have your AI agent almost being like a social agent, having its own personality, its own character file, as well as other plugins like the Hedera plugin, which would allow it to potentially create tokens, send tokens, trade, whatever sort of, whatever your mind can think of. Before I go into that, I'll show broadly what the ELIZA structure is. So I've got these character files over here. We're currently using this Hedera character JSON. It's sort of specified for the Hedera functions, but there are also other character files that you can use. This gives your agent its personality. So yeah, we'll be using this one, which is sort of optimized for Hedera. You can also see plugins and import different types of plugins. You can have EVM plugin, you can have non-crypto plugins, but we'll start chatting with it. So this is the client which gets spun up. You don't need to build agents using this. Let's just make sure it works. Hello. Moment of truth. Hey, good stuff. Cool. Well, let's show some of the functionality that it has. And our plugin is pretty extensive because it leverages that base Hedera agent kit class. So if we go over to our plugin, you can find that inside of this directory, Hedera plugin ELIZA, and you can see inside of the actions all of the all of the functionalities that we have. So these are the actions, which is importing from that base Hedera agent class, making it really easy to integrate with frameworks like Eliza. And these are all of the tools or the actions which the AI agent understands. And sort of if we have a look at any one of these actions, we'll see it comes with a qualitative description. It comes with examples as to potential prompts that might be used to trigger it. And let's have a look at there should be a description here. It associates the provided token with a given account. This is what the AI agent uses to determine which function do I need to call. So we can say, hey, create a token for me called ETH Denver. And we could say with a symbol, that there are a few minimum requirements that you need. So we need a symbol, ETHTD, and also with an initial supply of however many that is, and 2 decimals. So this qualitative prompt, the AI agent will be understanding this and going, okay, this guy wants to create a token. Hang on, I've got a function which allows creation of tokens. And as you can see, we've created this token. Back to my point on the easier UX, potentially making it easier for people to interact with stuff that typically might have a bit of a learning curve, maybe needs to be a developer. And we can see on HashScan, which is the block explorer for Hedera, that token which has been created. Nice user interface, which one of our friends, Ali, at the back has really been leading on. So shout out to Ali. But it's a really nice new user interface, and I'll stick with dark mode. Cool, so that's sort of creating a token. We could also transfer that token just by doing a similar sort of prompt. But I also want to share the LangChain agent, which doesn't have some of the features which the Eliza agent has. It's sort of less aimed for a Web3 social environment. It doesn't have immediate integrations to platforms like X. But it does have other benefits, like plugging in really well to the LangChain library. LangChain is one of definitely the first LLM framework or sort of tool set which I was familiar with. It's been around for a good couple of years now, and definitely on the enterprise and in the Web 2 world, LangChain is really leading the way. So we can also let's also play around with the LangChain agent. I've cloned the repo. These instructions are on this part over here, test LangChain / LangGraph agent. I've cloned it, npm installed, I've done my whole environment setup. Let's go for the test, and what this does is it pulls up just a CLI chatbot where we can also hang around and start interacting with it. Now, I'm showing you a very, very superficial overview as to what you can do, but as I sort of mentioned earlier, these are the total depth of functions that you can have. We've also had a really happy about this. One of you guys yesterday came along, we were talking about it, and they did a pull request last night for support with one of our leading decentralized exchanges. So big thanks to Kamal who did that. And I want to echo what I said earlier. If you're contributing to our SDKs and you want to apply for one of these AI agent bounties, this is valid because it's AI. So if that's something which you're interested in, if you've got your own little project, you need some extra plugins, you can sort of double up, and I think that would be a really great look. Okay, back to our agent kit. So we've now got the option to go autonomous mode or chat. I'm just going to do chat because it's a bit safer. And again, we can sort of be really quite flexible here. We can say, hey, let's create another token, create a token called test with the same symbol and that many initial supply. Yeah, we do incorrect spelling mistakes. AI is pretty clever now. There we go. You can actually also do this in other languages as well, because again, these sort of GPT-4o models are pretty decent. So you can even do this. And again, back to my earlier point on user experience, having that interface where you can actually interact with it in multiple different languages could also be a value add for any use cases which you're looking to build. So it's now created it. Let's do some examples of airdrops. I've got my wallet over here. Let's go. This is a different account, so I'll airdrop it to this account. Airdrop that token to this account. Oh, 29, yeah, 29. Send them 500 of them. I'll send 5,000. So that's done it. It's obviously remembered within that sort of context memory that, okay, that token is the one which we previously created. And then we can also do things, I guess let's try out the query, get HBAR balance query. So get the balance of that account that I just dropped. I just airdropped. So again, it's sort of, it's contextualizing it within that whole, with that whole sort of short-term memory, and the account of that account is a balance of 5,000 test tokens. Okay, cool. So it's actually done that. I mean, we can also specify, get the HBAR balance of it. And that should be also supported. Balance 426, balance 426. There we go. So this is really just a very high-level overview as to how you can sort of set it up. Obviously, we do have that AI agent, the AI agent bounty, where if you're using one of these tools, that's great. Don't have to use these tools. You can look at stuff AI Providence. But this is really exciting because we've been working pretty hard on getting these open sourced and out on the market ready for you people to use. So I wanted to give a really quick overview just as to how you can set it up. This doc is almost that golden source of truth. And you can set up the ELIZA plugin, try it out on Gitpod, then start implementing it with your relevant specific use case, looking at where it plugs in with other functions, with other actions, and maybe having it on X. Maybe you want to have it where it's sort of creating tokens, transferring tokens, trading them. I've got a few minutes left. I mean, I can keep on prompting it and pushing the boundaries, but I mean, if anyone has any questions, now's also a good time. Happy to answer them up here. And or maybe we can push it to the limit. You test me with some prompts to try out, and we'll see how robust it is. But over to anyone who's got any questions.
This might be like pushing its functionality, but I was curious if you could like extend it to do like maybe like a Uniswap or something.
That's a really, so that sort of ties in to that pull request, which one of these absolute legends did yesterday. He's definitely in the Hedera good books. He's integrated it with SaucerSwap, which is essentially the Uniswap equivalent. But yeah, you can do that. I mean, and again, honing back to that rhetorical question, which I said at the beginning, can AI agents make the user experience for consumers, people who don't really have the best understanding of DeFi, all of the concepts, or maybe even just sort of wallet management? You could even do stuff to the extent of, okay, I have X amount of HBAR, ETH, whatever that token is. I've got a high risk tolerance. Find out for me what a good strategy is. And then you can have an AI agent which goes, right, okay, there's a plugin to scan all of the yields of a particular decentralized exchange, or potentially the borrowing and lending rates of a particular exchange, and then go through that end-to-end process of, right, you've got your HBAR, swap it for another token, and then provide liquidity to a particular token pair, and tell that all to the user. You could do a user sort of human-in-the-loop approach. That's what LangChain's really good at. LangChain's got some nice functionalities where you can sort of get the LLM to get to a certain point, and then it goes, right, stop, user, do you want to continue? Yes, no. That's pretty nice for some of these more riskier use cases, or you can sort of go YOLO mode, just do it for me. These are all things which, I mean, potential ideas for you guys. Building user interfaces for this is definitely a great use case where AI agents can really shine. So yeah, hopefully that answered it. I'll leave the floor open because that was a good question. Hopefully we can get a follow-up as good or better. Ah, love it. Bro, ask away, man. Ask away.
Just a question.
Bro, I love
have
questions.
Lots of them. You said that it has LangGraph implementation.
Yeah.
Do you have like the base flow that we would be extending off of?
Yes.
Or
yes.
So that can be seen. Is that like you have that graph?
Yeah. So LangGraph is LangChain started like a couple years ago. It was mainly good for things like RAG and just creating these pipelines. But obviously, AI has developed quite a lot since then. So they then had LangGraph, which I believe is specifically for agents. Don't hold me to that. But agents is definitely one of the core offerings of it. And as you can see, so what we're basically doing is similar to ELIZA and similar to any framework. You have your deterministic function, which here is using the Hedera agent kit. We've got this create FT method that can take these object sort of parameters. Some of them are required, some of them are not required. But all that we do is you extend the LangChain-based tool. You can then create your own plugin. I mean, it's so easy. It's just like mind-boggling. You give it a qualitative description. This is what LLMs understand. And then you can use this. We've got an example implementation in that test script. So over here, we're importing currently all of the tools that we have support for. That's just in this helper method. That returns an array of the tools. You can be more selective. This maybe all of these tools, if we go to that. So let's go to, not that one, create Hedera tools. So currently, these are the tools that we have supported with LangChain. We've also got consensus service support. It's not yet been integrated here, but by tomorrow it will be. And you don't need to use all of these. For your use case, maybe you just want to have a create fungible token. Maybe you just want to have a create fungible token and transfer or airdrop. And that would, of course, make the model a bit safer. I've only got 20 seconds. That will make the model a bit more likely to execute the correct thing because there's less, almost entropy, less room for error, and also slightly cheaper because that token price will be reduced. Okay, 8 seconds. I'm going to show you how you do this. So you've got the stuff over there, you import the list of tools that you want, and then you just use this create React agent that's coming out of LangGraph, and then you go, let's go, time's out, hopefully they let me on for a bit longer. Over here, you pass in the LLM you want, that can be any LLM, and then you pass in that tools array, and that's how it has access to it, plus message modifier. Cool, that's me. Hope everyone enjoyed that, and hope you're also building AI agents.
Tears, call me well connected, I call it drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. They rock on P Island. Get homemade in 7-4 Shaboom goes the efficiency pulse. The lag runs lagging in his latency so. Professor weighs out the future on dancing where the bottlenecks been. Professor Wade's got the future on spin. Plug in tomorrow with yesterday's days. Velcro boots clicking through blockchain debris. Crypto notes flutter like drunk bumblebees. Optimize the board fins, they cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Wade's got the future on spin. Urging nodes dancing where the bottlenecks been. Professor Wade's got the future on spin. Plug in tomorrow with yesterday's RAM stains. Chaos is not compeller. Order's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI? Nah, just 3 Red Bulls in a row. What you building? Prop? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Like Ron Styler found. Age? Old as speak, young as each block mine down. Professor Wade's got the future on spin. Urging nodes dancing where the bottlenecks been. Professor Wade's got the future on spin. Plug in tomorrow with yesterday's RAM stain. centuries, Colorado Comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking, ether night whiz. Found her at a bullet hook, sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagron drools over slow motion duel. Her shield's a disco wall, fracturing legs, grass, shooby-doo-bop crack. Ooh, that lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bluff the corn's grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Architect with a buffercorn's grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with for do with for do with with do you ordered a moonwalk across gas feet graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. Your private DMs, I'm the dumpster dive chump. Eyes everywhere, match 3 bird phones. Haunteries whisper, king chomp and blockchain bones. Make it down to my voted fuck. Stealth crawl through your junk dead scene. Ran it up to the entropy. Mace cracked vaults like, who's got the keys? Nullifiers huffing, you're just a rat with These firewall splinter to confetti bits, I'm curating leaves. At the after party, sipping TLS tears. Call me well connected, I call it coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti, they rock on PI. Homemade in 7 Shaboom goes the efficiency pulse. The lag runs lagging in his latency sub. Professor Way's got the future on spinball. Urgent notes dancing where the bottlenecks been. Professor Way's got the future on spinball. Bugging tomorrow with yesterday's RAM stains. Velcro boots clicking through blockchain debris. cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Way's got the future on spin, boy. Urging nodes dancing where the bottlenecks been. Professor Way's got the future on spin, boy. Plugging tomorrow with yesterday's ram stains. Chaos is not compeller. Order's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI? Nah, just 3 Red Bulls in a row. What you building? Prop? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Light runs dial up found. Age? Old as speak, young as each block mine down. Professor Way's got the future on spin, boy. Urging nodes dancing where the bottlenecks been. Professor Way's got the future on spin, boy. Plugging tomorrow with yesterday's ram stains. Calling me mad, but mad's just a beta test. A boodle. Oh, he jumps right to you. 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 We're biddlers, not just dreamers. On-chain truth, no middle schemers. Forking hard and shipping code till sunrise every day. DAOs are voting, vibes are flowing. Buff corns are still a-growing. While the world is breaking down, we're regen in a new way. Some VC said this tech won't last. And the hurt bubble, watch it crash. But we don't need your central banks. 'Cause regen biddlers stack in stacks. For we bid let this city on sports and chains. We bid let this city with regen brains. We bid let this city on sports and chains. No rug pulls, just pure on chain. Whale pools floating, fees are burning. ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, code permissionless and finalized. Fork marmots on the scene, you know we're gonna bid a little it there. Some tread fibro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games. We just launch and stake on chain. Go, we pay let the city on sports and chains. We pay let the city with regen brains. We pay let the city on sports and chains. No rug pulls, just pure on chain. If you fade it, just stay seated. The etherverse will leave you heated. We don't need your legacy, 'cause regen memes are proliferate. We bid let the city on sports and chains. We bid let the city with regen brains. We bid let the city on sports and chains. Rolling up and slapping chains. She's a Colorado comet in code forged steel. Wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if you chains choking ether night whisk. Founder at a bullet hook sucking down APIs. Armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagron drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, crack. That lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bluff acorn's grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Architect with a buffercorn's grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with for do with for do with with do you ordered a moonwalk across gas feet graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess. Scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. Click, clack, goes a mace on firewall. I spooked and truce from trash sheets. That's my device. Nullify a sniffing by my clothes too crisp. Mainnet gossips, tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. You private DMs, I'm the dumpster dive jump. Eyes everywhere, match 3 bird phones. Haunteries whisper, king chomp and blockchain bones. Make it down to my voted fuck. Stealth crawl through your junk den scene. Head it up to the entropy. Mace cracked vaults like, who's got the keys? Nullifiers huffing, you're just a rat with These firewall splinter to confetti bits. I'm curating leaks at the after party, sipping TLS tears. Call me well connected, I call it coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. They rock on PI. Get 487 for time. Shaboom dose, efficiency pulse. The lag runs lagging in his latency so. Professor Waze got the future on spinball. Urging notes dancing where the bottlenecks been. Professor Waze got the cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Way's got the future on spin, urging those dancing where the bottlenecks been. Professor Way's got the future on spin, bugging tomorrow with yesterday's ram stains. Chaos is not compeller, or it's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI, nah, just 3 Red Bulls in a row. What you building, prop? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Light runs dial-up-found. Age, old as speak, young as each block, mine down. Professor Way's got the future on spin, urging those dancing where the bottlenecks been. Professor Way's got the future on spin, bugging tomorrow with yesterday's ram stains. Throwing me mad, running mad's just a beta test for Buddha. Oh, P-Jobs, floating, fees are burning. ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, code permissionless and finalized. Fork marmots on the scene, you know we're gonna bid a little it there. Some TradFi bro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games. We just launch and stake on chain. Go, we pity let the city on sports and chains. We pity let the city with regen brains. We pity let the city on sports and chains. No rug pulls, just pure on chain. Chains. She's a Colorado comet in code forged steel, wings wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking ether night whisk. Found her at a bullet hook sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-bop crack. That lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bluff the corn's grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Alliance architect with a buffer corn's grit, teaching stale protocols.
Hello. How's it going? I'm going to wait for my slides. There it is. Perfect. Hello, everyone. My name is Johan Gorsny, and I am a co-founder and technical lead at Zirkit. And I am here to talk to you today about EIP 7702, which you may know a little bit about, or maybe you don't. This is mostly for the people who don't. But if you do know something about it, maybe you'll still learn something and still find it interesting. So without further ado, let's get into it. So the boring technical details, or sort of the details of the EIP, which aren't that technical. What is it? The vital information. What does EIP 7702 do? Well, it is an EIP that's about setting an EOA account code. That's the name of it. And it's authored by a bunch of well-known people or established researchers in the space. And one thing I really want to highlight here is that on that list of authors, which is a great list of authors, I'm not on it. So if I say anything wrong, I apologize. Please, call me out on that later. But, hopefully it's all still good. And just if I do misspeak, this is exactly why. But anyways, the EIP aims to add a new transaction type where you can set account codes for EOAs. It's been out for a couple of not quite a couple of years, but a couple of half years maybe in terms of drafts. And it's actually going to be included in the upcoming Pectra release of Ethereum. So it's a pretty core EIP that everyone's going to have on Ethereum L1, and then probably shortly after on a bunch of L2s as soon as it goes live, which is something we'll talk about a little bit later in terms of the release timelines and things like this. So why do we want it? Why do we care about EIP 7702? Well, we wanted a better user experience. That's the full sort of short version of this. We wanted something that we could do many different transactions at once on-chain for a bunch of reasons. So for example, right now, if you want to deal with sending someone an ERC20, if you don't know them, if you've never dealt with it before, you have to approve your spend, and then you have to actually spend it. This is really annoying. And it requires doing multiple transactions. And they might hit the chain at different times. Things might happen weirdly. It's not great. If only you could do it all at once. In fact, that's one of the goals of EIP 7702 and one of the things you can do. So you can batch transactions. But once you start going down this rabbit hole of what type of UX you want to improve for end users, you actually want to do other things too. There's a bunch of use cases you can do with arbitrary code attached to an EOA. And two of the more popular ones are sponsorship. So I could sponsor someone else's transaction. I could say, I'll pay for my colleague or my friend's transfer or smart contract call or something like this. And that's really helpful for onboarding people. If people are new, they don't have ETH, maybe this will help them get some ETH. It's also really good if I'm a dApp, because maybe I want to sponsor transactions that will target my dApp, and I will gain users as a result of it. So there's a lot of benefits of doing this. Also great for things like L2s, where we can sponsor onboarding onto our chain. One of the reasons that Zirkit here is also interested in it. But you can also do other cool stuff. You can do things like privilege de-escalation, where you sort of assign different subsets of your sort of account to different people based on the logic you give in that code. Essentially, you can say someone that I know has a key that can only do certain things with my account, not everything, while others can do different things. So you can imagine one of my friends could spend my USDC, and the other could only spend my USDT, or something like this. How we'd actually do this is, subject to the code, and we'll talk a little bit more in the future, but keep all of these things in mind. Part of the reason I wanted to give this talk is not because this topic isn't already been covered by a couple of people. It certainly has. There was a great talk at DevCon, for example, by one of the authors, like Lance. But the other one is that we're at the beginning of Build Week here at Denver, and honestly, it's a hackathon. So if you're looking for things to hack, one of the things that would be really interesting is figuring out ways to use EIP 7702 set codes as an interesting project. And I think that's sort of the moment to do it is right now before Pectra comes live, but while the protocol is still relatively final. And if you do this, you'll be building into this sort of larger notion of account abstraction. So EIP 7702 is one step towards this notion of account abstraction, where we don't sort of need to know that the EOA is in fact an EOA rather than a multisig or something like this. But essentially, the Ethereum Foundation, or at least the Ethereum website, defines account abstraction as flexibly program more security and better user experiences into the accounts. And that's sort of what I said with batches and sponsorship and privilege de-escalation. But essentially, you want to be able to do stuff where the dApps that receive transactions from the transactions don't know if it's an EOA or another smart contract, and honestly, they don't really care. They just do what they're supposed to do. And this is only one step because this is not quite native. This is, in fact, something you have to do separately through this set code transaction type that I alluded to in the last slide. And it's not native in the sense that you still have to do this. You would like to have full AA on Ethereum, or at least many people would. And this won't get us there, but it will get us part of the way there. And until we have that full, all the way native account abstraction, this is a pretty good starting point where we can start to get users ready for the notion that they could have a smart contract wallet that can do some of the things that they would do maybe by default in the future. So this is a really good stepping stone. And it's important to note that this approach is not incompatible with other approaches towards account abstraction like EIP 4337 or other things that have been looked at. So if you hear all of these words, this is one good starting place, and this is again why I want to bring it up at this hackathon. So you can start building something that works, something that's interesting, and takes us in to the direction of the future Ethereum chain itself anyways. So let's dive a little bit deeper into some of these use cases, because I think the motivation is actually really, really important. And a lot of people gloss over it because this topic's fairly old. In fact, AA has been sort of hot topic for 2 or 3 years, if not longer. And although 7702 only sort of got draft status last year, I think, AA has been around. So let's look at some of the critical use cases. First, batching. I've already said the case of the ERC20s with the approve and the spend. This is, I think, one of the easiest things you can fix to get users onto the chain. Most end users, if they only come from Web 2 or Cash or Visa, don't understand the need to approve. They just go and they spend the money and it's all good. Doing this atomically would be very good. You could, alternatively not go down this route and require people to deploy their own smart contracts to do this, but that's a real pain, and that's why we don't want that. But you can also do things like trades. You can also think of more critical sort of infrastructure upgrades. So if you have a big dApp and you need to deploy a new proxy and then initialize it before it's front run, that might be really problematic if you can't do things in batches atomically. EIP 7702 allows people to do this with the right code. The next major use case I think is really, really interesting is this notion of sponsorship, where people will pay for your gas, or you'll pay for someone else's gas. This is helpful, I think, for onboarding a bunch of people, because now you can build apps where if you're willing to pay for the on-chain costs of some users, those users don't even need to be really touching a KYC process, or maybe they do, I don't know, I'm not a lawyer, but they don't need to have Ether in their account. They can just have an account made, an address, and you can pay for their on-chain transactions. And this means as a dApp developer, you sort of get closer to that Web 2 seamless thing where you just say log in and everything just works. And maybe you still need an address, so maybe it's not 100% just click here and log in and there's no Web 3 stuff, but it's a lot simpler. This also means that infrastructure projects like Zirkit, where we're building a rollup, can sponsor their users to get people on chain to do particular things, or just anything we want. So this is really cool. And this is not limited to just ETH, right? You can sponsor things in other ways as well. You could sponsor people's on-chain transactions, which are paid in ETH, but you could say that those persons should pay you back in USDC or some other currency, or off-chain favors, or whatever you want. So I think it's really cool. But the list of use cases does not stop there. One of the next big use cases is the idea of enhanced safety. What you could actually do is have part of your account code talk to a smart contract that will allow some level of social recovery. That is, if you lose your part of your key to that account, there might be a multi-sig attached where if you can go talk to the other people who hold that types of privilege or those types of subkeys, they can say, oh yeah, actually, well, that is the person, so I'm going to give back privilege to that account, and we're good. And that's really, really cool, because this is also another feature that scares a lot of people who aren't Web3 native, right? If you lose your private keys, it's over. Here, maybe we can do better. We can build it in a little bit more. And that's really, really exciting. And this sort of brings us to this notion of session keys and revocability. If you like those people and you want them to always have the ability to socially recover your account, that's great. If you don't, you can also make it so that those keys and those privileges expire over time, or you can revoke them. And this means you can sort of do things like approvals that are a little bit more general, not just for tokens, but for actions and sort of general sequences of things, arbitrary code. And then you can revoke them at certain times. So this is really helpful for building out different ways to sort of put yourself partially in the hands of someone else without giving up entire trust. So this is really cool. So I did say it was an introduction. It's a bit technical. Let's go a little bit into it. What the EIP does is introduce a new new transaction type. And the transaction type is called a set code transaction. It's built on previous work. EIP 2718 introduced the ability to add new transaction types, and so here we're building on that, and we're using it, and that's not super important, so let's keep going a little bit. But essentially, you get this new transaction, and the transaction contains a whole bunch of things like this. And I'm not going to go through every single one of these. This is definitely helpful if you're going to try to implement some of these things on this hackathon or beyond. But there's a couple of things that are really, really important I'll dive into. So at a glance, there's sort of stuff you'd expect, a chain ID and a nonce. This has to come from the people signing this transaction and submitting it on the right chain, if that's appropriate, gas and all of that. And then there's one really, really interesting parameter, which I've highlighted here in green. And that is the authorization list. The authorization list is actually where all of the magic happens for EIP 7702. So let's look deeper into it. The authorization list has a couple things in it. It's a list of lists, and the inner list has a chain ID. It has an address, a nonce, and a YR and S. So what those things are is a way to set up other people's privileges for you to set up other people's privileges to act on your behalf. And the chain ID and address are somewhat straightforward. The chain ID should match the chain you're putting this transaction on, but you can set it to 0 so it can be replayed, subject to some sort of caveats. And then the rest of it is a signature that actually comes from you. So when you create this entry in such a list, you sign it, and you sign it with your public key, and you can recover this from the RNS values. And then what happens is the address there is actually entitled to act on your behalf, and that's really cool. Now it's got to be non-zero, and why it's cool that you can do this by just signing this entry is that this means someone else can actually submit this transaction for you. You don't even have to pay for the transaction to set your account code. You just need to sign the tuple here, and it'll go through, which is really cool. Some technical details, it's got to be non-zero. No surprise. Wouldn't be very helpful if it was 0. But essentially what happens is that we call this a delegation designator, where we have some ability to say that the code that's in that delegation designator will be run when someone else who you've delegated wants to run the code. And the person who you then allow to act on your behalf runs the code that you point to in this list, and everything kind of just works out. So actually, you can load in arbitrary code. There's smart contracts you can point to, and it'll be copied in. It's not quite exactly the same as normal deployment. You have to call an initialization call. I think it's my next slide. Yeah, you have to call it an initialization after you put in this tuple. But once this is done, so you have someone submit this authorization list, and then you have yourself or someone else relay the initialization, the code that's pointed to at each address can be executed by the person you've delegated it to. And this is really, really cool, because that's an arbitrary piece of code, and so they can do stuff that you've allowed them to do, which is smart contracts. And that might be sounding really abstract, and I probably went too fast still, despite my efforts to slow down. One thing that's really, really important is that what you delegate the code to should be what you want it to do. And here's my call to action. This is the main reason I want to give this talk at this venue. rather than just a technical deep dive of what's going on, because I think other people have covered it better, is that when I say someone can execute that code on your behalf, I'd like to see some of that code. And I was looking around for a while, and I didn't see a lot of that code. There are some examples. I think Coinbase has a couple. I think OpenZeppelin is going to work on some. I saw some tweets. But I haven't seen a whole lot right now. And there are testnets out there that actually do support EIP 7702. I forget on the networks, but if you look around, they are there. So we should really be at a point where we can say, I want to delegate my code to something that's well trusted. Because as someone who used to be a security researcher in this field, I think it's very important that you don't delegate code to something you don't trust. And the reality is, the 2 or 3 or 4 use cases that I pointed to in the first couple of slides of this talk are probably the most common, and probably the ones that most of the people in this room and beyond really want to see. Batching, sponsorship, and social recovery. It's probably the biggest ones. And yet we don't have standards for the delegation code to actually run them. So I'd really like to see some ideas of how that could look. It's a hackathon. Come build some. We don't technically have a prize for this at this one, but if you do deliver anything good, tag me or Dr. Z on Zircuit, and I'm happy to take a look for reasons I'll explain in the next couple of slides. Either way, I think this is a good project this time, even if it's not quite as sort of sexy or on hype as AI or DeFi or other things, because at the end of the day, this might actually onboard people quicker than an AI that does something else. But part of that concern is security. So the delegation of your account to other people or parts of it is risky. So this is the reason I want to see stuff early, because if we develop the stuff early and then it fails, well, we can fix it for later users. So let's get started. Ideally, we don't have any issues, but probably we will. Nonetheless, if you do start doing this, be careful. If you delegate to a proxy contract, it can upgrade itself. Now you're delegating sort of arbitrary powers. That might be very desirable. Maybe you trust the person. Maybe you want the ability to update that in some way. In other cases, I'm guessing in a lot of cases, you don't want to do that. That might be very scary, because the person you delegate to can arbitrarily update their code, and then, you've got to worry about if they can do something bad or something that you didn't want them to do. For now, I would then therefore recommend keeping the delegated code simple. Choose one action and delegate to different people different actions. This way it's easy to audit. This way it's easy to understand. And this way you know what rights you're delegating away. I also think that we should practice and sort of work with the idea of removing delegation access. There is a way to overwrite that list so that delegation goes away. And I think this is important. I think in the past, we've seen a lot of hacks where people said, revoke your approvals, revoke your approvals. I bet you're going to see similar things, maybe on a smaller scale, about revoking delegated access, either because the person you delegated to is not trustworthy, or because the code that's been at that address is problematic itself. And then finally, if you're building just any other dApp out there, be aware that now with the introduction of EIP 7702, the invariant that TX origin should be the message sender is no longer going to hold. So if you're using that to check if something's an EOA, you're out of luck after EIP 7702. You got to do something else. So all of these things should be sort of considered, and this is the time to do it. And that brings us to what we're going to do next with it. So Zircuit, the zero knowledge rollup. If you're familiar with us, great. If not, we're a zero knowledge rollup with some nice features. And we're standing by to be one of the first to adopt 7702 as soon as it goes live. Our new testnet, which is going to be coming out very, very soon, sometime this week for sure, possibly in the next couple of hours, will be going live. And while it won't actually support 7702 just now, as soon as Pectra goes live on mainnet, maybe not mainnet, sometime very, very soon, we're going to have support for this, possibly before Ethereum mainnet is actually what I'm trying to say. And what this will also mean is that Zircuit, Zircuit unique feature of sequencer level security, where we actually look for malicious transactions in the network, will also be adapted to look for malicious 7702 transactions. So this will include delegating things to people that you shouldn't be delegating, or problems in that delegation code. And that's really exciting. It's going to take us a little bit longer to get that online, but honestly, we're really excited, and I think that'll be an extra level of security. So, almost out of time. What's next? Well, for 7702, it's got to go live. Pectra is supposed to go live on Holsky today. I don't know if that's happened yet. I haven't looked. I was too busy practicing the talk. On March 5th, it's going to go live on Sepolia. That's really cool. At some point then, on that day, if everything goes well, or shortly after that day, people will decide when the mainnet launch of Vector will be, and that will include 7702. And so it'll come very soon, probably a month or so after, I think is what I heard. So free IP 7702. If you have any comments about the technical implementations, better get them in real quick, because it's going live. For Ethereum, the road to account abstraction is not done here. 772 is a great first step, but maybe we still want 4337 or something like it in order to get native AA, and that would be really cool. There's going to be a lot of work here, but getting used to 7702 is helpful. And then for you, as an end user, the call to action is twofold. First, come up with some good delegation code here at Denver. I think that's really exciting. I'd really like to see it. And second, as soon as networks, particularly Circuit, start to deploy 7702, test and play around with it. See what works, see what doesn't work, see what breaks, see what doesn't break. I'm not saying you're going to break the network, but I want to see those delegation code things break when it's a test run, not when someone puts a lot of money in it and we have to have a bad Twitter thread and people calling for rollbacks of chains, which is not so great. So for now, play around, be aware, learn, use. That's all I've got to say. So thank you. If you have any questions about me, 7702 or Circuit, come talk to me. I'll be at a booth here or a table over there, or hit me up on email or Telegram or Twitter and check out Circuit. Thank you.
Alliance architect with the buffercorn's grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with for do with for do with with do You ordered a moonwalk across gas feet graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. Click, clack, bosom, lace on firewall. Eyes spoken truths from trash sheets. That's my device. Nullifier sniffing on my clothes too crisp. Mainnet gossips, tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. You private DMs, I'm the dumpster dive chump. Eyes everywhere, match 3 bird phones. Haunteries whisper, king chomp and blockchain bones. Make it down, uploaded fuck. Stealth crawl through your junk dead scene. Heading up to the entropy. Mace cracked vaults like, who's got the keys? Nullifiers huffing, you're just a rat with firewall splinter to confetti bits. I'm curating leaks at the after party, sipping TLS tears. Call me well connected, I call it. Coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. They rock on PI. Get homemade in 7/4 time. Shaboom, dose, efficiency pulse. The lag runs lagging in his latency soul. dancing where the bottlenecks been. Professor Wade's got the future on spin. Bugging tomorrow with yesterday's ram stains. Velcro boots clicking through blockchain debris. Crypto notes flutter like drunk bumblebees. Optimize the board fins, they cackle and shout. Self-sustaining hubs flickering the blackouts out. Professor Wade's got the future on spin. Urging those dancing where the bottlenecks been. Professor Wade's got the future on spin. Bugging tomorrow with yesterday's ram stains. Chaos is not compeller. Orders just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI? Nah, just 3 Red Bulls in a row. What you building, prop? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Like runs dial-up-found. Old to speak, young as each block mine down. Professor Wade's got the future on spin. Urging notes dancing where the bottlenecks been. Professor Wade's got the future on spin. Bugging tomorrow with yesterday's ram stains.
Hello, everyone. My name is Dennis from Magic Labs, and I'm here to talk about Newton Key Store. Key Store rollup with trustless, verifiable on-chain automation. In detail, I'm going to go over the on-chain and off-chain hybrid infrastructure for agent-driven decentralized finance with verifiable security and privacy. At Magic, we are very passionate about the convergence of AI and Web3. Web3 and AI, they individually, respectively, bring their own benefits and strengths. Web3 reduces dependency on intermediaries, prioritizes data sovereignty and privacy, and provides censorship resistance. AI, on the other hand, it automates tasks and optimizes processes, and is capable of solving complex problems at unprecedented scale. We believe the future is an agent-driven economy, system where autonomous AI programs like agents interact, transact, and execute tasks independently on blockchain networks. We believe there will be DeFi bots and decentralized marketplaces and governance, those on-chain processes to be automated and enhanced for user experience. We have already seen many examples of AI coming on-chain. We have seen different like AI chatbots, mainly for kind of social management, community management / data analytics. However, what we believe at Magic is we are at the verge of seeing agents actually taking actions on the behalf of users to solve the Web3 complexity problem. And that's what we are trying to solve. Yeah, so we believe this is the future of what we can achieve by combining crypto and AI. Web3 will have enhanced DeFi with AI-powered analytics and fraud detection, AI-powered smart contracts automating complex processes, and personalized experience for users without compromising privacy. Not just chain abstraction, but also app abstraction without Web3 complexity. For AI, trustless execution, data integrity, tokenized incentives, and interoperability. To start off, I would like to start with an example. The user says, can you find the top 10 traders on Base in terms of P&L the last 7 days? The agent replies, here are the top 10 traders on base in terms of P&L. The user says, can you set up copy trade for me cross-chain for these addresses with max spend limit of 10,000 USDC in value until March 2nd, 2025. An agent says, sure, I've set up copy trading function for your account with these permissions. The problem is, in order to really see the future of agents taking action on the behalf of the user, accessing the user's funds, the module execution integrity becomes a question here. How can we verify correct model execution? How to preserve model privacy without sacrificing privacy? How to ensure against model tampering? How can users and agents trust each other? That's what we are trying to solve at Newton. Yeah, so this is a diagram. There's a trust gap currently for client request. After clients making the inference request, yeah, what is the model? Is it genuine execution? Any security concerns? So this is what we provide. For users, we provide chain abstracted ERC 7579 modular smart contract Newton account. It's gas optimized and fully audited, and it comes with chain abstraction. And the signer is secure with secure enclave, trusted execution environment. For users, provides social login passkey, good user experience. For agents, it provides remote attestation that can be used to be verified on chain. Underneath, Newton Key Store is our infrastructure that, in essence, it is a cross-chain ZK key store rollup. It operates ZKVM to provide programmable, stateful, and verifiable permissions. Also, in order to enable verifiable automation for AI agents, we have the unique model registry and verifiable inference mempool to provide censorship resistance, trustless AI experience for users and agents. So we define this key store as the trust layer for agents with verifiable autonomous execution. The verification includes execution integrity, agent sovereignty, proof-based decision-making, and censorship resistance. First of all, I'll start with the first portion of the architecture, which is the key store rollup itself, how we achieve the chain abstraction for our permission rollup. For Ethereum and other L2s, we operate light clients, which are part of our Newton validator network. Essentially, they aggregate the key store contract state from all the connected rollups, and it manages these two mempools for permissions and also inference separately. It sequences the block, which gets executed by the verifier node, which operates a ZKVM with read-optimized index Merkle tree. So that's where the permission state, the program for programmable session key, is being stored. It also has model registry. I'll talk about the model registry in a bit. And in addition, lastly, it provides remote attestation verifying that the execution by the verifier node on ZKVM is correct. The executed block gets returned back to the Newton validator network, which provides consensus and fast finality to be settled to Ethereum and use ZK state proof to synchronize to all the other L2s. And this is the second portion of verifiable automation, which is the model registry part and how we achieve verifiable automation. This is the combination of off-chain and on-chain infrastructure that I mentioned earlier. To begin with, I know the words the letters are quite small here. And I cannot zoom in to make it larger. But I'll just speak it out. So it starts from AI developers. They use our SDK to circuitize their model. Or if the model is running on TEE, it also can use the remote attestation of the TEE to get deployed into a verifier contract on Newton for later verification of the execution. So the model registry contains all the model details, including input, output type, the commitment, which is what is the required commitments that the operators of the model should achieve. And lastly, and other metadata. So our network contains exact information that we can use in addition to the circuit that is deployed on our ZKVM to later use to verify the automation execution of the models, of the inference. And when at the time of the user, the permission delegate, the users want to make inference, it submits inference request to a decentralized inference mempool that our validators operate, and which orchestrates those inference requests exactly to the node model operators that register with a state. Essentially, those model operators, when they are registering, they're making a commitment with a stake that can be slashed if their model execution fails to get verified on our rollup. So again, back to the inference mempool, it gets orchestrated to a specific model operators, which provides the inference result back to the user. And if they want to, they can also store their inference result to a IPFS or Filecoin or Arweave-like permanent storage, decentralized storage. And in addition to the inference result, they are responsible for providing a proof of valid execution of the model, whether it's TEE remote attestation or the ZK proof that can only be verified by the verifier contract. If they fail to get verified, or if they fail to provide the proof, they get slashed. Otherwise, they earn the fees that inference requests require. And so by making this verifiable inference, that's how they get authenticated with ZK verification to the user's smart accounts to trigger intents, to execute intents on the behalf of the user. Also, like many people would have been or concerned about the privacy of the links between their wallets. Essentially, like users manage multiple wallets, their interaction with their agents, all those interactions, people don't want to make it public and store on-chain. So we also provide optional privacy for putting permissions on-chain, where on the client side, they can execute in a private execution environment. So, which is essentially, they updated the state on the client side off-chain, and then send a private transaction along with the proof of the execution correctness, and broadcast it back to the node. This is actually very similar to how Aztec provides private execution. Yeah, so this is the last slide of my talk. With Newton account, which is chain abstracted wallet, a smart account for users. Also underneath with a key store rollup with verifiable automation. We provide for users chain abstraction, but also app abstraction using AI, cross-chain verifiable permissions, transparent verified AI predictions for on-chain automations, and cryptographic guarantee of faithful execution by the agents. For agents, we're still running the AI models on off-chain. The inference, we are not running AI models on-chain. However, we are putting the verification circuit on-chain and the permissions that agents are given with specific policies that are given by the user. It is therefore, the ML models, they can protect their proprietary algorithms. Also, thanks to the decentralized mempool, this can be also used for cross-chain agent swarm, where this infrastructure can be used for multi-agent coordination and collaboration. Also, with decentralized fee-based marketplace for inference, models are able to get secure payments from users, decentralized. Yeah, so that was the gist of the talk. This is what we are trying to provide for both users and also agents. We believe these two together can be a fundamental infrastructure for crypto and AI convergence. Thank you. Any questions? No?
You ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a mempool express. Next bottleneck, I see mountain crush it. Click, clack, goes a mace on firewall. I spooked and truce from trash sheets. That's my device. Nullifier sniffing on my clothes too crisp. Mainnet gossips tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. You private DMs, I'm the dumpster dive jump. Eyes everywhere, that's 3 bird phones. Haunteries whisper, king chomp and blockchain bones. Make it down to my phone. Stealth crawl through your junk dead scene. Headed up to the entropy. Mace cracked vaults like, who's got the keys? Nullifiers huffing, you're just a rat with These firewall splinter to confetti bits. I'm curating leaks at the after party, sipping TLS tears. Call me well connected, I call it. Coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. They rock on the island. Get homemade in 7 for time. Shaboom, dose efficiency bulb. dancing where the bottlenecks been. Professor Way's got the future on spin. Plug in tomorrow with yesterday's RAM stains. Velcro boots clicking through blockchain debris. Crypto notes flutter like drunk bumblebees. Optimize the orphans, they cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Way's got the future on spin. Urging notes dancing where the bottlenecks been. Professor Way's got the future on spin. Plug in tomorrow with yesterday's RAM stains. Chaos is not compeller. Order's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Room She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking, ether night whisk. Found her at a bullet hook, sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange drools over slow motion duel. Her shield's a disco wall, fracturing legs, grass, shooby-doo-bop crack. Ooh, that lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bluff the corn's grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. With a buffercorn's grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with for do with for do with with do You ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. Click, clack, bosom, lace on firewall. I scooped and truce from trash sheets. That's my device. Nullifier sniffing on my clothes too crisp. Mainnet gossips, tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. Your private DMs, I'm the dumpster dive jump. Eyes everywhere, that's 3 burner phones. Haunteries whisper, king chomp and blockchain bones. Make it down to my voted fuck. Stealth crawl through your junk dead scene. Let it up to the entropy. Mace cracked vaults like, who's got the keys? Nullifier's huffing, you're just a rat with His firewall splinter to confetti bits. I'm curating leaves at the after party, sipping TLS tears. Call me well connected, I call it. Coffee for drip and the lab coat on fire. Sticky note.
Right, okay. So, welcome, friends. We've got a crazy prezzo, as I alluded to previously. This is going to be, we're going to see how it goes, because to be real, they talk about live demos are, very bad luck. This is like live demo like times 10. So get ready. We'll see. Okay, so what do we have? We have it's 3:53. What am I going to be telling y'all about? I'm going to be going through the Superchain interop DevNet tutorial and starter kit. And then we are going to go into a experimental interop repo and thing that I've been working on, which I was calling the futuristic Superchain starter, which is probably broken. And as you'll notice, my latest commits were as of 38 minutes ago. So trust me when I say this is a live demo. This is a extremely alive demo. So okay, real quick, what is native interop? What is this thing? Well, I hate to break it to y'all, but we solved Ethereum interoperability. We did it. We did it. We can go home. No, but actually, though, for real, it is actually very exciting. This is the real deal when it comes to interop. It is chain A can read information from chain B, high security, and with low latency. And by low latency, I mean a couple seconds. And realistically, if we fix the builders, it could be as low as same block. That whole silly meme that's probably not that useful of synchronous composability, it is on DevNet. It is not fully there on mainnet, but we are so close. So, what does this mean? It means that you are in on the ground floor. And if you don't believe me that there's a DevNet, I promise there's a DevNet because there's a block explorer. Things are not real. Blockchains are not real unless there are block explorers, and we have explored. Now, we actually have multiple block explorers, but I'll get into that soon. And we're going to see what it's like to build an example app. This right here is the first live tutorial about how to build an example app on the Superchain DevNet. So now, if you want to follow along, which I highly recommend, go to gist.github.com/opsuperchain. Click on this gist. OP Superchain, it's not me. It's someone else. Someone else's GitHub. Now, what are we going to do? So, thankfully, I have already downloaded and, I did a git clone, but I really didn't touch it. I promise I did not touch this thing. And by the way, let's look at it. Let's look at what we have here. So if I go to let me actually follow along with the tutorial like I'm supposed to. Boop, boop, boop. We're gonna go to, here we go. Superchain Starter Kit gives you a few nice things. All you need to do is you clone it, go into your repo, pm-pmi, and then pm-pm-dev. Super simple. So why don't we do it? So, by the way, I whipped out my old Vim and tmux configs for you. Not because I use Vim and tmux anymore, but because I wanted you to know I know the key bindings, but I still choose not to use them. Okay, where are we at? So, this is actually really shout out to the DevX team. They did a really good job with this. This is pretty cool. So what did we actually do? I started up the development environment. Spins up SuperSim. What does SuperSim do? It deploys 2 chains, kind of like, testnet chains, right? And it has auto relay enabled, meaning that if you send a message, initiate a message on chain A, it will automatically relay on chain B. Now, notably, this relaying is asynchronous. So we are moving into the world of Solidity programming with asynchrony, which is extremely exciting and also very scary. But for the purposes of this demo, it is extremely exciting. And what actually happened in the background? Well, one, it ran this deploy contracts CLI. This is like super CLI. It deployed 2 contracts. It deployed a counter. You need a counter in your starter kits. Deployed a counter on chain A and a counter on chain B. Now, something that you will note about these counters is that they are deployed via create2. We know that it is very hard to deploy these contracts in a multi-chain context. We need to make sure that all of the addresses are going to be the same on all of these chains, which means that we've had to build out tooling to make it easy to deploy your contracts on various chains. So here we go. We've got the logs from the SuperSim A and SuperSim B, and chain A and chain B. And we've got this beautiful little front end, which I will then pop open. Oh, yes, I forgot. I need to click C. And then, boom, we're here. OK, so what does this end up? What does this do? Pretty simple. We have a counter, and your normal counter, all you would do is you'd click the incrementer, and it would increment the value, right? That's like your normal counter thing. Next, we have the L2 to L2 cross-domain messenger counter, aka the cross-chain counter, where what I'm doing is I am actually sending a transaction on chain A, and that is initiating and incrementing the counter on chain B. So I can, send it again, and you'll note that it's a little bit slower than the single chain. Now, I haven't proven to you that I'm actually doing cross-chain interactions here, but you can kind of get an intuition because of the latency. There are really two transactions going on when I'm doing the cross-chain version of this counter. But now, to actually prove to you that I am doing this remotely, I actually had some logs which would have proven it to you, but what I'm going to do instead, because I feel very cool, is I'm going to move to the DevNet config, and then what I'm going to do is I'm just going to serve. Actually, I'm going to look up the npm thing. There we go. Okay, dev front end makes sense, checks out. And what I'm going to do is run the front end. And so instead of connecting to my local environment, let me pop it open. This is the diff. This is the delta. I'm just changing the, from using the SuperSim L2 to using the interop alpha. Great. So now let me pop it open. Boom. We've got some different chain IDs. It's promising, thank God. The other thing that you'll notice here that's actually kind of cool, it says that the counter is already incremented to 3. Why is this? Well, it turns out that I've already deployed this contract, and because I've already deployed it, but the address is deterministic based on the bytecode. If you don't understand the words that I'm saying, I really do apologize, but create 2. It's really cool. I'm going to call this function. This is a cross-chain message. Now, I happen to open this Explorer open to this particular address. Why is that? Because I think that it is the correct address. It is the correct address. We have found this transaction 12 seconds ago, 19 seconds ago. If you were timing it, it would line up perfectly. And we've actually, instead of incrementing on my local machine, I can send a message, and I have incremented yet again on the remote DevNet. So, y'all, if you literally, here's what I want you to do. Okay, you get a golden star if you open up this, where did I put this gist? If you open up this gist and you follow all the steps and then you increment the counter before I'm done talking. If someone does that, that's very impressive. I will be impressed. I won't know who you are unless you tell me or if you claim credit for someone else's work. Okay, so we have officially done the thing. We are literally, and by the way, I don't know if y'all really appreciate this, the fact that we have this DevNet that allows you to, in seconds, move information from one chain to another. I remember, I didn't actually tell you why interop is so insanely crazy, but think about all of the horrific fragmentation in Ethereum right now. You try to deposit into a chain, or sorry, you try to just put your token on chain. Let's not talk about deposit. What does that mean? You try to get an on-chain asset, you're confronted with a disgusting dropdown, truly abysmal, of a million different networks. This needs to go away. The only way for this to go away is if where you deposited your asset does not actually matter because you can move your asset from chain A to chain B to chain C within seconds. And as it turns out, that's exactly what we did in this demo. We moved from chain A to chain B. We did not go to chain C. Okay, so now that we are done with the kind of like the basics, which I think, first off, extremely cool. Part of me wants y'all to applaud right now. It really is amazing. I mean, like, look, it's so anticlimactic, but that's what you get for building infrastructure. Okay, truly, blood, sweat, and tears. Okay, so next up, what do we got? We've got a futuristic, universe. Let me actually pull back before I even get into my like live demo bit. So I just want to mention that this is really the beginning of a new paradigm. We are entering an age which we knew we would enter in Solidity blockchain land, which is we need to build applications and programs and smart contracts asynchronously from the get-go. And so what that means is we need to support things like promises in Solidity. We need to be able to do, perform callbacks. We need to do async await. We need, as I said, better cross-chain deployment tools. I went through the ones that we built, but this is just the tip of the iceberg, and there's huge amounts of improvements. And literally something as simple as upgradable cross-chain proxies. How do you handle upgradability and keeping all of your smart contracts in sync if they're deployed to many chains? There is a literal huge number of things to build. And by the way, yes, indeed, we have 40,000 somethings of bounties, which you should contribute to in this hackathon. So definitely for real, I think it's very, very cool. Okay, now I will show this kind of crazy version of the front end and general. I'll show you a kind of crazy version of the counter. Let me increase my zoom. Okay, so by the way, I'm going to be giving this talk tomorrow at a Superchain event where I'm going to actually try to complete the entire application because looking at the time, I think I'm really, really running low. But I will still be able to show you, like, for example, something that you should be able to do very simply in the near future, right? This guy is the cross-chain counter. It is async enabled, meaning that it can make these cross-chain calls. Again, this is a protocol level feature. This is the same level of security as, a cross-contract call, right? This is baked into the protocol. It's not like a extra wrapper with a relayer. So I'm going to call this increment on chain function. I'll give it my chain ID. And what I can do in this particular library, this is not the best syntax, and this is like tons of room for improvement here. But what I can do is I can make this cross-chain call, use this, get this proxy, make this cross-chain call, and call cross-chain get implement. Cross-chain increment, and boom, increment on the remote chain. Then I can add this actually returns a promise, just as it does in Solidity, and I can register a callback with a .then, just as I would in, I said just as I would in Solidity, I meant just as I would in JavaScript. And then I just emit an event with this, right? This whole thing is incredibly, this is a whole new side of Solidity programming, which will contain an enormous amount of bugs, an enormous amount of gotchas, but still very, very cool. And what, I might do is I can, npm test. Let's run the tests. And what I end up, how do the actual tests look? By the way, I recently added some tests. I know the counter tests work. It's unclear if the other tests work. But I just wanted to show, even cross-chain front-end code will change with this stuff. So first off, we're not going to be operating in a context where it makes sense to have one RPC provider anymore. Or maybe it still makes sense to have one RPC provider, but one RPC endpoint. Maybe there's a meta endpoint, but the point is you'll need one endpoint per chain, no question. The other thing is, well, this is just a wallet with private key. That's the testnet private key, don't worry. But unless it isn't, and there's actually a massive bounty sitting there for someone, lucky you. Okay, but point being, super contracts. This is another thing that is like kind of a weird abstraction, but it makes a lot of sense when you start building your smart contracts in this cross-chain context, right? Instead of deploying, having a single contract instance in your front end per deployment, you really want to be able to operate on all of your deployments at once. You want to be able to make calls to the same functions. The function is number, for example. But you want to be able to specify the chain ID. Which chain ID, well, you know, your contract may have hundreds of instances across the superchain. You're going to need to make these calls directly. And, you know, similarly, sending transactions. So we've got 15 seconds. All I have to say is this, if I had, you know what, I will do it. This is a green field. Literal, one of the greenest. In fact, I would argue probably the greenest in crypto. And so if I were you, I'm not, and I'm also very biased, but I really would consider building on top of interop, building some of these primitives, because you don't have to be smart to push the state of the industry forward right now. You can be you can have very mid-curve ideas, and it will be brand new because no one has built cross-chain smart contracts before, ever. So this is the first opportunity, is literally the first DevNet that is public for interop, for Ethereum. Let's solve fragmentation and save the world. Thank you.
Click, clack, goes a mace on firewall. I spooked and truce from trash sheets. That's my device. Nullifier sniffing by my clothes too crisp. Mainnet gossips tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Job receipts in my cheeks, encrypted and plumbed. You private DMs, I'm the dumpster dive chump. Eyes everywhere, that's 3 bird phones. Haunteries whisper king chomp and blockchain bones. Make it down to my voted fuck. Stealth crawl through your junk dead scene. Heading up to the entropy. Mace cracked vaults like who's got the keys? Nullifier's huffing, you're just a rat with As firewall splinter to confetti bits, I'm curating leaks. At the after party, sipping TLS tears. Call me well connected, I call it coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. They rock on PI. Get homemade in 7-4 time. Shaboom, dose, efficiency pulse. The lag runs lagging in his latency sub. Professor Waze got the future on spinball. Urgent notes dancing where the bottleneck's been. Professor Waze got the future on spinball. cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Waze got the future on spinball. Urging nodes dancing where the bottlenecks been. Professor Waze got the future on spinball. Hugging tomorrow with yesterday's ram stains. Chaos is not compeller. Order's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI? Nah, just 3 Red Bulls in a row. What you building, prop? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Light runs xylophone. Age? Old to speak, young as each block mine down. Professor Waze got the future on spinball. Urging nodes dancing where the bottlenecks been. Professor Waze got the future on spinball. Plugging tomorrow with yesterday's ram stains.
Hey everyone. I'm Christopher. I'm a developer advocate at the Definity and the Internet Computer. And I lost the screen share. Yeah. Today we're going to talk about cross-chain applications, and I would like to demo for you building a cross-chain Ethereum wallet built on the ICP. So, like I said, my name is Christopher. If you would like to get in contact after this call, you have my contact details there. And to start things off, I just wanted to let this slide hang there for a second or two. Why do we keep inviting these rando chains to Ethereum Denver? And to some of you that might be know a little bit about ICP, know that ICP is an L1. So you can build things on just using ICP. But fact of the matter is this, that we are here because we see that Ethereum needs scaling, or Ethereum needs scaling, but Ethereum apps need scaling as well. And there are many reasons why you might want to scale your Ethereum application. So you might want to be able to store larger volumes of data, or you might want to run complex computation, or you might want to integrate with external systems somehow. And all these are good reasons to scaling your Ethereum application onto something else. So that is the clear message I would like to give you as Ethereum people today, is that view ICP as an Ethereum scaling solution and put it in the same category as other Ethereum scaling solutions such as EigenLayer and RISC-0, etc. So just for comparison, and when you're building an Ethereum application, you have a toolkit of platforms and ecosystem projects that you can use to achieve this scaling. And of course, there are trade-offs for all these when you should use which platform. So with EigenLayer, you rely on the Ethereum validator set as a trust model, and with RISC-0 you have the ZK proofs, and in the ICP case you instead trust the ICP consensus algorithm and the signatures that the nodes in the subnets produce. So you use these scaling solutions for different reasons. And before going into showing you some code on how you build this Ethereum wallet on ICP, I think it would be wise to give you a little bit more details on how actually ICP works. So rather, I would spend half of the time of the talk roughly describing this high-level overview, or fairly low-level, semi-low-level description, because otherwise I think I will convert basically 0% of you. So we need to describe this. But Internet Computer is a blockchain, and it is a decentralized public network that serves fully on-chain applications. And when I say applications, I don't just mean smart contracts, I mean applications, and that means we can serve both the front end and the back end, which is the smart contracts. So a decentralized public network, what does that mean? It means that it's geographically distributed, and we want it to not be dominated by like one or a few particular actors. And in the network, we have a number of nodes that execute the smart contracts, and these nodes and smart contracts, these should be general purpose, meaning that we can execute any type of computation that is computable, and they are composable, they can call each other, they are tamper-proof and autonomous. The ICP subnets and the networks are a replicated state machine, meaning that they accept input from the outside world. They run a round of consensus, and once the blocks have been arranged in a blockchain, the execution layer takes over, runs the smart contracts, that does the state transition, and then the state of the whole chain is advanced. We call the smart contracts canisters. And these canisters are WebAssembly modules, and these modules, of course, run in a WebAssembly runtime that is provided by the nodes. And in addition to this WebAssembly runtime, the nodes also provide the smart contracts with a system API that allows these smart contracts to access a bunch of cool stuff, which are the ICP-specific features. So ICP offers a whole range of features that most chains cannot offer through this system API, and that HTTPS outcalls means a smart contract can communicate with the outside world, thereby acting as its own oracle. It can keep secrets. That is a topic for another conversation. It can use timers. You can build cron-like functionality where a smart contract wakes every 5 minutes or whatever. It can access true randomness. That in itself is not a small thing. It's really important for all like game scenarios and a lot of different use cases. Chain key cryptography, we'll get back to that one. And also massive cheap storage, so up to 400 gigabytes storage per contract. And so all of these features might be like a good trigger. If you are developing an Ethereum application and you'll be like, yeah, some or one or more of these features would be, I would like to use those in my application, then you can do that. So keep building on Ethereum, but offload part of the computation to ICP. And when I said that there's an ICP network, in reality there's loads of ICP networks. We call them subnets. And these subnets are managed by a DAO, and this is important. So imagine a scenario where we have all these subnets, and the subnets execute smart contracts, and we want it to be decentralized. And of course, the topology of these subnets might need to change every once in a while. We need to add nodes, remove nodes, etc. If this was to be done in a completely decentralized manner, it would be like extremely difficult for all the subnets and the nodes to find each other, etc. So instead, we try to achieve the best of both worlds, where we have let a DAO, we call it the NNS, the network nervous system. We let that DAO manage the subnets, and the holders of ICP tokens can stake their tokens in the DAO to get the voting rights that will let them affect how ICP as a network evolves. So the DAO manages the topology, and importantly, it also provides all the subnets with key shares, which I will talk more about in a slide or two. So I think I mentioned this, but where in all this is the blockchain. So the subnets, the nodes in the subnet, they accept input from the outside world. And once that input has been accepted, a node that gets the input broadcasts the messages that it accepts to the other nodes, and a round of consensus happens. And once the nodes have agreed on an order of blocks created, those blocks get stored to a blockchain, and the execution layer takes over, which is the smart contracts, the WebAssembly modules. So there's a lot of information in this step, I know, but I just wanted to, we are soon done with this part. Two interesting features. I said we can host both front ends and back ends on ICP. So this is how serving front ends work. You have a front end there on the left, making an HTTPS call to something we call the boundary node. And there's a number of boundary nodes, and this is also a decentralized setup. So boundary nodes are responsible for translating these HTTPS requests to the internal format that ICP uses. So it routes the HTTPS request to a node that responds with an HTTP response if it's a query call, and if it's an update call, then we need to run the consensus algorithm before returning a response. So ICP provides this candid interface specification that is a fully typed interface. So once we have a front end, we have the benefit of using that fully typed RPC library. Threshold signatures is a super important thing, especially when it comes to building cross-chain functionality, such as an Ethereum application or Ethereum wallet. So I told you that the subnets give the nodes in the subnet each a key share. And threshold signatures works this way, so that if the nodes, when they sign a request, each node sign a request or a payload individually, and then all those signatures gets put together to form the final signature. And only 2/3 of the nodes need to be online and not malicious for this algorithm to work. So it's quite fault tolerant. And the cryptographic schemes that we currently support is ECDSA and EDDSA, which means that we can sign transactions on Ethereum, Bitcoin, Solana, and over 20 more blockchains. So I think the previous speaker said that we're doing the cross-chain smart contracts for the first time. Yeah, but ICP has been doing this for a number of years. And ICP plays really nicely with Ethereum. That is one of the core messages of this talk. And using the HTTPS outcalls in combination with the threshold signatures means that we can achieve a two-way communication with Ethereum. So a smart contract on ICP can sign transactions with the help of the nodes that do this threshold signing process. And once we have a signed payload, we use HTTPS outcalls to send that signed payload to a regular RPC provider such as Alchemy. And in a similar manner, we can also monitor log events from Ethereum. And monitor log events, we can, of course, we can use that as a way for Ethereum smart contracts to notify an ICP smart contract, now it's time to actually perform an action. And this is great because we don't need any bridges. We just use these two features in combination, and we can achieve this two-way communication. So we would soon get into not coding, but showing code for this wallet application. And so I just briefly wanted to discuss the architecture. The round circle there represents the node we are running on, and we have 4 distinct smart contracts involved in this process. So looking at, starting from the user, we have the user interacts with the front end. The front end is a smart contract that has the sole purpose of serving HTTPS like a pre-built front end, in our case, a Vite and React front end. That front end interacts with the back end using this RPC, using RPC calls that I mentioned. The backend itself uses calls another canister, another smart contract, which is the EVM RPC canister. And that canister is responsible for routing the requests we want to make to Alchemy and routing them out of ICP using HTTPS outcalls. The call goes to Alchemy and then Ethereum. We are also using Internet Identity, which is a service provided by the Internet computer. It's an easy way for users to generate an identity, because that is one key requirement when interacting with ICPs, that you have an identity doing so. You need to sign all the requests. Okay, I'm going to fix this here. And we have 6 minutes, so I will be able to show you at least some code. First, I just wanted to briefly show you the overview here. The project is, in essence, a regular Vite and React project to start with. And once you have set up that project, so now we're building the front end, we just add one configuration file, that is the dfx.json file. And this file here, we say which components, which ICP components are included in this project. And here we have the internet identity, and we specify some information here. We actually pointing this configuration file towards a pre-built WebAssembly module that we get from GitHub. So that is one of the benefits with using WebAssembly. We can use composability on the canister level. We can, in this case, use a pre-built one. The EVM RPC canister is also a pre-built WebAssembly canister that we are just adding to our project. We don't need to build that from scratch. And then we set up our backend canister, saying here that the type of canister is a Rust canister. And I will show you the code for that one soon. And we have the front-end canister, and this canister is of a specific type. It's an asset canister, so it's, like I mentioned, its sole purpose is to serve assets. And here we also connected with a specific PMP run build script that we will use later. Okay, next up, I'm going to show you how to deploy things. I need to have my list there to remember stuff. So dfx deploy. dfx is the command you're using to interact with the local ICP development environment. And I have a replica of the ICP blockchain running locally already. And by saying dfx deploy, the dfx deploy, it looks at this dfx.json file and builds every part of the project according to its needs. So basically, it takes this internet identity and the EVM RPC canisters that are already pre-built, just spins those up, and builds the Vite front end, and also compiles the Rust-based backend. Next up, backend package. Yes. So let's see, the backend package. Or I can show you like this instead. The backend package here is a regular Rust project that we have added to our source folder. Not much to say about that, but in addition to the Rust code, we have added an interface specification using this candid interface specification language. And here we define the endpoints that the backend smart contract canister should offer. And in our case, we have the get address, get balance, and send ETH. Just a super simple. We have just 3 endpoints. So let's jump over to the front end and show you some how we connect the front end with the back end. Let's see, it's this one, I believe. So we are jumping straight to the, I didn't show you the project. Sorry. This is how it looks, by the way, once it's done. This is the wallet interface. This wallet address is generated by the backend canister. And you can see the balance here. Just some basic functionality. We can show you a QR code. And there's a send button where you can enter a to address and an amount. So let's try that. Do we have time for that? We have only 2 minutes. Sorry, this will have to be cut off slightly, the demo part. But let's just send a little bit of Sepolia ETH to our MetaMask wallet. And you see we don't need to sign anything. The whole signing process takes place inside the canister.
Nonce too low. Next nonce 3. Okay, I did something. Should never try to demo things live. I did something wrong before setting this up. But anyway, if this would have a sort of, you can see we did interact with the RPC and we got a error response back. So the send button, we jumped right into the send button, the React send button, and here we have defined a React hook that defines a send ETH function. We are using 10-stack query to manage the calls for us. Let's have a look at how this send ETH hook looks. It basically just interacts with the backend here, backend.sendETH. And now I have only 45 seconds. I really need to fast forward. And we have configured the front end with an actor here. Use actor, where we basically create an actor provider that wraps the whole component tree of the reg application, saying like this is the backend canister you should interact with. And by doing so, we get the fully typed interface that we interact with. And in 22 seconds, I'll jump right in and show you the send ETH function in the backend canister that matches the send ETH function we have defined in the interface specification here. And what it does in 8 seconds is that it creates a signer, an ICP signer using the Alloy library, a version of the Alloy, the fantastic Ethereum support library that supports ICP. So you can really easily sign a transaction, and it uses this threshold signature features of ICP. And I think I need to cut off there, and I'm happy to talk more about this later. Thanks.
She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking ether night whiz. Found her at a bullet hook sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-bop crack. Ooh, that lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bluff acorns grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right.
Hello guys, welcome to the workshop, Story, the P2P IP network. Before we get started, let me introduce myself a bit. So my name is Tim. I'm currently in charge of infrastructure partnership, DevRel, and also validator program at Story. So I also have some background in researching academically with copyright and blockchain. So as we know, Story has been focusing a lot on the AI agents side, but for this workshop, we will go back to the origin. What is IP? And then what is our tech stack? How layer 1 supporting us to create a better copyright system for existing world? So first question is, what is IP? So we've seen on the slide that PayPay is an IP, Nike is a patent, and then you have song, you have animation, code snapshot, games, and then you also have the section of real-world assets, such as designers, brands, and also physical items. So in law, IP is a very complex terminology. It's a bundle with between 2 types of rights. One is the ownership that consists of whether you're able to use the product, whether you're able to trade the product. And then the second part is the property right. So the simple example of property right is, can I use this IP for meme coin? Or can I use this IP for NFT? For example, when PayPay meme coin first released, they probably don't have the property rights to do so. So they are technically, they are violating the copyright of original owner. So let's looking back to a bit of the history of IP and why copyright law exists. So in the early days, when we first discover literature, when we first discover words, or when we first discover the format of displacement, we start printing books and art. In order to protect the ownership of those creations, we need a layer of protection, where copyright law as an IP layer came into place. The first IP law actually introduced in 17th century in UK, where they want to protect the ownership of publications. So with over the past 20 years, we experienced from 2-dimensional books and arts into 3-dimensional, such as radio, film, television, series, and gaming. And then now we are coming into the era of social media and generative AI. So the existing copyright law seems to be lag behind. We are yet to find a good way to tackle down and supercharging the evolution of technology, such as how we protect the data for AI models, or how we protect how we claim the ownership of image or text generated by AI models. So we can set a statement that the problem is the failure of current intellectual property layer. We are applying medieval system to godlike technology. So we need an internet native IP system where Story comes into place. Story is the world's IP blockchain. We want to tokenize world's creativity, making it programmable, making it easier to use, and also identify the ownership. We want to work with the internet instead of against it. So the programmable IP layer. So how do we achieve this vision of making it programmable? We split into three sections. So the protocol layer, the proof of creativity, merged with the general protocol layer and also our programmable IP layer license. And then it's our native layer 1, the story network, to boost, to supercharge all the creativity protocol. So story is a layer 1. We leveraged EVM execution and also using Combat BFT for our consensus layer. So we also added a precompile to supercharge and transversing computing over the graph data structure for our IP graph. Lastly is that with this layer 1, we can easily execute a lot of IP-related specific logic for IP oracle and also dispute automation. And then with layer 1, you kind of build this decentralized network for global composability of IP in their license and token. So imagine every chain can use us as an IP settlement layer, and also all the application on top of our blockchain can interact with each other, no matter which application or creator tooling you use. So a bit more detail into our modular approach of blockchain. So as mentioned earlier, we are EVM execution, Combat BFT consensus, so which means we are EVM compatible. So any EVM chains application can easily transition to our chain with all the transaction types and also development tool. We also support EIP 1559 and other EIPs. In the future, we will also have switched to state-of-art consensus algorithm. A bit explanation of how story validator works. So in order to run a validator, you need to run two types of client. The execution client, the story gas, which is fork of existing gas, including the meme pool and also IP graph precompile. And then the next client you need to run is the consensus client, where we added and also updated existing Cosmos modules such as staking, slashing, and minting, with the ABCI++ adapter of Combat BFT. So in between the two clients, we use Engine API to interact between each other. The second part I want to deep dive a bit into our layer 1 is the staking mechanism. Imagine story want to elaborate and break into the real world use cases. So we actually had a design of a special system in the staking mechanism. Thinking like you are in the bank, you want to stake your, you kind of want to save your money into the bank and then earn the APY. Normally it's a fixed staking period, right? You gotta stake for a year or 2 years where you gain the incentivized. So at Story, we have a chain native reward distribution system where allow delegators or validators to choose the staking period. Depending on the staking period, you get more multipliers. And also we designed a special phase called singularity phase. So before singularity phase, none of the validators are able to gain any block reward. Only once the singularity phase ends, the block rewards start to generate to create a fair environment for staking. As you can see on the diagram on the left-hand side, so we have currently flexible staking, 90-day staking, 360-day staking, and 540-day staking. Obviously, the more dates you commit, the more reward you'll get, and the higher multiplier it is. Lastly, I want to touch base on is the IP graph precompile. So this is one of the reasons why we choose to build a layer 1 rather than sticking on Ethereum ecosystem or layer 2. I think a lot of people initially had a lot of confusion or doubts why Story want to build a layer 1. So we did a lot of internal benchmark testing and experiments around layer 2s and layer 1. As you can see, like we do IP. So when IP has a derivative, it counts as it starts to build the IP graph. The first version of our protocol, it was deployed on Subfolia, but during that time, when we're trying to reach to, for example, remix over 670 parent IP, it reached the gas limit. So we kind of start to limit the creation of creators. And then also when you're trying to distribute a royalty towards those trace back to the parent IP, it's very hard because you need to go through all those layers, and then that will also exceed the gas cost. So for Story VM, what we did is we pre-compiled IP graph within the gas client, so the usage stays near consistent even over 1,000 remakes IPs, and also distributing royalty towards those 1,000 IPs will remain to 200K gas. As you can see from the diagram on the left, where we did a comparison between EVM native protocol and also our layer 1 deployed protocol. So what's the future for layer 1, our layer 1? There are two areas we want to look into. One is the graph vector database. As we said that we pre-compiled IP graph. So we're trying to see how we can actually optimize further into the IP graph transversal and computation, and then enforce the IP-related AI inference and training, so where we can use the graph database or vector database to actually segment out the IP into different vectors. And then the second part is the validator-related innovations. One of the most excited items on the roadmap for the near future is actually the decentralized IP oracle, where one of the future imagination that I witnessed is that are we able to allow normal Web 2 companies to start running the validators, acting as an IP oracle, where we can further using those data to prevent infringement happening or earlier detecting the copyright violation to support our automated dispute resolution. So next up is the proof of creativity protocol. So the POC, so I will use POC for now, since it's easier to pronounce. So POC is actually split into three major components. One is the module. We have the license module. For top module is the license module, royalty module, dispute module, and grouping module. And then we have the account-based system, which is built on top of the EIP 6551, the token-bounded account, where you have once you register your IP, it generates two assets. One is the IP account through the smart contract, and then the IP assets via NFT. And then we also designed a specific access module to further preventing people violating the system. So you need to follow the rules of IP account to the module, and then the interaction between module, and then module between module and registry. Lastly is the preparatory contract, where you can see it as a traditional SDK to a lot of operation. We build this layer of abstraction to support developers easily on board to Story, because we know when you want to mint a token and also attach a license at the same time, sometimes you need to write your own logic. But with the periphery contract, you can just call the single method to support your all the general execution action. So here is a slide diagram, a complex diagram introducing how the flows between different assets type and modules collaborating together. So we go from the bottom of the diagram, where we have the ecosystem application. So the ecosystem application first needs to register the IP assets. And then after registering the IP asset, you generate the IPA and then the IP NFT. Doing this process, you can also choose whether you want to directly attach a license or not. If you want to attach the license, you go through the license module, finding the license, for example, whether it's no use, no commercial, or commercial usage. And then through the modules, we now go into the license and access module and also royalty token. So every license is actually NFT as well. So we further elaborate the DeFi usage on those token assets. For example, you can use IPFi or Color marketplace to trade your license between each other, and also trade your royalty token on the swap or DEX for further usage. So slightly into detail what each module is meant to be doing. So for license module, it taking care of configuring the license template. So as I mentioned, we have 3 default templates, but user can also define their own templates upon their needs. And then registering derivatives will need to go through license flow as well. And then minting the license token and attaching the license token to existing IP. And then we have the royalty module, which it taking care of the royalty flow for different, it taking care of the royalty flow between parent IP and child IP, where for each parent IP, we generate a royalty vault. So through that vault, we can aggregate back all the related remix royalty back to the original user. So to sort out the problem between derivative creator and original creators, the cliff between those type of users. And then we have the dispute module. So currently the dispute, for dispute, we work with UMA. So UMA will taking care of the arbitration policies, where we as a protocol layer level, we just label the assets. So after labeling the assets, when the IP creator raise a claim, the assets will no longer be maintainable or attached to any parents or even making any further interaction with the protocol. Lastly is the grouping module. So for a lot of NFT collections, you can imagine you have a lot of IPs. You want to register them and then sharing the royalty of that collection. But certainly before a grouping module came out, it's very hard because you need to register and interact with each single IP assets. But with grouping modules, you just add all the IP assets into that group, directly interact with group as a instance rather than IP assets as instance. So one of the other use cases we are looking at is AI model training. Imagine you have a lot of image IP assets, and then you want to use it for model training. You can't really interact with each image IP assets, so it will take a very long time, and also it's very computation heavy. So with group module, you can just bundle all the image IPA into that group, and the model will just directly interact with that group rather than each individual assets. So lastly, I think one of the most important innovation we're trying to do is the programmable IP license. So what we witnessed over the past years, or more like a general common sense, is that people don't understand their rights. People don't read laws. So the initial creation of the smart contract was a cryptography term that was created in 19th century as well. The initial idea of smart contract is trying to transition contract license into machine-readable language for us to easily automate those contracts. At Story, for our license template, we remap the existing US law, copyright law. We extract all those attributes into visualized component for user to modify their rights. So visualizing your rights is a huge improvement in human society because it's reduced a lot of time for people to understand what's going on within the rights. So this is one of the IP kit component we're trying to build. We want to use this component to support creators to further understand what rights they hold, and further for a majority of the people to understand what right they hold and what rights they can give out. So through there, we can create a better licensing process and further preventing the copyright infringement or violation. Lastly, our aim is very simple. Just like USDC on-ramp and off-ramp fiat, so Story on-ramp and off-ramp IP. Thank you very much, guys. So this is the workshop for Story.
She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking, ether night whisk. Found her at a bullet hook, sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-bop crack. Ooh, that lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bluff acorns grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Da-da-da-da. Architect with a buffercorn's grit, protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with a do with a do with do with do. You ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a mempool express. Next bottleneck, I see mountain crush it. Click, clack, bosom, lace on firewall. I spooked and truce from trash sheets. That's my device. Nullifier sniffing on my cloaks too crisp. Mainnet gossips, tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. You private DMs, I'm the dumpster dive chump. Eyes everywhere, match 3 bird phones. Haunteries whisper, king chomp and blockchain bones. Make it down to my voted fuck. Stealth crawl through your junk dead scene. Bend it up to the entropy. Mace cracked vaults like, who's got the keys? Nullifiers huffing, you're just a rat with his firewall splinter to confetti bits. I'm curating leaks at the after party, sipping TLS tears. Call me well connected, I call it. Coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. They rock on PI. Get homemade in 7/4 Shaboom goes the efficiency pulse. The lag runs lagging in his latency so. Professor Wade's got the future on spinball. Urging notes dancing where the bottleneck's been. Professor Wade's got the future on spinball. Bugging tomorrow with yesterday's RAM stains. Velcro boots clicking through blockchain debris. cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Wade's got the future on spin. Urging notes dancing where the bottlenecks been. Professor Wade's got the future on spin. Bugging tomorrow with yesterday's ram stains. Chaos is not a compeller. Order's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI? Nah, just 3 Red Bulls in a row. What you building, prof? A singularity jukebox. How you stay charged? Espresso straight through my cortex. Who's your nemesis? Light runs found. Age? Old as speak, young as each block mine down. Professor Wade's got the future on.
Hello, everyone. How's it going? Pretty tired? Is this showing? All right, cool. So thanks for being here. My name is Stephen Pu. I'm one of the co-founders of the Terrassa project. Today, we're going to present something a little bit more fun, okay? The title looks very boring. Resource efficiency of realized mainnet throughput of layer 1s. What it really is a study that seeks to expose the lies that you've been told about layer 1 performance metrics. All right, let's get to it. So the layer 1 space, the Web3 infrastructure space has been getting extremely crowded, increasingly more so every single year. And the need to differentiate between those infrastructure networks has been growing. But that need has not been fulfilled. It's been thwarted by unrealizable theoretical performance metrics, unverifiable tests done on secret networks, overly optimistic assumptions that people are making while conducting these tests, and of course, juicing up their performance with supercomputing level hardware. All right? So how do we fix this? How do we cut through the hype? How do we cut through the lies and the BS? Well, first of all, you conduct all your tests on mainnet. You only trust realized performance metrics on mainnet. It's on mainnet or it didn't happen, okay? Mainnet or it didn't happen. This gets rid of the theoretical numbers. This gets rid of the secret, non-transparent, unverifiable numbers, okay? This gets rid of the unrealistic, non-real world assumptions. Have your performance metrics on mainnet. Second, the metric must be balanced by hardware costs so that you're not artificially juicing up your numbers while you're conducting performance tests. There are different types of performance, there are types of consensus, such as leader-based consensus mechanisms that especially exploit juiced up hardware. You guys all know what I'm talking about, probably. A lot of networks out there with minimum requirements of their validator nodes that are extremely expensive. Might as well be a supercomputer. So we propose a new metric. Very simple, right? So simple, even my grandmother understands it, all right? It is simply TPS per dollar spent. So we take 2 numbers, realized TPS on mainnet, divided by the cost of 1 single validator node, right? That's it. Very simple. Everyone can understand this, right? It cuts through a lot of the lies. The sources, right? We get the throughput on the mainnet sources primarily for this study through a website, an application called ChainSpec, which is an application that's dedicated to benchmarking on-chain performance across Web3 infrastructure networks, layer 1s and layer 2s. Go check it out. Very interesting. We get the hardware costs, configurations from every single project's their own official documents. We didn't make it up. Their own official documentations, their minimum hardware requirement for their validator nodes, and we estimate the cost using the Google Cloud calculator, right? All perfectly transparent. Every piece of data in this study is on terrassa.io/fast/data. There's a Google sheet. Every single bit of data is sourced. Go check it out. You can reproduce it if you want. If you have a problem with any of the data, let us know. Happy to correct it if we made a mistake. All right? Let's go through and see how this is done. Number 1, we look at realized throughput on mainnet. So on chain spec, if you go through and sort by maximum TPS realized on mainnet across a 100-block range, you get 34 chains up and including Ethereum, okay? We only included 22 in our study. We excluded 12, 10 of which are permission networks. So permission networks, right? Beyond, besides being a complete heresy in the world of decentralization, they have highly relaxed trust models and highly relaxed networking condition assumptions. So their performance numbers are not technically comparable to permissionless networks. The other one is sharded networks. Now, sharded networks, sharding is a perfectly fine way to scale. It just so happens if you actually add up all the throughput numbers across sharded states, that is not a fair comparison because you're trading off cross-shard transactional latency for expanded storage and throughput and storage. If they're not sharing the same state, it's not a fair comparison, okay? So out of the 34 on chain spec, sorted by max TPS realized on chain, 12 were excluded, 10 because they're permissioned. They shouldn't even be on that dashboard as far as I'm concerned. All the layer 2s are permissioned, by the way, in case anyone doesn't know. And 2 were excluded because they were sharded. So we're only going to look at the 22 networks. And here are copied directly from chain spec, the 22 networks, maximum realized TPS on chain, right, across an 100-block range, right? Copy directly from their website. You can go look at it yourself too, right? There's another number, the number that we're all very familiar with, theoretical TPS, right? Sounds really great. Anyone can say anything about theoretical. I can say that Taraxa has a theoretical TPS of infinity, whatever, not verifiable, right? So projects are provided their theoretical TPS on chain spec as well. And look at the difference between the theoretical TPS and the actual realized TPS. It's pretty big, right? We put a bullshit number on there too. Yeah, look, 10 for Taraxa. Others are much more ambitious than we are. On average, of the 22 networks that are included in the study, there's a 20x gap between theoretical TPS and actual realized on-chain mainnet TPS. 20x, right? And let's plot, right, on the horizontal axis, maximum observed TPS actually realized on mainnet versus theoretical TPS, right? So group A, modest TPS, modest aspirations. They're very honest. They're honest people, right? Great. Kudos to the honest people. Group B, pretty good TPS, modest aspirations in their theoretical estimations, also pretty good. Group C, I can only describe them as very ambitious. Crap on-chain TPS, very ambitious aspirations, okay? So you guys can check out who these guys are by looking at the source data at terasa.io/fast-data. Look at the numbers yourself. All right, we talked about max on-chain TPS. That's the denominator. Let's look at the numerator. The numerator is cost per month for a single validator node. Where did we get this from? We got it from every single project's official documentation. You go on terasa.io/fast-data, every single documentation page where we got these configurations are linked. Check it yourself, right? Here are the hardware configurations by CPU, memory, and hard drive, right? So these were adjusted slightly, scaled slightly, so they fit nicely onto the graphic. At the top, the least hardware requirement for CPU, 8 gigs for memory, and 100 gigabytes of SSD, right? This is for a pruned light node for Taraxa, pruned consensus light node. Much bigger one at the bottom, right? This is just for reference. So once we get the hardware configurations, the minimum hardware configuration for a validator node from every project's official documentation, we turn them into numbers. We turn them into dollars by putting them into Google Cloud Calculator. Now, the absolute numbers that you're getting out of the Google Cloud Calculator is not important. What is important are the relative numbers. We're talking about ratios. It's very important that all the data come from the same source. Everyone knows Google Cloud is not the cheapest, but we're getting it from a consistent source, okay? Every single Google Cloud configurations where we got the dollar numbers are, again, any guess where it is? Taraxa.io/fast/data. Every one of them linked. Click it into yourself, see it for yourself, all right? So here are all the numbers, copy down for every single hardware configuration for minimum hardware requirement for a validator node across these 22 networks. This is the dollar amounts. Again, the absolute numbers are not important. It's the relative numbers that are important. We're calculating a ratio here, okay? And here's the result, right? TPS per dollar spent. Or the longer version, mainnet realized TPS. Realized, not theoretical, not made up, not dreamed up. Realized mainnet TPS per dollar spent per month for a minimum hardware requirements for a single validator node, okay? These are the results. Check it out yourself. Taraxa on its own right now has a mainnet maximum TPS, realized TPS of 4906. The Google Cloud estimator calculates our validator node costing 98.7, just under $100 per month. And we have a ratio of 49.7. So making us #1 in the world in terms of TPS per dollar. These are real numbers, transparent, verifiable, not theoretical, not dreamt up, all right? If you'd like to disagree, love to understand why, okay? I don't understand why no one does this, all right? So, if you're still awake, you might ask, how did we achieve such performance? I know there was no shilling. I'm just talking about our technology. So, Taraxa achieved this level of performance and efficiency because of the following reasons, right? Number one, we have a next generation block DAG architecture. So block DAG, if you haven't heard of it, it was first described in a paper called Phantom Ghost DAG in 2018 by Sompolnitsky, Wyborski, and Zohar. It's a very interesting architecture. We read the paper, we implemented it. It allows parallel addition of blocks onto the network instead of single chain, all right? So on a single chain, you can only add one block at a time. On a block DAG, you can add multiple blocks at a time, right? Almost every single mainstream layer 1 you see today are single chain architectures. They're massively sacrificing security guarantees to get the performance that they're getting. Massively. Leader-based consensus, all right? That's a great example. They predict pre-compute all the leaders that are going to be producing the blocks. And every single leader stay there, you know, producing blocks for many, many epochs, right? Let's turn an entire network of thousands of nodes, attack surface of thousands of nodes, let's turn into a single node, all right? Great sacrifice of security for performance. Block DAG doesn't have this issue. It doesn't need to sacrifice security or decentralization to achieve this kind of performance. And this is borne out by realized mainnet TPS, not dreamed up theoretical paper TPS, all right? Second, we have a dynamic sub-second block rate. It makes sure that the network does not waste any work. It tunes up the block production rate when it sees there's a drop in the transaction overlap between the DAG blocks. And it turns it down when network traffic goes down the other way. We have VRF and VDF, which reproduces the random delay in proof-of-work systems without the arms race of proof-of-work systems that cost a lot of energy. You know, it has all the benefits and none of the downsides. We have true finality with an asynchronous PBFT process. This is very critical. Anyone who has tried to take an EVM and push it above 100 TPS will realize that the EVM actually puts all reads and writes into state through the Patricia-Merkle tree first. How do you get past that? Why did they do that? Well, it's because they're accounting for state reversion risk. So in order to get rid of state reversion risk that's inherent in probabilistic finality, you have to introduce true finality. So we introduced an entire layer of true finality in order to remove the need to always go through the Patricia-Merkle tree every single time state is read and written into, okay? We have asynchronous and parallel execution, and of course, we're 100% EVM compatible, right? This is SDamber, you know, show up with EVM compatible layer 1s, right? We wouldn't dare showing up with some Rust VMs. All right, so Taraxa this year has 5 bounties as part of the hackathon. So we hope that after this talk, if you're not too angry and too pissed at me, you will like to check us out. You would like to build on the fastest and most efficient layer 1 in the world. We have 3 AI agent bounties, and that's very unique, right? Everyone has AI agent bounties. I hear the word AI every 3 seconds sitting at the desk. What's unique about Taraxa is that we have a platform called Chape built on top of the layer 1 that actually is a decentralized network that feeds real-time Telegram conversational data from public Telegram groups, from over 20,000 crypto English-speaking public Telegram groups. No one else in the world gives you this data. Nobody else. I looked very hard. That's why we built this. And this is what's going to make the agents that are built on this unique data set substantially different than all the other agents, right? LLMs, they're easy. Download the model, feed it some data. Depends on what kind of data you're feeding it. This unique data set gives you unique insights, okay? Check it out. You won't be disappointed. We also have 2 other infrastructural layer 1 bounties for you to check out. But come to Taraxa.io on our front page are all the resources you need to check out our bounties. All right. Our team is sitting at desk T1 over there. All right. And we have a booth 314. If you agree with us, if you disagree with us, if you want to yell at me, come to these places. I'd love to talk to you. All right? Thank you very much.
Across gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess. Scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. Click, clack, goes a mace on firewall. I spooked and truce from trash sheets. That's my device. Nullifier sniffing by my clothes too crisp. Mainnet gossips tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. You private DMs, I'm the dumpster dive jump. Eyes everywhere, that's 3 bird phones. Haunteries whisper, king chomp and blockchain bones. Make it down to my voted fuck. Stealth crawl through your joint and scene. Pen it up to the entropy. Mace cracked vaults like who's got the keys? Nullifiers huffing, you're just a rat with These firewall splinter to confetti bits. I'm curating leaks at the after party, sipping TLS tears. Call me well connected, I call it coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti. They rock on PI. Get homemade in 7 for time. Shaboom, dose, efficiency pulse. The lag runs lagging in his latency so. Professor Wade's got the future on spinball. Urgent notes dancing where the bottleneck's been. Professor Wade's got the future on spinball. Plugging tomorrow with yesterday's RAM stains. Velcro boots clicking through blockchain debris. Crypto notes flood cackle and shout. Self-sustaining hubs flicker in the blackouts out. Professor Way's got the future on spin, boy. Urging notes, dancing where the bottlenecks been. Professor Way's got the future on spin, boy. Plugging tomorrow with yesterday's ram stains. Chaos is not compeller. Order's just a bug I forgot to unfurl. Mainnet shivers as their wild hair glows. Rumored AI? Nah, just 3 Red Bulls in a row. What you building? Prop? A singularity jukebox. How you stay charged? Espresso stream through my cortex. Who's your nemesis? Light runs dial up found. Age? Old as speak, young as each block mine down. Professor Way's got the future on spin, boy. Urging notes, dancing where the bottlenecks been. Professor Way's got the future on spin, boy. Plugging tomorrow with yesterday's ram stains. Throwing me mad, but mad's just a beta test for Boodle. Oh, he jumps right. Oh, he jumps right. Oh, he jumps right. Oh, he jumps right. We're biddies, not just dreamers. On-chain truth, no middle schemers. Forking hard and shipping code till sunrise every day. DAOs are voting, vibes are flowing. Buff-eyed corns are still a-growing. While the world is breaking down, we're regen in a new way. Some VC said this tech won't last. And the hurt bubble, watch it crash. But we don't need your central banks. Cause regen biddlers stack in stacks. For we biddy let this city on sports and chains. We biddy let this city with regen brains. We biddy let this city on sports and chains. No rug pulls, just pure on chain. Whale pools floating, fees are burning. ZK proofs the chains keep turning. Every block we validate is trustless, clean and fair. Open source and gas optimized, code permissionless and finalized. Fork marmots on the scene, you know we're gonna bid a little it there. Some tread fibro just rolled his eyes. Where's the yield? Where's my supply? But we don't need your banker games. We just launch and stake on chain. Go, we biddy let the city on sports and chains. We biddy let the city with regen brains. We biddy let the city on sports and chains. No rug pulls, just pure on chain. If you fade it, just stay seated. The etherverse will leave you heated. We don't need your legacy, cause regen memes are proof of brain. We bid let the city on sports and chains. We bid let the city with regen brains. We bid let the city on sports and chains. Rolling up and slapping chains. She's a Colorado comet in code forged steel. Wings snipping latency like scissors through gel. 9 centuries young with a lance that's if your chain's choking ether night whisk. Found her at a bullet hook sucking down APIs. Armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-bop crack. That lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bluff acorn's grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right.
GM everyone, hope you are having a good day. My name is Vivek. I'm working with Kite AI. So we are one of the earliest AI Web3 protocol that is working on modifying the EVM machine and building our own Kite VM layer. So what does that mean? We are trying to add AI as a first-class citizen. We have seen a lot of blockchains retrofitting AI into their stack. Today, I'm going to quickly show you what we are building, why we are building it, what are the changes we are going to bring into the EVM stack, what could you do with it, and what stage are we in, and what is the direction that we are taking. So when we say we are redefining the AI economy, we have seen a lot of these AI builders who deploy their models, agents on some of the platforms and then do not get the real value out of it. What I mean with that is, if you are a good model developer, you upload it on a platform and people keep using it. The platform benefits from it, but the model developer or the agent developer in the new agentic world really do not get the benefit out of it. And that's something that we want to change with Kite AI by creating an attribution or like the proof of ownership of the contributor to the platform on chain, which will use some logic very similar to what we have seen with the chat GPTs of the world based on how much usage that has been done on the platform by the end users, the builders, and the contributors of models and agents would be rewarded based on that. And that's a consensus mechanism that we're building is also new, which is different than proof of stake and proof of work. We call it proof of attributed intelligence. The more you attribute, the more rewards you could get from the platform. So why do we need this new L1 for AI? So like I said, we have always seen that the execution, settlement, consensus, and data availability had a monolithic world. Then we moved to the modular world. But even in the modular world, the focus was always Web3. And the AI data, until today, is not registered on any chains. So what we thought is, if we start adding AI compute across these layers, whether it is the execution layer, the settlement layer, the updated consensus layer, which is like the proof of AI, and also add some of this information in the data availability layer, we will be able to advance the overall Web3 ecosystem by adding AI metadata into the stack, into the EVM stack. And based on some of these information, the users across these layers could not only benefit, but they could also use it for a lot of other use cases, whether it is building agents, preventing frauds, or doing a lot of prompt-based solutions. That's also something that we built as a part of our testnet launch. So the current problem, so if you look at it on the top, the state, the transaction, and the new state or the updated state. So and that is something that we see in the EVM ecosystem. So there's a certain state of the block, and then there's a transaction that takes place. In this case, it could be a swap, a withdraw, a transfer, or a bridge. which mutates the state, and then you get an updated state. In this case, the state only captures information which are related to the transactions happening on the blockchain without any AI component into it. So, like I mentioned, the EVM or other blockchains currently are not designed to capture any AI metadata into it, whether it is which model was used, who was the contributor of the model, what within the model was used, which agent was used for that matter, and how much of the data was used in processing a certain transaction. So this is something that we are actually updating into what we call as the Kite VM, the virtual machine, by adding AI compute information as part of the process. So in the new world with Kite AI, when we launch it around summer this year, the users can also see which model, which data, and which agent was used as part of the transaction, because in the AI Web3 world, you will be using either the data, the model, or the transactions, but also AI infra to process, for example, a DeFi application, right? Or for doing something with payments. And based on which model, data, or agent was used as a part of the transaction, you get an updated state which records these usage and then rewards the contributor based on that. In proof of attributed intelligence, what we do is you see the layer on the top, like the new block, the existing blocks, they do not store AI information. In the new block, you also have something which you see at the bottom here, which is the AI compute. And there is a standard developed by Ethereum around it. It's called ERC 7001, which currently caters to only the NFT use cases. So we are also trying to contribute towards the EIP or the standard, which also could cater to fungible token use cases. So what it does is basically it looks at a different set of new data that has been added to the block, and based on the block on the chain, the rewards will be calculated and distributed to the contributors. A part of the testnet launch that we did a couple of weeks ago, so we were able to hit 1 million wallets, which was a very interesting and a very valuable number for us to experience and see how the users look at it from an adoption perspective. I think we see a lot of interest from different builders and consumers, where we actually built a couple of AI agents that people could interact with as part of the testnet. And we also saw a lot of inference calls. Here we mentioned 25 million. It actually went recently close to 50 million. And these AI inference calls, imagine if these inference calls are actually being used by a model developer or through an AI infra, and you could actually be able to put a weight to it and calculate the value it created, the value accrual, and then actually end up using your AI, as we call it, proof of attributed intelligence, to reward the users. We will be able to create an economy which will be like more self-sustaining, but also will create a flywheel effect, where on the Kite AI marketplace, the builders would want to publish their AI agents, and the consumers would want to use a pre-built AI agent or a model or a data set, which is very hard to find across different stacks. And that's also something we see, that it is very difficult to find a clean data set or a ready-to-use model or an agent so that you can build something on top of it, whether it's a dApp or a new AI-based agent. And this is the composability that we bring to the ecosystem, where as users, you could, for example, pick a data set that you get out of, I don't know, from a Pyth kind of a network, and you have an AI agent that is built by using an eigenlayer framework. And then there's a model that was deployed by someone from Hugging Face, but also on our platform. And you could, in principle, compose all these three solutions and cook up a new solution altogether, which can basically solve or build a new dApp using AI and Web3. And this could be a prompt-based dApp, so there are choices you could make. It could be a prompt-based dApp, it could be an agent, or it could be just a solution which is around data, which gives you something on-chain proof about the contribution of the developers. So like I mentioned, in terms of protocol development, currently EVM executes only the smart contracts, and the smart contracts only takes information and sends it to the bytecode, which do not have any AI data into it. So currently, the EVM smart contract doesn't have any of these opcodes, and that's something that we are trying to add, which will actually also include some of these models and inferences call into the opcodes. And a lot of these AI interactions that we do, we just cannot move it as is into the blockchain because it consumes a lot of processing. There's a large amount of data, as we know, in order to process a model or to run an AI data set. And if we want to also execute such a large data set, that will also cost a lot of gas. So which will actually take us back to the 2008 days where the gas fees was a big problem. So our approach, like I mentioned earlier, is to create an AI-specific execution layer, so a smart contract which also includes information about AI execution in it. And this AI execution in this case is adding some of the new AI opcodes. And the opcodes in this case could be something around AI model, AI inference, or even AI metadata for a certain domain. And for proof of, what we are also looking at is hybrid execution. So we want to process some of the things on-chain, but there will also be some part which will be processed off-chain. And in order to also process some of these things, there are a couple of solutions that has been built recently, which actually processes some of the data in an AI format, which are called as AI oracles, basically. Hyper Oracle is one of them. Aura is another. So the idea is also to see which pieces of these existing AI oracles we could use, but we are also looking at some smart and futuristic storage solutions apart from IPFS Arweave, like Walrus, to name a few, to see what are the things that these new storage solutions could store off-chain so that we could also use the data when it is needed to process on-chain. And we could always create a hash and a pointer in order to detect which transaction was processed on which particular data set. In terms of proof of AI consensus, like I mentioned, so we are also going to add a validation mechanism where the proof of AI will go and validate if the contributor has a certain profile, if it was not a spam, and the bot prevention around it, but also the overall security, so that people could not very easily gamify the system. I think it's also very important when we are adding an incentive structure to a new system. It's very easy to bypass the system with either bots or by doing an MEV attack. So that's also something that we are currently exploring. So in order to build something like this, it's a Herculean task. So we read a couple of research papers. We are working with 40+ top universities across the world, but also working with some of our top Web3 industry partners, whether it is EigenLayer, whether it is Avalanche. So we are an Avalanche sovereign chain. That's the decision we took to deploy everything on EVM because one, it's an existing ecosystem of developers and projects that could build on us and utilize the AI value that we bring to them. At the same time, it has all the cross-chain compatibility that we require in the EVM world. So the two options is either we fork an existing EVM, and that's the choice that we are taking, or the other one is build everything ground up, which actually is a very time-consuming cost and cost-wise and a very complex affair, and we don't even know if we'll be successful at the end of that experiment. So the approach that we're taking currently is we are going to fork one of the EVM clients, and then we are going to create our own Kite, deploy our own Kite virtual machine, which will have some of these changes that I mentioned across the layers in terms of the execution, the settlement, and data availability, as well as the consensus mechanism. So what we have done is we have reached out to a lot of researchers to try to come up with research papers. So there are multiple research papers that will come out from Kite ecosystem. One will be around the entire approach of how we are doing the proof of intelligence. There will be a protocol paper that we would also want to distribute with the ecosystem, so that they understand how this entire Kite VM ecosystem was developed. So like I said, so there will be like AI optimized state management where the AI models, weights, inference, and output and metadata would be stored on chain. And the storage, like I said, will also use different mechanisms, whether it is Merkle trees or blobs that can be stored also on storage with a walrus-like solution. We are going to have AI-specific bytecode, like I mentioned. So for example, you could add AI model in this case, which model was used, which inference was used. And we are also looking at the mechanism to add proofs to it, whether it is it's an optimistic proof or whether it's a ZK-based proof. There will be proofs that will be generated so that people could actually go and verify that they were the contributors and they can get value out of it. For proof of AI consensus enhancement, so we are going to add AI-generated information to the consensus mechanism. But we'll also have, like I mentioned earlier, an attribution detection based on the contributor and the usage and the amount of usage and the type of usage of the contribution that was made to the AI. Another thing is also what we are looking at is the optimized gas. So we want to come up with a relayer approach, but also like fund some of the gas initially. At the same time, add AI oracles, like I mentioned earlier, for heavy compute. And also look at off-chain storage for pre-trained AI models, which can actually be just sourced from these RV or Walrus kind of storage solutions. So this is ERC 7007 that was written earlier this year, which actually caters to the AI-based use cases with the AI opcodes into the VM stack. Currently, this 7007, like I mentioned, is very focused on NFT use cases for ownership. And that's something that we will have for model owners. But we also want to have more non-NFT based use cases where the transactions are also captured in the AI transaction data is also captured into the blockchain and stored on the blocks. So if you want to follow us, we are on Kite AI. We are called GoKite.ai. And we launched our testnet V1 recently. We'll have a testnet V2 end of March. And then by the summer, we'll have our mainnet launch. So we're looking at partners who would want to build an AI Web3-based novel solutions. So if you are interested to build with us, we are part of the Avalanche Infra Build program as well. So we could help figure out some novel use cases around AI and Web3 that you would want to build for different solutions. We are also looking at a subnet architecture stack, which is similar to what we have seen with the bit tensors of the world. So if you're a developer focused on a DeFi use case or on a fake detection use case, or you come with a very strong domain background, so there's a totally separate subnet-based approach we have for such contributors, whether it's a developer or a founder that could come and build with us. So we provide ecosystem access, but also development support with our partners in the ecosystem, which are subnet partners and Avalanche in this case. A couple of things that I could quickly show you is, so this was the very basic agent solution we built as a part of our testnet, where each of these agents could give you results, and it interacts with the Kite chain, and the points are stored on chain, and you can be rewarded as part of the airdrop. We actually built what we call the classic counter DApp. It is on again, if you go to GoKite -AI, and if you go to the Kite counter DApp, you can actually look at all the testnet and all the other information and the stack that it is built with. Very soon, we are also going to launch AI templates so that you can very easily click, fork the template, and start building your own solution on top of it, depending on what use case you have. Very similar to what we have seen with the Versal SDKs of the world. Yeah, that's pretty much it from my side. Thank you so much for listening. If you have any questions, I have a minute to take them. I take it as a no. Thank you so much. Have a nice evening, all of you.
She's a Colorado comet in code forged steel, wings snipping latency like scissors through gel. 9 centuries young with a lance that's, if your chain's choking ether night whiz. Found her at a bullet hook sucking down APIs, armor clinking with layer 2 lullabies. Scalability scripture, she winks at the moon while Lagrange drools over slow motion doom. Her shield's a disco wall, fracturing legs, grass, shooby-doo-ba crack. Ooh, that lance a lightning fork, splitting bottlenecks backs. Alliance architect with a bluff acorns grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Architect with the buffercorn's grit, teaching stale protocols how to fucking commit. Decentralized this, she smirks mid-flight as her wings tickle nodes into doing things right. Up to do with a do with a do with do with do. You ordered a moonwalk across gas feed graves. My mainnet's smoother than your mom's VPN saves. Daughter of the Rockies, high-speed high priestess, scales of justice ballast on a Memphis Express. Next bottleneck, I see mountain crush it. Click, clack, bosom, lace on firewall. I spooked and truce from trash sheets. That's my device. Nullifier sniffing by my clothes too crisp. Mainnet gossips, tastier than breakfast chips. Story, hack, flurry. Mama's making news before the cold reload. Got receipts in my cheeks, encrypted and plumbed. You private DMs, I'm the dumpster dive jump. Eyes everywhere, that's 3 bird phones. Haunteries whisper, king chomp and blockchain bones. Make it down, top it, fuck. Stealth crawl through your junk dead scene. Head it up, the entropy. Mace cracked vaults like, who's got the keys? Nullifier's huffing, you're just a rat with His firewall splinter to confetti bits. I'm curating leaks at the after party, sipping TLS tears. Call me well connected, I call it coffee for drip and the lab coat on fire. Sticky note constellation stuck to the ceiling wire. Gas fees are confetti, they rock on PI.
Hello, everyone. It's a pleasure to be on the Denver stage and talking about chain abstraction. Before we begin, I will request a quick round of introduction from Vivek and Brendan here. Anyone can go first. Brendan, you want to go first?
Sure. Yeah. So my name is Brendan O'Toole. I'm a senior product manager at Agoric. Bit of background on Agoric. Agoric is building orchestration capabilities that enables developers to create user-friendly apps that allow the seamless movement of assets and services across chain.
Hi. First of all, it's great to be here in among some of the brightest minds in the Web3 space and ecosystem here. My name is Vivek. I am the CTO of Okto. Okto is a end-to-end chain abstraction solution where we are basically building a SDK using which developers can express their intent that will be orchestrated across the chain using multiple layers and components. The main intent here being to simplify the usability and the experience for the app developers and user experiences for end users as well.
That's amazing. So that brings me to my first question. Like right now, Web3 seems very fragmented. We have multiple chains, multiple protocols. There are different consensus mechanisms. Everything seems so clunky. So what's your opinion on that? Vivek, Brendan, you are going to first? Yeah.
It's already obvious at this stage that fragmentation is a big problem in the industry. I think what's interesting about fragmentation is it's allowed innovative solutions to run in parallel because people have had to figure out how to coexist. But I think the real challenge is not the fragmentation itself. It's been the lack of connective tissue that has bridged these ecosystems together to act as conduits for that liquidity. So, there's such a huge addressable market out there if we can all bring it all together. And that's what we're trying to do with orchestration. We're trying to bring these players together. We're trying to abstract away the complexities to enable this amazing, desirable endgame of this UX. And these are the real problems that we're focusing on.
That's amazing. Vivek, your opinion?
Right, I think it's a very good question because the fragmentation in the Web3 ecosystem today is real. I mean, there is a whole selection of networks, protocols, liquidity solutions that are spread across with their own set of complications that make it very difficult for a developer to build on them. Right? Because a developer has to worry about how am I going to orchestrate my transaction across multiple ecosystems, how am I going to orchestrate my transaction across different chains, what if the user has liquidity spread across multiple networks, how am I going to aggregate that liquidity and then execute the transaction. And the reality is that's not what the developers or the end users eventually want. Right? So if you ask an end user, what do they want? They want their intent to be solved. Right? So for example, if I have an intent to invest in a perp protocol, then I should be able to invest in the perp protocol without having to worry about what the network is, what the protocol is, where my liquidity lies. And the same applies to an app developer. An app developer should be able to develop a dApp without having to worry about which network am I actually executing this transaction on, how am I going to execute this transaction on, etc. So the real question here is, how are we going to achieve that? Right? For example, how Brendan mentioned about creating this connective tissue in this fragmented ecosystem. I believe that it is a matter of creating this solution at 4 different levels. I mean, first of all, you need to solve for coordination. Then you need to solve for execution. Then you need to solve for data and liquidity. And then finally, settlement or finality on chain. Right? So take the example, right? So take an example of the perp example that I was saying. So for example, if I'm an end user and I wanted to make an investment in a perp protocol, where my assets are actually lying on 3 different chains in 3 different ecosystems. So some of it is lying on Solana, some of it is lying on Aptos, and some of it is actually lying in, say, Ethereum, right? How am I going to then be able to execute this transaction, say, on a Hyper VM, right, or Hyper EVM, right? So what do you need to do? You need to, first of all, find out what is the best way for me to aggregate this liquidity. Then you need to be able to execute these steps and aggregate that liquidity. And then finally, be able to execute that transaction on the target network and then do the final settlement. And so if you are able to do all of these steps and execute this transaction across all of these steps in a single click of a button, or a single expression of intent from a developer, then that is the unified ecosystem, or that is the unified blockchain world that every developer or every user is actually looking for. So I think fragmentation is real, but the end state here would be where everything is unified and automated.
That's amazing explanation. That brings me to a question specifically for Vivek. What is exactly the chain abstraction solution Okto is building? We are talking about the complete stack. Can you put some light on it?
Sure. So see, Okto, like I said, we are building an end-to-end chain abstraction solution. The start of which is basically an interoperable wallet that we are building. An interoperable wallet that gives you delegated access to execute transactions across any of the chains and any of the networks that we support. At this moment, we support more than 30 networks, and we are expanding as we go along. Now, if I were to go back to the 4 layers that we were talking about, right? So how are you going to do coordination? How are you going to do the execution? How are you going to do... And in Okto, we have actually built out a solution for each one of these 4 layers, and made it so simple that a developer is able to just express their intent and is able to execute. Right? For example, we have built out a solution called as unified liquidity layer. What this unified liquidity layer does is that it actually aggregates liquidity transparently without the user having to worry about where their assets are lying. We find the best ways to do it. We find the most cost-efficient ways to do it, the fastest ways to do it, and then aggregate that liquidity for the user. Similarly, we are also building out a solution called as DWN. DWN is what we call as Decentralized Wallet Network. Decentralized Wallet Network is, I believe, one of the world's first fully decentralized wallet network that is actually driven on top of AVS operators, where the user is actually able to express an intent, get the signing done, and the signing transaction can then be executed across multiple chains. Then we back it off with what we call as internally decentralized transaction network, which actually finds these paths and executes the transactions across multiple networks. So in summary, if you were to go back to the original framework that we were talking about, coordination, execution, data and liquidity, and then settlement, we are actually operating our solution across all of those things. And that's why we say it's total abstraction, or we say it's an end-to-end abstraction solution, where a user is able to express their intent with just one single expression of intent, and everything else on the blockchain is taken care of by a platform.
That's amazing explanation.
Can I chime in there?
Yeah.
Yeah, so yeah, it's worth distinguishing that what you guys are doing with Okto, you have this, it's a lot bigger ecosystem that you're trying to abstract. You're trying to abstract kind of the whole, everything in between. The way Agoric is approaching it is different. And again, this speaks to how there's a lot of people trying to solve this problem in the space. No, it's not a monopoly, it's a market. People are doing it in different ways. They're going to do it in ways that complement each other. You know, there may be ways that Agoric and Okto work together to overlap and increase the surface area of this orchestration fabric. But the way Agoric looks at it is, you know, we're a smart contracting platform in hardened JavaScript, but we look at it, you know, our orchestration smart contracts are these programmable smarts that can automate this cross-chain, multi-chain function. And so the nature of our smart contracts are, you can do things that you can't do anywhere else. You can code timers. You can have actions take place in future when a certain date is met. You can have transactions happen over multiple blocks. You can have things preset to trigger under certain events. And so you program the smart contract. It has all these features that allows the user, the builder, to code in this amazing experience from start to finish, and so it puts more of the power in the builders' hands, because the builders are ultimately the decision makers. They need to choose orchestration tools to provide that exceptional UX, and so when they do that, they have to. What they pick is important, because it might not be a one-shot solution. They have to do it a few different ways. Yeah, I just want to kind of add the context of how Agoric is a little bit different to Okto.
Right. So, and I think I agree in that Agoric is doing, I think, beautiful work, especially on the execution layer of the overall framework that we were talking about. In the way that we are actually trying to build the DTN network is pretty much in the conceptual thought of the way we were actually talking about, in that we eventually plan to have a whole, you know, a network of solvers, and then for the users to be able to express their preferences of who actually the solver would be and how the solving actually would be done. So while in the first layer that we have actually built out, we will probably be one of the only solvers in the network, but eventually the solution is actually built out, and that's the reason why we actually call it decentralized, in that we are going to have a whole network of solvers and then be able to find the most optimized way to solve it across multiple solvers.
That's amazing explanation. But whatever the point you said, Brendan, like that brings me to a conclusion that more than smart contracts, we need smart coordination inside the blockchains. How is Agoric orchestrating it, and how is the solution working? Do you want to put more light on that?
Yeah, so I don't see how smart coordination is possible without smart contracts, right? The smart contracts are the composable, reusable, programmable, like insert your thing here, that you can program these smarts into, right? And so the coordination aspect is like, without coordination of anything in any market, you don't have anything. Like, think about Amazon, take away logistics, take away payment gateways, what are you left with, right? So it's how you string it all together. And the hardest part with coordination is it's not sending a transaction from one chain to the other. It's sequencing all the things that need to happen at the right time. And so with, orchestrate smart contracts on Agoric, you can do that in the way you need to. The builder picks his own journey, right? You can build in the parameters that address that user's intent. Ideally, if we're talking about like top down, the user is never going to care about what needs to happen for their intent to be delivered. No user wants to know how the sausage is made. They just want to eat their sausage and go home. They don't care about validators. They don't care about bridges. They don't care about any of that. And so at a very simple level, that's what needs to be abstracted away. And it's on the builder picking his tools to decide that and pick that journey.
That's amazing. So this brings me to a question, like we have spoken about different methodology that we are solving the user experience for the end user. So what is the end game for user experience on blockchain? Like, Vivek, you want to go first here?
Sure. So I think the end game is a fully automated blockchain where the user is able to express high-level preferences, and everything else is transparently executed for the user. Right? So, user experience is something that we actually at Okto kind of obsess about. I mean, that's kind of the mission statement with which we actually started off the whole project, with the whole premise that the experience for both the end users as well as for the developers is actually not sorted in the Web3 ecosystem, and that is probably the biggest blocker to mass adoption of the entire product, the ecosystem. While we love the decentralized principles and the whole concept about how people have power in their hand, the trustless ecosystem, we are not never be able to bring the actual value, the true power of it in the hands of the masses unless the experience is sorted for both end users as well as for the developers. So what's the end state? I think end state is fully automated. For example, if you look at sexes, right? Sexes actually solve this in certain ways. Right? For example, if you have to interact with a sex today, it's fairly simple. For example, if I want to swap, or if I want to buy, if I want to sell, it's all single click of button, everything is sorted. But what is not solved there? What's not solved there is decentralization, right? So it has centralization risk, it has centralization problems, and we have seen often, we have seen fairly commonly that the centralization risk actually plays itself out in the ecosystem. And so an end state would be what you would see in the Web 2 world. For example, how I hit the like button in an Instagram, and I don't care about whether a socket protocol sockets are being used, whether it's an HTTP connection, whether JSONs are used. I don't really care about any of that as an end user, right? In similar fashion, in the end state that we have, people will not care about what my liquidity solution is, where my liquidity is lying, what my networks are, what my protocols are. All I'm going to do is I'm going to express high-level intent, give my preferences, and everything else will be automatically sorted while maintaining the principles of decentralization, security, and trustless execution that defines the very principle of the Web3 ecosystem.
Yeah, I mean, to your point, like, if we weren't building or fully decentralized solutions, everything would be easier, right? Like we don't build these things because they're easy. We build them because they're needed.
Because those are very hard to solve problems.
Yeah,
right?
I mean,
how do you build a fully decentralized, trustless
Right.
ecosystem and yet give that the experience that you want to build?
Yeah. No, my point is like we're in the blockchain space for a reason. We're not building Web 2 solutions all the time. It's not always as easy as decentralized 100% of the time. So I agree with like kind of what Okto's
Exactly, and I think we are at one of those curve points, pretty similar to how we didn't know how to send an email over a network, right? I mean, that was a hard to solve problem. But today, that's not a very difficult problem to solve in the Web 2 world. In the Web 3 ecosystem, I think we are at that curve. And I do think that in the next 3 to 5 years, we would have actually solved a lot of problems which will make some of the further building for developers much easier, right? For example, when we say that we want to solve for user experience while also solving for developer experience, the real problems will be solved. People will be able to focus on building their business logics, actually being able to solve and crack for user problems when they don't have to worry about solving the problems of the infrastructure, where they don't have to worry about solving the problems of the platform. And I personally believe that we are at that curve. And as soon as we have crossed that curve is when I think the mass adoption will come in through mass solving of use cases that go beyond, say, for example, financial intents to generic intents.
Yeah, and my one-word answer to the question, though, is it should be invisible. The end state of UX in multi-chain world is it's invisible. The user has an intent, the user presses a button and signs once, and the user gets their outcome. And whether that's a developer who's built that experience or an AI agent who has vibe-coded the app for them because it didn't exist and provided that outcome, whatever gets there first, right?
So the end game is chainlessness. So the end game of user experience is chainlessness. Like
Yeah,
you won't
it's
know.
like
No.
pure agnosticism. You don't know where it's. You go to an app, you don't know if it's in Cosmos, if it's in Ethereum, if it's bridging, if it's got to do some complicated validation behind it. You don't know the network security exactly.
That's amazing. So that brings me to my last question. Like that's a pretty interesting one that I want to know. Like, how do you think like narratives like AI fit into Web3?
I have a few ideas. So like I talked about it, like agentic frameworks that utilize AI. I mean, I think we're not far away from, and this is what's interesting about orchestration and building orchestration solutions. There's an opportunity for orchestration builders to create like digestible, composable, reusable components that an AI agent could integrate and deliver that user's intent. So, if we are creating these things in the right way, and if they're maybe if they're lightweight, what's stopping an AI agent delivering that user's intent by using that orchestration and perhaps building the app that sits on top of it? And what's also interesting is with wallets, like maybe wallets just become an interface for an AI agent, and you direct it, you give it its power, you trust it, you say, I want to complete this intent, and users stop interacting with wallets altogether because they trust their AI agent, and it's just an interface for authentication and signing. So.
Sure, pretty much. I think it'll be about improved efficiency and usability. So what an AI agent could actually do is learn on top of all the user behaviors. So for example, you are actually trying to solve for an intent in your various path. An AI agent could actually determine which is the most efficient path and keep optimizing it dynamically, as an example, right? Similarly, on a usability front, for example, if you had a wallet, and if you could give a very high-level intent and then have the AI agent actually understand what the intent of the intent is, and then do the execution for the intent at the solvers, then you could actually have an AI agent solve for usability too. So I think from a usability and efficiency standpoint, AI agents could actually play a very big role once we have actually solved for the abstraction and coordination, because in absence of abstraction and coordination, even an AI agent would find it very difficult to coordinate across multiple chains.
That's amazing. Thanks a lot, guys, for this session. We learned a lot about user experience today. So happy to host you guys today. Yeah.
Pleasure to be here. Thank you.
Thank you.
Old to speak, young as each block mine down. Professor Wade's got the future on spin. Urging notes, dancing where the bottlenecks been. Professor Wade's got the future on spin. Plugging tomorrow with yesterday's RAM stains. test for Boodle. Just dreamers, on-chain truth, no middle schemers, forking hard and shipping code till sunrise every day. DAOs are voting, vibes are flowing, buff-eyed corns are still a-growing. While the world is breaking down, we're regen in a new way. Some VC said this tech won't last, and the hurt bubble, watch it crash. But we don't need your central banks, 'cause regen biddlers stacking stacks. For we biddy led this city on sports and chains. We biddy led this city with regen brains. We biddy led this city on sports and chains. No rug pulls, just pure on chain. Whale pools floating, fees are burning.